Plant Genetic Resources, New Delhi, and MS Swaminathan School of Agriculture, supported by the Faculty of Applied Sciences and Biotechnology, Shoolini University. We should clap. Now, I would like to request our respected chief guest, Dr. R.S. Paroda, and all the dignitaries on the dais for the traditional lamp lighting ceremony to officially inaugurate this event.
सरस्वती मात पिता तुम अखिल जगत की मात पिता तुम अखिल जगत की वंदना करूं शारदा सरस्वती वंदना करूं शारदा सरस्वती हम सब बालक शरण तिहारी दया जननी तुम्हारी शरण आज बखाई सब मात पिता तुम अखिल जगत की मात पिता तुम अखिल जगत की वंदना करूं शारदा सरस्वती वंदना करूं शारदा सरस्वती वंदना करूं वंदना करूं शारदा सरस्वती.
Thank you all for gracing us with your presence and initiating this ceremony. A special thanks to the students for this beautiful Saraswati Vandana. A big round of applause, please. I will now request Professor P.K. Khosla, Chancellor, Shoolini University, to felicitate Dr. R.S. Paroda, President, ISPGR, and Chairman, TAS, New Delhi, with Himachali cap, mufflers, and planters. Thank you, sir. I would now like to request Professor Atul Khosla, Vice Chancellor, Shoolini University, to welcome our respected guest of honor, Dr. P.L. Gautam, Chancellor, Dr. R.P., CAU, Pusa, Bihar. Thank you, sir. I would now like to request Professor Atul Khosla, sir, to welcome respected guest of honor, Dr. Sanjay Kumar, Chairman, ASRB, New Delhi. Thank you, sir. I would now request Dr. Anuradha Agarwal, General Secretary, ISPGR, and Organizing Secretary, PBFSNWH, New Delhi, to felicitate and welcome Professor P.K. Khosla, sir. Thank you, ma'am and sir. I would now also request Dr. Anuradha Agarwal to welcome Professor Atul Khosla. Thank you. I would like to request Professor Y.S. Negi, Dean M.S. Swaminathan, School of Agriculture, to welcome Dr. Anuradha Agarwal. Thank you, everyone, for gracing us with your presence. Your presence today has added immense value to our event, and we are truly honored to have you here. Ladies and gentlemen, distinguished guests and participants, it is with great pleasure I welcome Vice Chancellor, Shoolini University, Professor Atul Khosla, to the stage to deliver the welcome address. May I kindly request, sir, to join us on the stage for the welcome address.
Thank you. Thank you very much. And what an exciting day it is today. I was so excited that I wore a colorful, very colorful sweater. I thought I need to bring in color to the day today. Unfortunately, the sun is not out, but I hope the blessings of the gods will be there on us and to everyone in Himachal and the Himalayas. So welcome to the National Seminar on Plant Biodiversity for Food, Nutrition, Health and Security. I think the focus is North-West Himalayas, which is apt. I'll have to start by saying that I am not an agriculture scientist, so apologies for that. I'm not going to talk about agriculture, but as a keen student of economics, I think there's a strong correlation between economics and agriculture, and I'd love to just leave a few thoughts for the day and for the 2 days for us. But before that, I'd like to welcome all our esteemed guests. We have luminaries of ICAR, agriculture, plant sciences, and the environment of India over here, not just India, but I think internationally over here. So welcome, Dr. Paroda. You're like an uncle to me, and so lovely to have you here. Dr. Gautam, Dr. Sanjay, you've been here before, so thank you for being here again. Anuradha for giving us the opportunity. Dr. Agarwal and every other luminary who's here today. Welcome to Shoolini. Welcome to this beautiful seminar. Like I said, the topic is so apt. The topic is apt because, in my opinion, my humble opinion, if we think about the Himalayas and we think about Afghanistan to the east of the Himalayas, there are very few pockets of peace that exist around the Himalayas. Possibly Himachal, Uttarakhand, and a couple of others, Bhutan, Nepal. But there is significant amount of strife, civil strife, military strife that exists in the Himalayas, and there's a reason for that. And I think the reason is a huge battle that's happening between the desires of economic growth of the people in the region and a denudation of the economic and the biodiversity resources that's happening along with it. So when we start thinking about biodiversity as scientists, as environmentalists, what I would request all of us to do also is to start understanding the economic demands or the economic aspirations of the people who live in this part of the country. So I was in a meeting recently with the government, with the chief secretary, and this whole point about agriculture land available in Himachal came about. And I'm told that 60% of land in Himachal, for example, is reserved for forests. So if 60% of land is reserved for forests, very clearly we are pushing our people towards a situation where they are disadvantaged economically compared to people in the plains. Simultaneously, we also demand that they should not do mining, they should protect the environment, they should make sure that Himachal and the Himalayas continue to be a beautiful state. And this is fundamentally contradictory to each other. So how do we protect the biodiversity of the Himalayas, which is so important, while simultaneously give economic advantages and benefits to the people of these particular states? So I lived many years in Switzerland, and I'm going to talk a little bit about Switzerland and Himachal, for example. Both are very similar countries, if you would call it, or very similar in terms of demographics, very similar in terms of topography. So demographics, give and take, Himachal is 7 million. So is Switzerland. We are a hilly state. Switzerland is a hilly country. Now let's compare the economics between Switzerland and Himachal. Himachal, give and take, is a $25 billion economy in terms of GDP. Switzerland is a $900 billion economy, which means everyone sitting in Switzerland is 30 times or more richer than everyone sitting in Himachal. So the fundamental question now is, how can the economists give accelerated growth to the people of this particular state or the Himalayas to ensure that they become more economically prosperous, and as a result, they start becoming more aware about the biodiversity and the environment and cater to these. And the answer, I think, is not that difficult. The answer is simple, and I'll break it down into 3 categories. Category number 1 is the industries that we promote. So if you think about Switzerland again, they are exactly disadvantaged to Germany and France. Germany, like Punjab, is plain. They've got large fields of wheat. They've got access to minerals. Switzerland doesn't. France is exactly the same. Italy is exactly the same. So if you think about industry in Switzerland, it is advantaged to Switzerland. They do high value manufacturing. So your lovely, beautiful watches that we call them Swiss watches come from Switzerland. They're very evolved in the service industry. We've all heard about the Swiss banks. And there's a reason why they promoted the Swiss banks, and they promoted privacy because they wanted to protect themselves from the Germans. So the whole world was putting money into Switzerland. So that's another area that they evolved. Biotechnology is very large in a place called Zug. There's a lot of innovation happening over there. Large number of entrepreneurs coming into Switzerland. And I think that's a fundamental question, along with, as we start answering the question of biodiversity, we should ask ourselves, can we give a differential economic growth to the Western Himalayas as we think about protecting the biodiversity of this particular part of the country? So that's the economic side to it. The second side to it is, and this is for my dear friends from ICER, is how we run horticulture and agriculture. But if you go around Himachal, and like I said, I'm not an agriculture scientist, I'm like just talking as an informed economist, I do not see smart agriculture anywhere. I do not see the extent of use of technology that we should. And that's the only way that the Himalayan people can be more competitive compared to people from the plains, which is the use of technology. So my request over here would be to all you sirs and ma'ams, luminaries of agriculture, do not put the same lens of agriculture on on institutions or the farmers living over here. Small example, and don't mind it, sir, Dr. Agarwal. We had a committee which came from Palampur to evaluate our agriculture program. And the first thing they asked is, show us the wheat fields. And I was scratching my head and said, why should we be cultivating wheat? We should be cultivating things which are economically superior to people in Himachal. And I think that's a change somewhere that needs to happen. And hopefully we'll be debating these. And like I said, the reason I'm mentioning all of this is because ultimately my belief is biodiversity and economics are very deeply entangled with each other. If you can solve the economic rationale of these parts of the world, we'll also be able to talk about we'll also be able to solve biodiversity. Ultimately, everything is economic in this world. The last suggestion or thought I have is about subsidy. And that's something, again, I've been talking a lot with my state government, which is, why should we not demand subsidy from people from Punjab, for example? If we are protecting the trees of India, if we are protecting the plains of India, and if we are protecting the biodiversity of the country, which I think we are planning to through the symposium, then why should we not be demanding subsidy from the government of India? Now, the unfortunate part of politics is that Himachal, Uttarakhand, and other states along the Himalayan region are very small states. So politically, they don't make any sense for the central government to support us. So somewhere, I think as intellectuals, we need to push towards the central government and start seeking subsidy for ensuring that people in this region protect the biodiversity of this region, so that people in the world can remain happy, people in the world can remain environmentally conscious, and we ensure that we can protect this very fragile ecosystem and not do what we have done to the roads over here. I think all of you came from Chandigarh and you've seen how badly we have constructed roads because we brought in the same technology we used for building roads in the plains into the Himalayas, which is absolutely not appropriate. So I think with that, really what my thought and my message to all of us is, along with environment, along with science, technology is important. Technology of building roads, of agriculture, and economics is very, very important. And hopefully, I think during the 2 days, we'll be talking about these very interesting issues. And hopefully, we'll be taking them to the government and to the politicians to make them aware that if we don't do these particular initiatives, then clearly there will be challenges going forward and all of India will be impacted. So once again, sir, thank you for bringing the seminar to Shoolini, to the Himalayas. Thank you, all of you, for visiting us, and hopefully all of you will have a wonderful days. Have a great day, and Jai Hind.
Thank you, sir, for your inspiring words. Your leadership continues to be a model of guidance and inspiration for all of us. Now, ladies and gentlemen, I would request Dr. Sanjay Kumar, Chairman, ASRB New Delhi, to grace the stage and share his profound knowledge and experience with us. A big round of applause, please. Over to you, sir.
A very good morning and happy Guru Parv to all of you. Honorable Dr. R.S. Paroda ji and Mrs. Paroda, Professor P.L. Gautam ji, Professor Khosla Sahab, Madam Khosla ji, Dr. Atul Khosla, Vice Chancellor, Honorable Vice Chancellor of this university. I could see Professor S.K. Sharma also a few minutes back on the screen. I think he was also joined online. So if he is still there online, I was very happy to see him. He was there online. In the hall, we see Professor Dhillon, Dr. Tyagi, and all distinguished Dr. Vats and all other distinguished gathering. And very important, our young generation, who will be the torch bearer, particularly for this seminar and whatever learning we get from here. Sir, I must share with you, around 33 years I spent in Himachal Pradesh and trying to understand the biodiversity in this zone. One thing was very sure, what we used to study, that People evolved along with the biodiversity. Humanity evolved along with the biodiversity, and it was very true here. We went to remote places of Himachal, and people were still using the black peas and the hulled barley for their diets. It was their support. We realized that high altitude, you have buckwheat, all nutrition. You have sea buckthorn, and people are utilizing it and using it. And as Dr. Khosla mentioned, that we should talk of technology. I think very pertinent point. We should make use of the technology. And at the same time, sir, my feeling was when I went further in Himachal, there was, you name a disease and you have a cure for that disease because we evolved with that diversity. For example, if you have liver problem, you know, we have Picroiza curva with you. All our children, they were given message with Dabar Lal Tel. And what that Lal Tel has, Arnibia euchroma. And today you try to find Arnibia euchroma, you hardly find Arnibia euchroma. You have a problem with fever, you know, you have aconitum. So you name a situation and you have the cure for that. And probably that created the problem also. We started harvesting it and we forgot that we need to conserve it and propagate it. So my first feel was, I think, sir, through this seminar, if you can say that, although we have Institute of ICR, we have Institute of CSIR, we have universities, but still I feel a concerted effort on the biodiversity conservation, propagation, and sustained utilization. I think as a policy matter, if you have this, it will make a sea change the way we are seeing the biodiversity of Himalayas. And I think we should not forget what we have in Himalayas, we don't have anywhere else. That we should not forget. For example, red rice, you will find here, not anywhere else. Just to give you one example, for that for which we have the GI tag also. Second, I also feel, sir, you know, if you go Himalayas, you find like protective areas, like GHNPs are there, Great Himalayan National Park. We went to Spiti area and there was a patch in Kibbar village. A lot of Arnibia used to grow there. People used to go and harvest it. In 1990, when I went for the first time, we saw lush green Arnibia euchroma. And in 2012, when I went, there were hardly one or two plants in that zone. I wonder, why don't we create such corridors of protected plant also in the zone so that we allow plant to propagate themselves naturally? So I think my second feel was that there should be some provision of protected corridors, particularly for these plants. Certain, that will make a lot of difference. That's what my feeling was. Third thing, we went to certain farmers and they were growing all the wild varieties. And they were telling that now they started shifted to peas and cauliflowers, and the area under those classical varieties is going down. And sir, you yourself are leader in this area. Whenever agriculture faced any problem, it is the wild varieties which came to our rescue. And sir, numerous examples are there. And that wild varieties, who were the protectors? Those farmers. Can we develop a policy to incentivize some of those farmers who are practicing this? And if we give them the economic value of protection, incentivization of protection versus the advantage that they give to the agriculture in terms of crisis, I think the figure will be mind-boggling, and maybe we are spending 100 crores and that gives us advantage of maybe several lakhs of crores. I think that advantage, sir, we have seen. Third thing, I also believe, particularly, sir, since you are talking of Northwestern Himalayas, sir, our traditional knowledge and plant diversity, it goes hand in hand. Although we have certain institutions which are working on traditional knowledge, but our activities is mostly making on databases. There are few efforts. We are going beyond databases, going from what a XYZ plant does, what is the mechanism of action, how we can take that plant to the final product formation. So you might remember, sir, in 2020 in Ahmedabad, WHO opened a world center for traditional knowledge research because they want to see that whatever across the world, across the globe, whatever traditional practices is being practiced, it should reach to the general public. In Himachal, although few institutions are there, few labs are there, we have one Ayurvedic college also. But do we have this approach that we take traditional knowledge from knowledge to money making? Which Dr. Khosla was also mentioning that unless there is an economic sense, why people will conserve? Sir, you might remember Dr. Pushpagandan in Kerala with that Kani tribe, how he converted that knowledge into the economic value. And today everybody is using it, tribe is protecting it, and they are leading a very good life. They change the whole livelihood scenario. So in Himachal, we know that, for example, rhodiola does a wonderful job. Sea buckthorn does a wonderful job. We all know it. But we could not convert that traditional knowledge into a solid outcome. So unless we have such centers which talk of converting this traditional knowledge into the product should be like that, if you take 500 milligram of paracetamol, it subsides your pain. It should be something like that. It should not be khaliya dekhenge kuch hoga theek to. I think we should not be to that extent. And I think our Ayurvedic plant have that traditional knowledge, has that potential. Example is bhang. You take bhang, it does work because there is no contamination in that, right? But when it comes to traditional medicine, people say it doesn't work. So I think we need to think something on that line. And here also I feel, sir, very strong involvement of our community is mandatory. Whether these is our youngsters, whether it's the villagers, I think involvement of community is mandatory. Research institutions or universities alone cannot achieve this. Second, I believe, sir, we have so many advertisements on television and radios. How many advertisements we have about the public awareness on the biodiversity? How many? Hardly any. I think maybe we spend few crores of lakhs of money. I think it will change the way we are perceiving this biodiversity scenario. Today, sir, even if you talk of baseline data, people will say we have some baseline data. Some have say we covered 40% of Himachal Pradesh. Some will say we covered 50% of Himachal Pradesh. Do we have any scheme where we are forcefully and we are ensuring in a mission mode? I think behind all that, if we work on a mission mode that in 10 years from today, we will be giving you this. Otherwise, sir, everything will just keep on, we are doing. We are always present continuous tense, not in past perfect tense. So for that, I think mission mode approach is mandatory and necessary. And sir, moment we say that our traditional knowledge is important, moment we commercialize it, a strong market linkage is very important. For example, in Himachal, we already have HPMC, for example, and something beyond that we can think of creating as a sort of market linkage. And unless we have that market linkage, complete supply chain to the end point, I think it will be difficult. So, sir, these were some of my views as an opening statement, particularly for biodiversity, our ecosystem sustenance, and sustenance of our humanity, particularly under this climate change scenario. I think we should take it very seriously. And students should also, they are the youngsters who will take this country forward. They have more of such responsibilities. We are always there to help you. Any guidance you need from us or anything is there that you want to take such activities forward. Thank you so much. And once again, I must thank Professor Paroda sir and Professor Gautam sir to giving this opportunity to share some of my thoughts. And I congratulate the society for taking such an important mission for this important state. Thank you so much.
Thank you, sir, for your gracious presence and for sharing your valuable insights with all of us. Ladies and gentlemen, please join in extending a warm invitation to Dr. P.L. Gautam, Chancellor Dr. R.P., CAU, Pusa, Bihar, to join us on the stage and share his invaluable insights with their lovely audience. Over to you, sir.
The chief guest of this inaugural function, Dr. R.S. Baroda ji, Mrs. Baroda, the architect behind the entire show, Dr. Khosla and Mrs. Khosla, our guest of honor, Dr. Sanjay Kumar ji. In the audience, we have very distinguished personalities. There is a need to really mention few, starting with Dr. Bus, the Vice Chancellor of Palampur University, Dr. Tyagi, the Vice President of the Society, our very distinguished person, Dr. Dhillon, who was Vice Chancellor and earlier Director of NBPGR, our esteemed young colleague, Dr. R.C. Agrawal, who is steering the education in agriculture in a big way. I see many people here, my own old colleague, Dr. Negi, Dr. Lakshmi Kumar. I was seeing here the DRDO gentleman, I think he's gone out. Dr. Chaurasia, he is also present. From Biodiversity International, we have Rana. And I am very happy to see B.D. Sharma. B.D. Sharma, can you hear me? Yes, he's one of the person who has a lot of work in the Himalayan biodiversity. There are many familiar faces, starting from Puri to Gopal, and all of you. You are all familiar, look very familiar faces. And it will be not possible to really name you all, but we will be meeting in subsequent sections and will greet and also exchange our pleasantries. We had two very enlightening speeches before me. And I would like to avoid the duplication from that. And I know that we have the chief guest, who is international authority in this area. So I would also not like to preempt the ideas and directions which he'll be giving. But I must say that when we were trying to persuade that where to hold the regional conference, and it was to be held in North-West Himalaya, we looked for locations, and it was so nice of Dr. Khosla that he responded to our call and give this opportunity to have this event here. In fact, Dr. Baroda asked me that you will decide the venue. And I had many choices, preferences, limitations of other institutions. But we wanted to see that how private and public sector institutions can sit together and understand the common cause for which we have to work a lot. I take you back to 1998. We had national dialogue on agrobiodiversity in CPRI Shimla. I hope somebody is there also from CPRI. And I must say that dialogue had been so successful that it produced the policy paper for management of agrobiodiversity in the country. And it has led to many developments in terms of legislations, in terms of the policies, and much more. But the mission mode program Dr. Sanjay Kumar has mentioned, that was also born out of that thinking that plant biodiversity is very important, and we should really try to come together and have a very, very big mission. And I think it was one of the highly supported program under NATP, that agrobiodiversity conservation, where about 200 institutions were involved. Now, when we think of these initiatives like regional conferences, here the focus is that Himalayas are very important repositories for biodiversity. And the biodiversity is losing at a very alarming rate. Reasons mentioned by Dr. Atul Khosla, right from the destructions which are happening. There are other many reasons, including the invasive alien species. They are also creating a lot of havoc in destroying our biodiversity. In terms of overconsumption, overproduction, unscientific harvesting, and monoculture, many things can be cited which are responsible for the loss of biodiversity in this part of the world. I don't want to say that why Himalayas are important, and that has been mentioned. So looking into the importance of the Himalayas and the wealth of fauna and flora which is existing in this region, there is a special focus required. That is why we are here. And in this regard, I should share with you that a little bit of background for particularly for the students. Up to 1992, the biodiversity was a common heritage of global community. This was the lesson being taught to those people who have studied biology at that time. But when the world over it was realized that environmental concerns, including biodiversity degradation, is a very, very serious problem, and it requires global attention. That is why the global level, the Convention on Biodiversity was adopted. And the main plank of that is that you have sovereign rights on your biodiversity. We are no more now talking about this is a common heritage of humankind. Now every country has rights on the bioresources which they are having. So that is the responsibility, that how to really, first is, how do we say that this is our biodiversity? That is where documentation is very important. How to say that this is our variety? And you may be familiar about new words and terminologies which have come. Biopiracy. This started with the problem of biopiracy, that biopiracy is theft of biological material without your information. Physical theft, you know, but biological theft is very, very important, and you are supposed to know this part also. And for that, how to say that this is your property? Now that is where you have to document. You have to document properly, conserve it, preserve it, and characterize it. So that is our responsibility, to say that this is our. Then you have to have enabling legislative mechanisms. You have to have the legal force to say and protect your biodiversity. For that, the nation has enacted legislations. The legislation like Biodiversity Act, where conservation, sustainable use, and fair and equitable sharing of benefits coming from biodiversity has been very nicely highlighted. And that is where we will discuss these things when I have a session separately. And then protection of plant varieties and farmers' right legislation, which provides rights to the farmers also to register the varieties. And I must talk about this here, that Himachal had been doing very well in this, the registration of farmers' varieties. And one farmer variety, the apple, was first time registered in this authority from Himachal itself. And Harman 99 is the variety which stands registered as a farmer's variety. And there are red rices. For conservation of red rices, the Genome Saviors Award have been given. So there are ways and mechanisms for protecting the biowealth and your varieties. At the same time, there are ways for promoting the commercialization part also. So there are then GI tags. Many of the Himachali products are now getting GI tags also. That is also a soft kind of protection for your materials. And I mention was made about economy, how to link with the economy and all these things. Globally, now we are talking of TEEB, the ecosystem and the economy and ecosystem services of biodiversity. So globally, now this is being talked about. And that is where we will be devoting time, that how to, there is a session devoted here, entrepreneurship development. How do we take advantage of developments nationally and internationally for that purpose? This is a very big area where we can go on talking and sharing the things, but we will have sessions. The session cover different aspects of biodiversity conservation relating to Himalayas. And I'm sure the participation of young generation with the experienced people here will make a good recommendations to be followed further. Rather, I was thinking that we should also bring out a policy paper emanating out of our discussions and deliberations, which will be helpful for further policy refinements. And the awareness generation, which Dr. Sanjay has also mentioned. I think these are areas which will require the concerted efforts and resources. Without taking more time, I thank Dr. Paroda for reposing faith in me to have this organization of this seminar in this place. And I feel very happy that Anuradha and Tyagi had been always, and Mohar Singh, a gentleman who has done a lot of good work in this. They had been, time and again saying how to go ahead about this. I'm very happy that things today have materialized into a very, very successful organization of this seminar. Thank you, Dr. Khosla, for all the help. Thank you all the best. We look forward for a very interesting discussion. Thank you very much.
Thank you, sir, for your gracious presence and for sharing your valuable insights with all of us. Ladies and gentlemen, please join me in extending a warm welcome to Professor P.K. Khosla, Chancellor, Shoolini University, to join us on the stage and share his valuable insights with our lovely audience. Over to you, sir.
Dr. Paroda, the most respected, I would say, the farm scientist among us. We have to learn a lot from his experience. Dr. Gautam, and the audience, Dr. Dhillon, Dr. Tyagi, Dr. Vats, Dr. Agarwal, Anuradha, Dr. Sanjay, and many more. Thank you very much for coming to Shoolini University on a seminar which is on a very vital subject, issue which concerns everyone, food and health security from our biodiversity. Friends, my association with the Himalayas goes back to 1968, when as a doctoral student from Punjab University, Chandigarh, my professor sent me to the Himalayan region, East Himalayas, Darjeeling. I was to study the trees, their chromosomal systems. We were 4 of us. 9 months we were staying in the mountains. For 3 or 4 years we stayed there. So my knowledge or my association with the plants, biodiversity, flora, that has gone in a way in my genes. After that, I continued working on trees, became the forestry scientist because my award of Commonwealth Award, postdoc award was in forest science. And then from Chandigarh, I shifted to Himachal Pradesh, and since then I'm here. All the time thinking what far the Himalayas are. I have been openly saying that Himalayas are not meant for crop cultivation. We should look at our flora and copy what is the nature has given. And also the system what nature has given. Nature has never given us that we clear the lands and cultivate crops. Nature has given that we develop that three-tier system, the tall trees, shrubs, small trees and bushes, and the ground floor where we should have the useful and economic plants, in other terms, the medicinal and aromatic plants. In my academic career as a teacher or as a student, I have always been talking about three-dimensional crop system, tree crop animal system. Times have changed. Population pressure is there. And much has not changed, I would say. If the changes have come, we have not been able to meet the population pressures or the people's needs from the Himalayan region. We had been very selfish. We have not been loving the conservation of the plants which are growing in the Himalayan region. So this seminar itself is self-explanatory. Before me, two speakers have already elaborated the theme. I need not go to the theme. I welcome everyone here in the hall, the students, the teachers, and the scholarly persons. A host of them I know personally, while the younger generation, I would be knowing and meeting people during lunch hours or later. But our Shoolini University promises that, because Shoolini University has come because of my efforts, after having served as a Vice Chancellor Agriculture University, Palampur, then as advisor to the government, I was wondering what I will do after my tenure as advisor. Then I was 64. I thought of entering into private education, and the process of growth, this university is the end product of that. And in the university, this university laid emphasis on research. So this has come up as a research-centric university. And 2022, when all of a sudden somebody rang me that in Times Higher Education world ranking system, Shoolini University, as a debutant university, has emerged as the second best in the country. That was the first time we became eligible only on the strength of research. Only on the strength of research. Because my colleagues have studied each and everything, they knew that 30 marks are allocated to research, 30 to teaching and learning, and 30 to miscellaneous aspects. And because of their efforts of publication in the high-end journals, the high-impact journals, and the better scoring and other things, citations per paper had gone very high. So Shoolini University has come up as a research-centric university. Many times I wonder why other universities cannot do. Even I very recently chaired one of the panel discussions with the chairman UGC. The issue was also there. Why I was made to there? Because my conversations with the ranking system, perhaps the ICR of the UGC thought that Dr. Khosla would be the appropriate person for this type of a discussion. The reservations are still there. I, as a nationalist, feel that we are 140 crore people in this country, and our topmost university is not even among 200 universities. It pains me. I know that ranking is not everything, but why should we second to anybody? My concern is this. So it is for the youngsters, people, friends, students, teachers. So do applied things, but do not ignore the academic part of higher education, because after all, it is a competitive world. We have to compete with other people. And India as a country, I've heard the speech of the Prime Minister. He said, we are very happy this time ever, so many universities are figured. Nobody talks about the quality. We are only talking about the quantity also in the higher education. So I think differently, because I think we should be among the education is that we should have a place among the top 10 universities of the world. I know it will take time, but dream that way. Today we are not among first 200 even universities, whether it is the QS or in the Times Higher Education. These are the world university ranking. But Shoolini University is making its own progress, but it takes time. For the private university, it's very difficult, because 30 marks are for perception, and nobody will give this type of share of marks to the private universities. Thank you very much. You have all come here, and I assure you, Shoolini University will do its best under the leadership of our young Vice Chancellor, Atal Khosla, and my colleagues, Dr. Puri, Dr. Julka, and many more are sitting here. We will do our best to ensure that the Shoolini University shines to the best of its ability. Thank you very much.
Thank you, sir, for your inspiring words. Your leadership continues to be a model of guidance and inspiration for all of us. Ladies and gentlemen, with great pleasure, as we commence towards the insightful session, it is my privilege to invite the chief guest, Dr. R.S. Paroda, sir, for the release of souvenir of National Seminar on Plant Biodiversity for Food, Nutrition and Health Security in North-West Himalayas, compiled by Dr. Manjusha Verma, Dr. Mohar Singh, Dr. Jyoti Kumari, Dr. Sherry Jacob, Dr. Padmavati, Dr. Santanu Mukherjee, Professor Y.S. Negi, Professor Saurav Kulshrestha, Dr. Monica, and Dr. Kuldeep Tripathi, and published by ISPGR. This publication contains the key messages from the Governor, Himachal Pradesh. I'll invite all the editors associated with the publication, please, to come on the stage. Dr. Manjusha Verma, Dr. Mohar Singh, Dr. Jyoti Kumari, Dr. Sherry Jacob, Dr. Padmavati, Dr. Santanu Mukherjee, Professor Y.S. Negi, Professor Saurav Kulshrestha, Dr. Monica, and Dr. Kuldeep Tripathi. This publication contains the key messages from the Governor, Himachal Pradesh, other ministers and dignitaries. It also contains articles from the invited speakers. Thank you, everyone. May I now request the respected dignitaries for the official release of the book entitled French Bean Diseases, compiled by Dr. S.K. Gupta and Dr. Monica Sharma. I invite the editors to please come on the stage. A big round of applause, please. Thank you, everyone. We are delighted to present the e-abstract book of the National Seminar on Plant Biodiversity for Food, Nutrition and Health Security in North-West Himalayas, compiled by Dr. Anuradha Agarwal, Dr. Monica Singh, Dr. Kuldeep Tripathi, Dr. Vartika Srivastava, Dr. R.K. Parmati, and Dr. Narendra Negi, which contains more than 80 abstracts. The book of the abstracts, a big round of applause, please.
Audio Jungle. Audio Jungle. Audio Jungle. Audio Jungle.
The book of the abstract projects to provide a roadmap to enhance food and nutrition security for improved health through optimal, efficient, and sustainable use of Himalayan agrobiodiversity.
Audio Jungle.
Big round of applause, please. Thank you, everyone, and let the National Seminar on Plant Biodiversity for Food, Nutrition and Health Security in North-West Himalayas begin. A big round of applause. Ladies and gentlemen, distinguished guests and the participants, we have the distinct privilege of having a renowned personality among us today, who is also serving as the chief guest for today's event, Dr. R.S. Paroda. He's also serving as the President ISPGR and Chairman TAS, New Delhi. May I kindly request you, sir, to join us on the stage and share your insights. Thank you so much.
Honorable Chancellor, Professor Khosla, Vice Chancellor Atul Khosla ji, Dr. P.L. Gautam, my old colleague and friend, Dr. Sanjay Kumar ji, the Chairman, ASRB, Dr. B.S. Dillon, Dr. R.C. Agarwal, our Vice Presidents of the Society, Dr. Tyagi and Dr. Rana, Dr. Vats, Dr. Mohar Singh, Dr. Puri, Dr. Julka, Dr. Negi, and many other directors of the ICR and other ministries, institutions like Dr. Chaurasia. We have also Dr. Lakshmikant, Mrs. Saroj Khosla ji. I would fail if I don't also address my wife, Shashi Paroda. Dear young participants, ladies and gentlemen, it's a great pleasure for me to be here this morning and would like to, first of all, thank Professor Khosla for providing us this venue to host this conference. And much has been already said by Professor Gautam about the background of this particular conference. Many important issues have been raised. Since we are running late on time, and I have an evening lecture also relating to this particular subject of managing our agrobiodiversity, I would like to say that for me, today it is like a dream come true, and that too on the group Purab occasion. And would like to wish all the teachers who are here Guru Purnima, and nothing would have been more auspicious for it. We know we have to learn more about biodiversity. Globally, not much has yet been understood. Whatever we have, much has been said, is required to be conserved, also evaluated and used. On the contrary, we have been using it without much knowledge in the past, and now we have to be more sustainable. And somehow over the years, demographic pressure has created problems, not only for the environment, but also for the human health. And we have recently seen after COVID pandemic that nothing would help us unless we take care of our good health, good nutrition, and immunity. And for that, look for local food systems. And UN Council was held last year only on this account to recognize that for future food security, we will have to depend more on local food systems. We will have to go back to many of those plants which we used to consume. I come from Rajasthan. I used to consume many those plants or food which now nobody is in cooking or is available. That tells that there is definite need for having a relook. We need to diversify our food basket. And we have also to not only just conserve them for the sake of conservation and keeping these saviors of genetic resources at a lower end of economy, the mention of which was also rightly mentioned by both Saratji and also by Atul. And it is very critical that we try to take benefit of what we really possess. But to know that and do that and add value to it, you would require institutions of this kind. You would require scientific knowledge, and knowledge would only come through institutions. And I am so happy that for organizing this regional initiative, which we have now taken up, though we organized International Congress on Agrobiodiversity, inaugurated by Modi ji about 5 years ago. And when the Delhi Declaration came and biodiversity became an important, aspect of consideration globally, and the millets now being talked about when we are saying about, and mention was made of many plants, sea buckthorn, grain amaranth. Also, we have been using earlier buckwheat and kalatur. Now we are talking of soybean revolution, but in the hills, this soybean, black tur had been grown for years. But soybean originated from China. America worked on it and made all the benefits. And today, Brazil, Argentina, USA are reaping the benefits of that research. So we have to, in fact, it's not necessary that what has originated has to be only taken care of, but we can even work on other plants which we didn't have in the past. And I would say that in that context, farmers of Himachal Pradesh are much ahead of others. If I just cite you, 100 years ago, apple was not grown in Himachal Pradesh. In 1916, it was introduced by Stokes. And today, Himachal is apple state of the country. Economy of the state is on apple. So to say that we have not really capitalized on, and now kiwi is another example. So we will have to therefore think of what we can do, how we can benefit. Kiwi also originated from China, but New Zealand did research on it. And today, New Zealand is known as kiwi country by the name of kiwi itself. Oil palm came from Africa, but Malaysia worked on it. And today, Malaysia, Indonesia are the world leaders. So it's not what we have only, but to take advantage of what we have, because tomorrow the pressures are building, pressure of climate change, pressure which is already there due to the, degradation of natural resources. The kind of degradation we had this year in Himachal Pradesh is not imaginable at all. And because we have somehow over the years, due to demographic pressure, this balance between nature and the human got disturbed. And that was because of the pressure on for demand for food and demand for other items, demand for housing and whatnot. So you can't blame that, but we have to be now sure and more wiser in future to see that we have a strategy on which we work now jointly in a coordinated manner. And I'm so happy that most of the directors working in various ministries, whether it is science technology or CSIR, DSR, or in ICAR, they are all participating in this conference. Perhaps never this kind of thing must have happened or a platform provided. And a lot of work is going on. We will understand when we listen to them and their work. An international organization like Biodiversity International is also working. Dr. Gautam mentioned about gene saviors and the awards given by the authority. So a lot of things have happened, but possibly now time has come that we need to put our brains together, understand the problem more clearly, try to also understand the strength. And I am very clear in my mind that India possesses very rich biodiversity and especially agrobiodiversity. And for climate change, tomorrow, for whether it is you are going for adaptation pathway or for mitigation pathway, we will be the world leaders to provide the genes for tolerance to both stresses, biotic and abiotic. I have no doubt about it. The best salt-tolerant material in rice is in India, and best salt-tolerant wheat also is in India. Best drought-tolerant also in wheat, if you see, we have with us. And the best species, when you look at, you go to the desert, no other desert has that much of variability and genetic resources that we have in our country. And we are really blessed by the God for that purpose. And that's why we have sustained so much of population per unit of area. That would have not been possible. But we then have to be wiser to evaluate it. And for evaluation, you would need human resource, trained manpower. From where it will come? You will require universities. You will require more Professor Khosla to create such institutions. And you would require young people who will take this challenge. And challenge is there because we have come a long way. Food security we have today, but nutrition security is a challenge. Maximum malnourished children in the whole world today, compared to any other country, are in India, below 5 years of age. And we have the problem of environment. And we have to link ourselves to market, which was very rightly mentioned, because you can't just say that you save the plants because you are doing very good work, unless you provide them incentive for those environmental services. So we will require certain mechanisms. Now even mechanisms of carbon trading being evolved, the National Carbon Fund also being evolved. There are initiatives of more research to be done. We have to do it in a mission mode, and the time is ripe. We just can't come, sit and talk and then go. Perhaps this conference should provide us an opportunity that we need to act. Talking is not going to help, and for act, you can go on talking, but you have to really do something in a mission mode approach. And I remember under NATP, we had, I think, documentation and the National Action Plan and Mission. Dr. Gautam, you were there as director at that time of the institute. And Agarwal was also with you, and Dr. Tyagi and all these were, and Dr. Dhillon also then later on took over. We collected 2 lakh accessions of all genetic resources that we have in the country by great efforts of people like Dr. Harbhajan Singh in the last 20 to 30 years. And in just 5 years' time, in a mission mode approach, we added additional 2 lakh accessions, doubled them. So it's not that you cannot do it, but then you require effort and you require initiatives, you require institutions, and you require young people, and then issue of traditional knowledge. This traditional knowledge is very important. The public awareness was mentioned, is very important, because people should understand. In Rajasthan, we have a village where you just cannot go and cut a tree, especially called Khejdi, Prosopis area. People had given their blood to save those trees. And these are examples over there. And you cannot go and just kill the black buck. Salman Khan is still in trouble. Just because of that and because of that community. So there are people. It's not that, the people who want to really conserve. And that awareness has to be brought in among the people. And that awareness will come how? Who will provide this? Unless this knowledge gets, disseminated to those who have to act. And just by preaching will not help. We will have to show how it is going to work, how to conserve. Dr. Rana's program, they will be having the results here. Will also be telling that how you have to work to conserve these genetic resources and even have community gene banks. So it's not only one national gene bank. You have to have national gene bank, you have to have regional gene bank. And we have created the laws. Dr. Gautam is one person who was chairperson of both the authorities. I think that's a rare distinction. Congratulations to you. We are proud of it. And both authorities, we have now the rules, regulations, but these rule regulations should not come in the way of using these genetic resources for our own economic benefit. But economic benefit should be such that it is not over exploitation, and you are just not gatherers. Go in, medicinal plants have been talked. So much rich variability we have for medicinal plants, and how much knowledge we have on them and how much we are using. Everyone goes for allopathy. So Ayurvedic treatments, the awareness about those as well are all required. The sea buckthorn, I saw the work in Leh. Chaurasia, doctor will be also explaining the kind of work which is being done on millets in Almora. Lakshmikant will possibly tell us. And many plants, have come. Maize possibly was not originated in India, but maize is secondary, origin as far as we are concerned, but very good work being done, even on maize in the Himalayas, and they have great potential. So, other last point I would like to only say that we have to be globally wise, but we must now act locally. And for that, this is our great strength, the biodiversity, agro-biodiversity. And we must have centers of excellence for Himalayan biodiversity. That's what was my dream. I have been telling. I wish it either comes here on Shoolini campus or somewhere with the support of the government. And we must also catalyze the state governments to make sure that the state biodiversity board becomes more effective and functional as they are in other states, especially when you go to Kerala and when you look at their efforts which they are making over there. So it is a great pleasure for me to be here. We wanted some chief guest to be inaugurating today. Somehow all these policy makers are busy, and sometimes it is also more comfortable for us not to get stressed by having them, because I was given to understand that chief guest who had agreed said that I can come after 2 hours, and 2 hours we could have not waited. So I never thought that I would be considered chief guest. I'm the host actually, and I requested Professor Khosla and thank you, Dr. Gautam, for your leadership, for your initiative. You belong to this region, so no one else could have given us better advice as to how to organize this conference. Thank you to Dr. Sharad Kumar. You worked all your life in this region, and you agreed to come despite being very busy. So we appreciate that very much. And thank you to Professor Khosla. We had been dreaming it for last more than 5-6 years to organize this kind of conference. So it's a kind of, realization of that particular expectation that we had. And I hope the benefit will be there to younger generation, because we all know what we are doing, and probably we are at the fag end, most of us, of our career. But they have the challenges and they have to make use. And what you was saying, Atul, you are young, and I'm sure during your life over here in Shoolini, all those dreams of technology be converted into economy will be made true one day. Thank you.
Thank you, sir, for gracing us with your presence and for your remarkable contributions. Your presence today has added immense value to our event, and we are truly honored to have you here. Ladies and gentlemen, I would now request Dr. P.L. Gautam, Chancellor Dr. RPCAU Pusa, Bihar, to felicitate and welcome Dr. R.S. Paroda, President ISPGR and Chairman TAS, New Delhi, with a shawl and a memento. A big round of applause, please. Thank you. I would now request Dr. R.S. Paroda to welcome and felicitate Professor P.K. Khosla, Chancellor Shoolini University. A big round of applause, please. Thank you. I would now like to request Dr. R.K. Tyagi, Vice President ISPGR, to welcome and felicitate Dr. Sanjay Kumar, Chairman ASRB New Delhi. A big round of applause, please. Thank you. I would now like to request Dr. J.C. Rana, Vice President ISPGR, to felicitate Dr. P.L. Gautam, Chancellor, Dr. RPCAU, Pusa, Bihar. Thank you. I would now like to request Dr. Mohar Singh, Officer in Charge, NBPGR Regional Station Shimla, and Local Organizing Secretary of the seminar, to felicitate Professor Atul Khosla, Vice Chancellor, Shoolini University. Thank you. I would now like to request Professor Saurabh Kulsreshtra, Dean, Faculty of Applied Sciences and Biotechnology, to felicitate Dr. Anuradha Agarwal, General Secretary of the Indian Society of Plant Genetic Resources. Big round of applause, please. Thank you, respected dignitaries, for gracing this occasion with your valuable presence. Now I would like to invite Dr. Anuradha Agarwal, General Secretary of the Indian Society of Plant Genetic Resources and Organizing Secretary of PBFSNWH, to join us on the stage and deliver the vote of thanks on behalf of the organizing committee. Over to you, ma'am.
Thank you, Nikita. Respected dignitaries on the dais, President of ISPGR and Chairman TAS, Padma Bhushan Dr. R.S. Paroda, and Chief Guest of today's function, Founder and Chancellor of Shoolini University, Dr. P.K. Khosla, Chancellor of Dr. Rajendra Prasad, Central Agricultural University, Pusa, Bihar, Dr. P.L. Gautam, Chairman of the Agricultural Science Recruitment Board, Dr. Sanjay Kumar, Vice Chancellor of Shoolini University, Dr. Atul Khosla, all the distinguished dignitaries of the dais, and please allow me to take a few names. Dr. R.C. Agarwal, Dr. B.S. Dhillon, Dr. R.K. Tyagi, Dr. Vats, Dr. Chaurasia, Dr. Negi, Dr. J.C. Rana, Dr. Chahota, Mrs. Saroj Khosla, Mrs. Shashi Paroda, Dr. Lakshmi Kant, Dr. B.D. Sharma, our very senior colleague, Dr. Ashish Khosla, elder son of Dr. P.K. Khosla, and all other heads of division, senior faculty of Shoolini, my colleagues from ISPGR and NBPGR. On behalf of the organizers, the Indian Society of Plant Genetic Resources, the National Bureau of Plant Genetic Resources, Shoolini University, it is my privilege and honor to present a heartfelt vote of thanks on this gracious occasion. First and foremost, I would like to record gratitude to Honorable Health Minister, Government of Himachal Pradesh, Colonel Dr. Dhani Ram Shandalji, who had although agreed to come for this occasion, but as already mentioned, got delayed. We place on record his agreement to come to this occasion, although we missed his physical presence. Nonetheless, the inaugural has begun, and we thank all the dignitaries on the dais for starting the occasion in the most appropriate manner. Words are inadequate to express gratitude to the founder and current president of ISPGR, Dr. R.S. Paroda, for not only his insightful remarks today, but also being the driving force behind the organization of this national seminar and all other activities of ISPGR. So we are indeed blessed by your benevolent presence today, as well as for all the activities in the society, and look forward to your continuous guidance and support. A big round of applause for Dr. Paroda. We profoundly thank Dr. P.K. Khosla, founder and chancellor, for readily agreeing to host this national seminar in this beautiful and serene campus, the warm hospitality, and the enormous support extended in every way through his industrious team of staff and students. His dedication towards science and agriculture and the country are indeed worth emulating. So we thank you for your valuable support. And we give a big round of applause for Dr. Khosla also. We are extremely privileged to have amongst us today's guests of honors, both of whom have significantly contributed towards scientific and practical development of plants and agriculture of this Dev Bhumi, Himachal Pradesh. Profound thanks to Dr. Sanjay Kumar, chairperson of SRB, for taking time out from his hectic schedule and sharing his enormous words of wisdom. Of course, sir, we look forward to your plenary lecture immediately after this inaugural, where you will share your experience related to Himachal Pradesh biodiversity. Dr. P.L. Gautam, currently Chancellor of Dr. R.P. Central Agricultural University in Pusa, Bihar, and formerly Vice Chancellor of G.B. Pant Agricultural University of Pantnagar, and Chairperson, as already mentioned, of PPVFRA and NBA, is the son of the soil of Himachal Pradesh and an honorary fellow of ISPGR. He has been closely associated with the society activities for more than 25 years. So we profusely thank you for not only accepting invitation for this inaugural session to give your special remarks, but as already mentioned by Dr. Paroda, for the enormous support extended in the development of this program, especially the technical part of this seminar. We have all benefited from your insights and outstanding experience in this area. We place on record the support and encouragement by Dr. Himanshu Pathak, Secretary DARE and Director General ICR, Dr. Trilochan Mahapatra, Chairperson, PPV and FRA, and Dr. Gyanendra Pratap Singh, Director ICR and BPGR, towards the organization of this seminar as well as all ISPGR activities. We are very thankful for their blessings, although they could not join us due to other previous commitments. Vice Chancellor of Shoolini University, Dr. Khosla, is a man of action and results. So your dynamic leadership has facilitated greatly in the excellent technical and administrative support provided by your team in the organization of this seminar, and we are indeed grateful. Thank you for your warm support, hospitality and support. Congratulations to Shoolini University for getting ranked as #1 in India among all private universities and second rank among all Indian universities and institutes under the Times World Ranking for 2 parameters, research quality and international outlook. We wish Shoolini University to continue rising in its stature. Thanks are accorded to the entire Executive Council of ISPGR, especially the 2 Vice Presidents, Dr. R.K. Tyagi and Dr. J.C. Rana, for their support in shaping the program, and also Dr. Mohar Singh, Officer in charge of the regional station of NBPGR in Shimla, and especially Dr. Saurabh Kulshesh, Dean, Shoolini University, and Dr. Y.S. Negi, Dean, Shoolini University, along with their large team members who have made this program possible. A special word of thanks to our young members of the Executive Council of ISPGR, Dr. Monica Singh, Councillor North Zone, and Dr. Kuldeep Tripathi, Treasurer, for making this, taking a major chunk of this work related to organization of this seminar. In fact, the seminar has been possible due to the support and guidance from a very large number of persons and several organizations. And due to shortage of time, I will not take individual names. Nonetheless, we thank sincerely all the chairs and members of the National Advisory Committee, Core Organizing Committee, Technical Program Committee, Local Organizing Committee, staff of ISPGR, NBPGR, ICR, TAS, and of course, Shoolini University. We duly acknowledge the financial support received from the Protection of Plant Varieties and Farmers' Rights Authority, Alliance for Biodiversity International and CIAT New Delhi, Mahiko Private Limited, HP State Council for Science, Technology and Environment, Satluj Jal Vidyut Nigam, Shimla, NABARD, and Ambuja Cement Foundation. Knowledge partners are gratefully acknowledged, especially Trust for Advancement of Agricultural Science and the CSKHP Krishi Vishwavidyalaya Palampur and Dr. Y.S. Parmar University of Horticulture and Forestry, Solan. Most importantly, we thank all of you, delegates, speakers, co-chairs, and conveners who agreed to join us in this important event and will help us in making it a great success. The more than 175 delegates comprise participants from ICR, its various crop-based institutes, the Alliance of Biodiversity International and CIAT, Central and State Universities, Council for Scientific and Industrial Research, and the Defense Research and Development Organization, Himachal Pradesh, state government agencies, private stakeholders, progressive farmers, entrepreneurs, etc. Thanks to all of you for your presence and for sharing your views during the seminar. With this, we come to the conclusion of the inaugural session. We will request you to join us outside for a group photograph, followed by a quick tea because we would like the sessions to run on time. Thank you and Jai Hind.
Thank you, ma'am. Ladies and gentlemen, I would now request everyone for a group photograph to be clicked at a beautiful Vrindavan garden, followed by a morning tea, which will be served at the Faculty Club for all the dignitaries. And we'll be meeting after 30 minutes. Volunteers, please guide our guests. I request the presenters for the technical session 1 to kindly share their presentation with the IT team, please.
Hello. 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 Hello? Hello? Hello?
Hello, everyone. Please, all the delegates and chief guests are please requested to move to the Vrindavan Gardens for a group photograph. Volunteers may please accompany all the guests and dignitaries and delegates to the Vrindavan Garden as soon as possible. Tea is also served there, so please have tea and come back to the venue. All the delegates who are here for poster presentation, they can paste their posters to their respective places, maybe at a later point of time. But right now, it is important to go and click a photograph and have a tea and come back. And volunteers may please also start preparing the auditorium for the first technical session. ज्यादा टाइम नहीं होगा हमारे पास, तो अभी इमीडिएटली जैसे चाय होती है, प्लीज यहाँ को भी रेडी कीजिए फॉर द फर्स्ट टेक्निकल सेशन.
Hello? 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 ये अच्छा कॉफी बनाया तुम। इतना ही कॉफी? ठीक है, बहुत बढ़िया।
Namaskar, very good morning on the auspicious day of Guru Purnima and Guru Purab. First of all, already our co-chairs are on the respective seats. I take this opportunity to welcome our honorable co-chair on the dais. I warmly welcome our honorable chief guest, Dr. R.S. Paroda ji, who is President, Indian Society of Plant Genetic Resources, Chairman TAS, and he is our chief guest. I also warmly welcome Dr. Sanjay Kumar ji, Chairman, Agricultural Scientist Recruitment Board. Other luminaries, including Professor Atul Khosla, Vice Chancellor Shoolini University, Dr. Dhillon, Dr. R.C. Agrawal ji, Dr. Chaurasia, Dr. Tyagi, Dr. Vats, Dr. Rana, and all the esteemed dignitaries present here. I also welcome the all the organizing team members of this very important conference. I welcome my co-convener, Dr. B.D. Sharma ji, rapporteur, Dr. Kuldeep Tripathi, and Dr. Vinay Kumar. Though the towering and gracious presence of our co-chairs needs no introduction, yet it will be very inspiring to all of us. I would like to mention few words about Professor. Ji, sir. Yes, sir. 1 minute, sir. For kind of a kindness, sir. Dr. P.L. Gautam is an agriculture graduate from. Yes. And now I request Dr. P.L. Gautam, sir, our honorable co-chair, to speak few words about our co-chair. Thank you, sir.
Thank you, Dr. Gautam, for setting the stage for this very important session. And myself and Dr. Khosla will be the co-chair of this session. Of course, we are not strangers to you all, but I will certainly like to say a few words about Dr. Khosla. As was mentioned in the morning, his role in building this institution. My association with Dr. Khosla goes to 80s, when we were struggling to start forestry education in this country. He from Nauni University and me from Pantnagar University, we had a lot of things which were common. And if forestry education has taken seats, Dr. Khosla has a great role in that, in putting that program in place. Both of us worked very hard for one program. That is to start education program in agroforestry. Very difficult. In fact, my problem had been that I had to start with the difficult things. And Dr. Khosla and me so much that today the agroforestry program, which has come into place in master's and PhD level, has got a respectability. And same thing I was sharing with Dr. Paroda, that when we started the MSc program in plant genetic resources, people were hell-bent upon that it is not started. But we could make a beginning, and it was blessing of Dr. Paroda that we started that program. And I could see some of the students here in this audience today. What I mean to say is Dr. Khosla is an institution builder. He is himself an institution and a very God-fearing person. And he has a lot of contributions, whether you take in promoting forestry and promoting education, promoting human beings also. Much more important is the inspiring people. Inspiring people to come forward. We see very rare people who inspire. I remember we had IFRO, International Union of Forestry Research Organization. It was seated in India very effectively with his presidency, with his leadership in agroforestry. So we have several common things which can be shared. He's an educationist and scientist and institution builder. We feel big when we sit along with him. Dr. Khosla, I wish you a very, very long life and long inning, and congratulations for whatever successes you have achieved. Today, in this session, we have plenary lecture. And then it will be having the invited lectures. And plenary lecture is being delivered by Sanjay Kumarji, who was here right from the morning. He also does not need much introduction. And he has given his introduction through his presentation in the morning session. But for some of the youngsters, it may be good to know about him. Dr. Sanjay Kumar is presently the chairman of Agricultural Scientist Recruitment Board and recruiting several scientists in agriculture in the country. He had been earlier the director of CSIR, Institute of Himalayan Bioresource Technology at Palampur. He had also been the in charge and the director of IGIB, CSIU, and was heading the HRDG. Graduate from, he's our alumni, he's a graduate from Pantnagar University and has his MSc and PhD from IRI. He had very prestigious Boy Cost fellowship from DST, and he has traveled abroad many times. He has many honors conferred to him, including INSA Young Scientist Medal, Professor G.V. Joshi Memorial Award, very famous R.D. Asana Endowment Award. Many of you may be knowing Asana, a figure in physiology, and he had that award. And he has contributed at international level in many capacities. He's fellow of National Academy of Sciences, Allahabad, and National Academy of Agriculture Sciences. His areas of research are plant adaptation, but much more than that, whatever experience he had, he is a man known in the bioeconomics of bioresources. A man with very long-standing experience, and I have seen working with him for many years, a person with the passion to do something new. And he will explain to you what new he has introduced. I don't want to preempt those things. So I leave it to Dr. Sanjay ji to make his presentation. His presentation is on the same theme which people try to introduce, the generating bioeconomy using bioresources of North-West and Himalaya. With this, may I request Sanjay ji to make your presentation. Hopefully we are not required to be displaced. We can continue here. Okay, please. Go ahead.
Thank you so much, sir, for your such an elaborate introduction. Honorable Professor Paroda ji, Professor P.L. Gautam, Dr. Khosla ji, my portier and other co-chairs, Professor Dhillan Sahab, and all other dignitaries and students in the hall. What I would like to share with you today, our experience that how we can generate economy using the bioresources. And this is the work basically represent when I was director at IHBT Palampur. And therefore, I thank all the students and staff there. And our work was supported by various agencies. So I thank them as well, whether it is DBT, DST, MSME, ICMR, or CSIR, certainly. Now, if you talk of Himalayas, I think what are the representative group of bioresources? I mean, you talk to anybody, they will say you have a lot of aromatic plants, you have medicinal plant, you have floriculture and things of that sort. But our question was that when we have such wide resources, why we are not able to generate the economy? And we realized that there are few reasons. And one of the major reasons was that do we identify the limitation? Do we identify the problem? That what is the problem that we are going to solve? Moment we identify the problem, probably the solution comes automatically. And when we talk of bioresource, I feel there are few things which we should always keep in mind, and they are very important. One is the quality of those bioresources, whether we have the quality planting material or not. And second issue is, even if we have quality, do we have that in that quantity which can make an impact in the society? The quality and quantity of planting material may look simple, but I tell you, when sir we started dealing with bioresources, this was the most important limiting factor. Value addition comes thereafter. And then certainly along with value addition, you have the issue of skill development. And when we talk of Himalayan bioresources, and if I move around, you will hardly find any center for processing. You will hardly find any center for packaging. You will hardly find any center where, you can store them properly. I think this is a major limitation. And last but not the least, I strongly believe that market linkage is very important. And if you want to really value Himalayan bioresources, can we brand it? For example, in Himachal, you have red rice, which you have branded. You have Kangra tea that you have branded. You have Rajma, which you have branded. But there are many more which can be branded. So I think branding becomes very important issue. And through this journey, I'll tell you that how we identify the problem and what solution we offered, and then how it impacted the livelihood scenario. Sir, when I was interacting with farmers, after taking over as a director, my first job was that we moved around and interacted with the farmers. And you know what farmers told us? They took us to the field, and that field was just lying barren. And they told us, sir, whatever we grow, wild boars will come, they will destroy, monkeys will come, they will destroy. So wild animal, monkeys, they were the major menace. And then he said, can you help us? I offered them certain solution. Then immediately their second problem was, they said, we don't hold much land. We have hardly half a canal of land. What can we do? We want to grow, say, wheat or rice, so that at least we get something for sustenance. And I think that was the real problem. But we realized that that is an opportunity for us. Why? Because if you have a small land holding, in Himachal, you don't have laborers. I said that with small land holdings, you will be able to manage your husband, wife, and kid. They said, yes, sir, it is possible. Then we made a cluster of all such farmers whose land was totally devastated. We made a cluster and we said, we are going to give you something that you need to follow. And then at the same time, we discussed at our headquarters. And we said, sir, we need to start something on aromatic crops. And we launched the mission on Aroma Mission, CSIR. And in this Aroma Mission, we identify the crops. For example, for Himachal, we identified Tagetes minuta. See, this is wild marigold. And India imports around 12 tons of oil from South Africa. And we said, when we are importing it, why can't we produce internally? And we said, we are going to give them the end-to-end solution, right from right variety to the nurseries raising. We teach them. We taught them agro technologies. Then very importantly, we said that once your crop is ready, you don't have to sell it to a middleman at the lower cost. You have to process your own crop. So we empowered them with oil processing. Then we also gave them now the role of institution came. We said, we'll give you the quality parameter of the essential oil. And then about storage and marketing, that thing we did. And when we started this You see, sir, in the, I think I am getting change here. You are not getting any change there. Yes, yes. So, sir, here what I wanted to tell you, once we started with this mission, on this aroma mission, you see, sir, in the number of people who were enrolled with us and the money that they generated, I think it was enormous. Income generation, you see, around 20 crores from the land which otherwise was yielding them zero money. And once people got this taste, I think now I'm sure that after I left, the number is going up and up and up and up. So now farmers want to do it. They said, sir, this is a very profitable thing. Now these companies, now we are producing around 7 to 8 tons of this oil in Himachal Pradesh also. Only. Earlier we were importing 12 tons of oil. So it suddenly changed the livelihood scenario. And when during COVID, what they told us that all their kids, they were staying outside. Now they started coming back. So reverse migration started taking place to the villages. So just one change we did, and that's how we changed the economy of the region. Another, sir, I would like to share a story about the floriculture. And not any floriculture, but 3 examples I would like to quote. One is on tulip, second was lilium, and third is on calla lily. Sir, you will all agree with me. We are still dependent on import of the bulb or planting material for these crops. Although in Srinagar, we say that we have the tulip garden, but they import every year worth 15 crores of tulip bulbs. I said, why can't we change this scenario? Same case was with lilium. And now we have places like Leh Ladakh and Lahaul and Spiti. So, sir, we started initially with lilium, and you see the scenario. Dr. Chaurasia Saab is here, and I think he will agree with me. Sir, 4 years back, there was no flower in any of the shop. We started with this lilium, and they are the now lilium bulb producer. And today, you see, last year what had happened suddenly. I think this slide is not changing. So anyway, let me explain just like that. So what is? नहीं, मेरा तो यहाँ बदल रहा है, सामने नहीं बदल रहा है. अच्छा, 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 अच्छा. ये नई टेक्नोलॉजी है. मैं यहाँ का बटन यूज कर रहा हूँ, बट आई हैव टू यूज दिस. So technology mismatch. Anyway. So, sir, this happened in Ladakh. First flower shop in Leh was opened. This was only because of our effort. Earlier, there was no flower shop. And now you can see the people sitting and selling the flowers. All hotels now you will find lilium flowers. All the bulb produced by them and flower produced by them. And in the morning, their job is to ship these flowers to Delhi. So we suddenly changed the way in Leh, people used to perceive their land, which was otherwise barren. And it just changed it. So now we call it Leh, the Lilium City. Now, similarly moving in the same direction, sir, we started working on bulb production technology for tulips. And all our farmers who are there in Lahaul and Spiti, so we did a lot of back work in terms of, production technologies. So now our Lahaul farmers, they are starting growing the tulip bulbs. And we established the first tulip garden of Himachal Pradesh using the bulb which is produced in India. So this news went to Delhi. So LG Delhi called us, and that he said that why don't you put in Rashtrapati Bhavan at least all the tulip, using the tulip which is produced in India. I am sure that this year they will be putting it. But this was our discussion with Honorable LG Delhi. So now you see, sir, we made small changes and it started making the livelihood scenario, it started changing the livelihood scenario of the nation. And you can see the number of people who were associated with us using this floriculture mission. And sir, as you mentioned in the morning, like in NATP, you launched a mission mode project. Here also, sir, we put it on a mission mode that by this date, if government spends 50 crores, we are going to give 100 crores back to the government. not necessarily in our pocket, but in the pocket of the farmers. And you can see again in income generation slide, such a huge generation of income just through floriculture crops, just by tulip, lilium, etc. So we made all these changes. And we wanted that empowerment with the farmers. So, sir, we interacted with MSME and they funded the processing units, packaging units in these areas, in remote areas. So they funded, they gave us around 3 crore rupees and we established some these models. So I think we always believe that we have to work on technology diffusion. And these guys who are there now in Lahore Spiti through MSME, now they are doing all this work of their own packaging, etc. Another example I would like to share with you, which percolated down to Punjab region, sir. That was on stevia cultivation. And at IHBT, we had certain varieties which were pretty good. So we worked with stevia and we worked out complete technologies on stevia liquid production, etc. And you can see we got a third-party analysis done. Enhancement in income of farmer by 2 to 2.5 times compared to their standard crops. That was the advantage by stevia cultivation it gave. And again, here they, engross. Okay. All right. Okay. So I had to use both the slides, both the hands. Okay, now I got it. Now I got it. So you can see, sir, even in stevia, it led to a lot of economy generation to our farmers. Now, next thing I wanted to mention, in the morning, sir was mentioning about Harman variety of apples. And I think that variety was so famous because, it started giving you fruit at, it started very small chilling period. Compared to 1400 hours, it needed only 400 to 500 hours chilling time. And sir, we did another varieties and we introduced in northeastern region, particularly in Manipur and all those places where they were dependent on Himachal Pradesh and J&K for apples, or they would get it from Burma. And now people started this apple cultivation. Again, in mission mode, we did it. More than 80,000 plants we had planted initially. So we had engaged tissue culture units. There are 5 tissue culture units who are engaged in this. We gave them the tissue culture technology for root stock because in apple, you need that. And today you see, Honorable Prime Minister in his Mann Ki Baat also mentioned about this achievement, that this is something very good which we did for northeastern region. And Honorable Chief Minister, he was so happy. He said, my people were growing something opium and other things. And now they have shifted from opium to apple cultivation because it is giving them higher income. So this also had an impact on their social fabric, some of these things. Another thing I wanted to mention about this hing cultivation. And that was, sir, again, the result of we were trying to catalog the biodiversity of the region. And one presentation was happening in our lab, and our scientist, he showed that this is the status of various plants. And suddenly ferula species came. And we said, then where is our hing? He said, sir, it is not present in India. I said, man, this is the opportunity if you don't have this species. And here, sir, I must tell that with ICR, with NBPGR, we work very closely in terms of getting permission, in terms of getting sanitary requirement done, all those things. Although it took us more than 3.5 years before we could get initial 100 grams of the seeds. But today, I think we multiplied it and we developed tissue culture technology, we developed agro technology of hing, and along with the state government, you can see now we have this nursery of hing developed there. And there are, I think, 93 different villages which were covered, more than 100 farmers. Everything what we do is we give it in the farmer's hand, so that we are there or not, at least farmer will take it forward. So, sir, this hing now in Lahore and Spiti, and also we gave some to Leh area also, around 100 plants. We gave it to in Uttarakhand also, so that, it should be saved somewhere or the other. And sir, for hing, everybody is using hing Around 1,500 tons we import from Afghanistan, Uzbekistan, and those areas. So I think we are thinking that in next 5 to 10 years, at least we should be independent in terms of hing cultivation in India. Another, and just to show you that, which are the places, you can see whole Himachal Pradesh, Leh Ladakh, this all is hing area. Another crop I would like to mention is about this monk fruit. Sir, this monk fruit is a very unique crop. It's grown only in China, processed in USA, and from their mongroside, which is a sweetener, which is 300 times sweetener than sugar, it goes throughout the world. And China was not ready to share that fruit with anybody. So along with NBPGR, we worked very closely, and we succeeded in getting this plant to India. And it was a male-female plant. First year we got only one fruit, but today we got, that our field is full of this fruit. So we developed complete biology of this plant, complete technology of this plant, monk fruit, and we laid the initial trials, and you can see that at least 3 places in Himachal Pradesh, they are giving very good result as far as this monk fruit is concerned. And I think in the area of sweetener, I feel this is the next crop of choice that we should focus upon. And just to share with you, for example, we developed complete tissue culture technology of this plant and took it to the farmer's field. Sir, one plant I wanted to mention. This is our plant of India. Center of origin is Kerala. And if you ask anybody about dalchini, they will say, "Arey, Kerala mein bahut hoti hai. Dalchini ki kya parwah karte ho?" Sir, we saw the import data, and around 45,000 tons we are importing from countries like Ceylon and neighboring countries. We wondered why. And that too, when we were importing the species known as cassia. And cassia, that with the black color, skin. And that is harmful. It destroys our kidney, it destroys our liver. So we worked closely with our ICR Institute in Kerala, with Dapolu Institute. We said, why don't we start mass scale cultivation? They also realized, yes, that is the problem. And in Himachal, can you believe people initially said it cannot be grown? Am I right, Dr. But today you can see after 3rd year of performance, dalchini is doing so well because we developed the relevant agro technologies, what was needed for this place. We identified the place. So we do a lot of ecological niche modeling in the process before going there. We conduct initial experiment, and finally it was very successful. And apart from dalchini, another crop I would like to mention, during COVID, mulati, and we were under the impression that mulati must be a lot in India. A long back, we thought that in Hisar, there was some project going on and Hisar would flood the nation with mulati. We approached Hisar and they told us that they had certain germplasm and probably it is at the verge of extinction. We said we should take it up. And now, sir, again in Himachal at lower belt, we put this mulati. Around 1,000 tons we get it from Afghanistan. We said at least through Himachal Pradesh, we should enrich at least on this resource as well. This was yet another one. One thing I wanted to mention that, about this. So this was something on new introductions and which are giving us revenues back. Like whether it is floriculture, whether it is aroma mission, whether it is hing. And hing, I tell you, sir, the economics, around 250 kg hing is produced from 1 hectare. And if it is sold at 10,000 rupees a kg, I think 25 lakh rupees per hectare. I think one of the most remunerative crop I feel that hing is. Now, sir, another effort we think we should do and we are doing is through ensuring that our rare, endangered and threatened plants, they are rehabilitated back into the nature. So we use tissue culture technology and we are trying to putting back those plants into the nature. Direct economy, we don't expect, but then tissue culture companies, they are making money out of it because they give it back to the companies and now they have got this technology. One technology I wanted to mention about this, our hydroponics, aeroponics coupled with tissue culture. Sir, can you believe Picoriza plant normally grows at high altitude along more than 3,000 meters. We developed tissue culture at Palampur. In hydroponics, we started cultivating. Plant which take 3 years, in 3 months time, you get the full plant with the same picrocide level as you expect. So I felt that new technology, if deployed properly, it can be very effective. And now there are 2 companies who have taken this technology from us. Rather 3 companies. One is in New Delhi, Jalandhar and Hyderabad. And they are making picrocide at low altitude. They don't have to go to high altitude region. So that is the power of technology, which I feel, and I thought I should share with you that this is also an important component. And from here, you can get the crop throughout. For example, tulip, we standardize the technique. For value addition, I wanted to now give you some flavor. Because our conference is all about malnutrition also. And recently, sir, when we started working on nutritional aspect, we had a meeting with our industrial partners, and they said that there are 4 or 5 things which are very important. One is vitamin D deficiency, iron deficiency, and zinc deficiency. They also mentioned that bone health is very critical, immunity is very critical. So we started working on some of these issues using the Himalayan bioresources. And you see, for this purpose, for vitamin D deficiency, which all Indians are undergoing because we don't take sun bath, our shiitake mushroom technology came in very handy. And by this technology, we can develop the vitamin D at the desired level. And this technology we gave to at least 6 different companies who have taken this technology. And more importantly, keeping in view the large demand of shiitake mushroom, we again through MSME, we made a cluster of people and they supported the shiitake production technology. So there are 750 people who are involved in shiitake mushroom cultivation, and each one is making good money. So just to give you the example that if you identify the right problem, if you take up the right bioresources, I think economy generation is not a problem. Second, I would like to mention about zinc and iron deficiency. And to meet out this deficiency, nothing better than spirulina. You can have as much zinc, as much iron as you need it. So you develop it, and after development, what we do value addition, like convert them into say chicky, bar, toffee, chocolates, etc. You convert them into that. And today you see, these are the products that we have made out of this spirulina. So when we discussed with the deputy commissioner, and he said, sir, for our malnutrition program, problem is we give panjiris. And our villagers, they give that panjiri to the buffaloes and cows rather than consuming themselves. He said, the things that you made, it is so delicious that people will start eating it. So now we work very closely with our deputy commissioners, and we are part of the Poshan Abhiyan. Our kit is for 7 to 8 rupees, which has got some toffees, some chocolates, some chickies. So the kids and the lactating mothers and the growing girls, they take it, and it's helping them a lot in terms of fighting with the malnutrition. So this is yet another way we have gone. So these technologies with the partner. Now there is a already natural sink we have created through this malnutrition program, and they are linked with the farmers. So you can see complete chain is established. And this is doing pretty well as far as malnutrition program is concerned. A few quick, I will just glance through. Like, for example, we develop a lot of nutraceutical product, particularly for bone health. You know, we have the problem of cartilage destruction as we age. So we use that traditional knowledge, which we were discussing in the morning, that when we talk of biodiversity, I think traditional knowledge is very important. And here we not only developed the formulation, we went up to the evaluation to the human trials using the medical college. And once they said, yes, it is effective, then only we launched it into the market. So it's already there into the market, this VC product. And properly, you know, complete chemistry done, complete formulation done, value addition done, and then properly checked by the medical college. Similarly, one more formulation we made out of tea, that is for immunity modulation, right? So why I am giving you all these thing is that if you have the right resource, if you know what you want to do, I think economy can be generated. For example, in Palampur region, you have a lot of tea, but if you just sell tea just like that, how much money you can earn? But if you make several products out of tea, maybe soap, maybe wine, maybe beer, I think you can earn a lot of money. At least now our soap is doing very well in the market. Wine is taking some time because of getting permissions and other formalities. But at least soap is doing very well. Our hand sanitizer all through the COVID, I think this was the only savior in Himachal Pradesh. Everybody had our IHBT product on the tea-based hand sanitizer. So our resources can give wonderful things. For example, bamboo. You can make yarn out of bamboo. You can make bamboo charcoal. You can make bamboo-based agarbattis. Sir, even today, all the agarbatti sticks are being imported. I always wonder why. When we have so much bamboo resources. So we set up a unit. We are training the people. We are telling them, भैया कम से कम अगरबत्ती तो अपने घर की ले लो. उसके लिए आप विदेशों पे तो मत निर्भर रहो. So we can make some of these bioresources and try to see that it touches, everybody's life. Similarly, sir, buckwheat we have. If somebody does not want to eat chapatis, we can make noodles out of it, bar out of it. Recently, we are putting a cluster there for buckwheat food processing. Very soon it will be installed. Once this buckwheat cluster is installed, then you will get all the noodles made out of buckwheat. So nobody will be having any problem of eating noodles. This is something on the almost last slide I wanted to mention, that not only such products, but high-end products can also be generated. Particularly India, we depend on Westerners for our enzyme need. 70 to 80% of our enzymes are imported in this country. Sir, we made a humble beginning by first making a complete end-to-end technology of superoxide dismutase. And we had done a lot of genetic engineering so that our sod was so much stable that you can autoclave it 3 times and it was stable. It can function at -20 degrees centigrade. So it was a fantastic product that we had developed. And at that time, company had given around 1 crore rupees also for this technology. So we had done something of this type. Now I'm coming to some other issues apart from bioresource to bioeconomy. I think it's very important that institute and universities have a startup culture. And we had opened the startup culture at our institute, and around 56 startups we had developed just within a span of 4 to 5 years. And all the startups, they are doing pretty good. If you see various areas around which we develop startups, whether it is a hydroponic, aeroponic, whether it is aromatherapy, whether it is herbal formulation, whether it is tissue culture, we have startups in a wide areas. Whether it is even including remote sensing, we have the startups at our ISBP. Even agriculture based products, we have the startups. So we develop a lot of startups, and you can see some of their products. For example, sir, I always believe, and if given a chance, this Himachal, I always feel, can feed the whole country. Whole France can generate so much economy out of perfume. We give so much perfumery products. In Himachal, we have so beautiful flowers, and one of our startup has come up with natural perfumes. We are just wondering how to upscale it. And in perfumery, you know how much money is there. So I am not telling you all the items, but at least perfumery can change the whole economy of this state and also of the nation. I very strongly believe. We say कि हमारे ऊपर 55,000 करोड़ का खर्चा है. ये कर्जा कुछ भी नहीं है सर, अगर we start working some of these things at a higher scale. That's my strong belief for our state. I'll just rush some of these slides because almost done. I think internet is not working. Okay. So here just I wanted to tell you that using some of these resources in last 8 years, we developed around 40 technologies. Not developed more than 80 technologies, but 40 technology we could transfer to 88 entrepreneurs. And right from packaged food, like today during breakfast, there was a discussion that when we go abroad, we don't get vegetarian food. And I tell you, in our local MLAs, whenever they used to go to Japan and this country, they would come and buy, this Kangdi Dham, we had done the packaging. So we feel that traditional food should be accessible to all. So we made a technology of packaging, no chemical, no preservative added. And I think this technology, we gave it to 5 different people, and all of them are doing pretty well. We developed this technology for lifelizing the fruits, particularly things like apricot, just in 2 days shelf life. So you can lifelize those fruits. We developed that technology. Now we give it to the person and she is supplying only to the 5-star hotel. She is not yet giving to the general public, but I feel a lot of potential. And like this, sir, you have whole range of technology. Around 88 entrepreneurs are associated with us. I am not going to read all of them. But just to give you a hint, right from gulal to lipstick to tissue culture technology, to enzyme technology, to waste management technology, which is very effective in our Lahaul and Spiti. Because it was a symposium around bioresource, I did not mention, but I tell you, sir, in cold desert area, waste management, when there is no waste degradation at cold temperature is a problem. And we had a composition which degrades waste even under freezing condition. So for some of the housings, we developed that, and that's doing pretty well and being used even by our army personnel. So just wanted to give you a flavor that using bioresources, economy can be generated. And there are various ways. Only thing is that we need to support our youngsters. So we should have the right policy. Sir, since all our seniors are here, we give our PhD student the fellowship. So when we started with the startup, and our MSc student, they said, we want to do a startup. And they were looking for some financial support. We said, why not you also get some financial support? So they were getting, sir, 20,000 rupees. But that was conditional. If you don't do your startup, you have to return back all the money. With PhD scholars, we don't do this condition. But with that, there was a condition. And because of that, you see 56 startups and their products are in the market. So small changes we do. Then we signed MOU with the SBI because they wanted, say, 1 crore loan. And for 1 crore loan, they will say you have to put the collateral. So SBI signed MOU with us that if the startup is associated with you, then we won't charge any collateral up to 1 crore rupees. So some of these steps helped our startup to move forward and launch their product. So, sir, thank you so much, sir, for your patience listening. And some of the things I wanted to share, that how we generated economy out of bioresources. Thank you.
Well, ladies and gentlemen, we had a very good presentation up to the theme of the session. And we were looking forward for such a presentation, which gives confidence to the people working in genetic resources, that how important these resources can be provided, you evaluate them properly, generate a system for their consumption, repair, commercialization. And since I had been noticing his work at IHBT very closely, and I really felt very much interested that we should have a presentation from Dr. Sanjay Kumar, who has done a lot of work there. And you know that right from introducing new bioresources to the utilization of our own resources, and then how the economic condition of the people can be improved. So this is a big message that we have, if you choose right bioresources, right technologies, right system of production and marketing, you can promote all these things. He mentioned about local food system. The local food system, which the Kangdi Dham, which he says, it can be stored for some time. There are 8-9 people who are producing that. So that's how a small initiative has made a big impact. Thank you very much, Dr. Sanjay Kumar ji, for agreeing to deliver this plenary lecture. I hope all of you will agree. It was a very, very informative talk, and let us give him a standing ovation. Thank you. In fact, this session has very distinct and very divergent type of presentation. And we have the next presentation as plenary, as an invited lecture. That is from Dr. Chaurasia, who will be speaking to us on plant diversity in cold desert Himalayas, challenges and opportunities. Dr. Chaurasia was introduced in the morning also, and he is a scientist in Defense Institute of High Altitude Research in Leh Ladakh. He has expertise in ethnobotany. He has extensively surveyed flora of medicinal plants of defense importance. He has pioneered many works and many technologies. He has about 12 patents to his credit, several publications, and books like Ethnobotany and Plants in Trans-Himalayas. You will see from his work, which he is going to present to us, a unique work, different organization that gives to cross-fertilization of ideas. With this, I request Dr. Chaurasia to make his presentation on the topic which I have already introduced to you. Thank you very much.
Honorable Dr. R.S. Proda, S.S. Proda, Chairman, TAS, and Chairman ISPGR, Dr. E.L. Gautam, Dr. Khosla, Chancellor, Shoolini University, and Dr. Sanjay Kumar, Chairman ASRB, and then and Dr. B.S. Dillon, ex-Vice Chancellor, PAU, and any other friends. So we heard from the beginning how plant biodiversity plays an important role in the day-to-day life. So I will talk. My topic is the plant biodiversity of the cold desert Himalaya. When we talk about the Indian cold desert, so major portion of the Indian cold desert belong to Ladakh, parts of the Himachal, that is the Lahore Spiti, and the parts of the Uttarakhand, that is the Itimana area, and the parts of the north, few parts of the northeast, that is the Tawang area. So in all, the 70% of the Indian cold desert come under the Ladakh area. I have been in surveying that area since 93, so almost completing plus 30 years in the Ladakh. Physical presence is my there. And see the whole Ladakh day by day becoming the importance. Earlier it was a district, and now it is very strategic bordering with the China, Pakistan. Our earlier competitor was the Pakistan. Now because of the China issue, now the China is the main issue, and China, because of China, our forces have been deployed in the extreme altitude, that is around 15,000 to starting to 20,000, 21,000. And they require the fresh food item. See the geographical area, forest cover is still very low. Area we are having the huge area, but because of the tough condition, cold desert, only few months, like starting from May to October are the conditional period to grow the things. Otherwise, the remaining 8 months are under the snow. And then also crop area very less, only 10,000 hectare. That is at 0.229%. Then the agility of the farmers are very below the marginal also, and the minimum temperature is on average -6. Otherwise, the temperature drops in winter around in Leh Valley temperature is around -20-25, and in the forward area and the high extreme altitude temperature goes below the -50-60. And then in summer temperature only for the few months, 3 to 4 months temperature remaining plus, that is on an average -20 degree, +20 degree. Otherwise, the maximum temperature in summer go around +30. And humidity quite low, and the precipitation is also very low. And so the growing period very short agriculture season, that is start from May to October. Yeah. So our next please. Next. 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 Yeah, so plant biodiversity of the health of the Ladakh. So generally plant biodiversity of the cold deserts are the unique, rare and high value, which are closely related to the day-to-day life of the locals. Medicinal plant, high altitude medicinal plants are extremely important, as Dr. Sanjay Kumar sir told, and Dr. R.S. Paroda, I think he visited to my place in the month of May. He himself has seen the biodiversity and like that. And now based on the keeping the importance of the medicinal plants, and we are working closely with the SOAR ICPA, and already to exploit our Indian plant, high altitude medicine plant, very similar to the Tibetan and the Chinese medicine system. So that's why to conserve our patent, already government of India has established the National Institute of SOAR ICPA at Leh. And especially the Honorable Prime Minister giving the focus to conserve our high altitude medicine plant, which are playing the major role in the Tibetan system of medicines. So already government colleges have been working under the National Institute of SOAR ICPA. They have established to conserve, to develop the full-fledged high altitude herbal garden, and their utilization in the formulation of the Tibetan medicines. And again, the cold desert of Ladakh extremely rich in Sibakthon, that is wild bush, and with the and DRDO play the pioneer. In fact, when you talk DRDO, Dihar play the important role. And in fact, I started my career with the Sibakthon. I am having the around 12 patent on that Sibakthon plants. So now the plant will become the golden bush. And then again, that is very representative with the apricot, huge germ plant of the apricot are available. And in fact, our team had collected the 84 types of germ plant of that area. So we will present it that one. And we extensively surveyed the entire, keeping all these germ plants. So our team had extensively surveyed the entire area of Trans-Himalaya. Next page. So I will presenting our presentation in the 4 groups, that is widely used high altitude medicine plant. Then the plants of edible and spices value. Then the super fruits, some are the super fruits are there. And then the fruit plants. Next one, please. Next, please. Back. Oh, yeah. Thank you. So plant biodiversity of Korea at a glance. You can see all the plants. We have mentioned only the important plants are here. So we have talked a lot. And these they are plants of the extremely high altitude plants, like Echinactum heterophyllum. Econite is represented by 3-4 species in the high altitude, like Echinactum heterophyllum, Echinactum violacum, then Echinactum other species there. Amongst two species of the Echinactum are highly important. That is the Athis and Pathis, and play the very important role in the Ayurveda system. Then the Arnibia ichroma, or Hatanjot, highly important plant, represented by the 3 species. In Ladakh area, there are 2 species. That is the Arnibia ichroma and the Arnibia. Arnibia. That is Arnibia. Other species I forgot name, and play the important role. Then the Caparus, it is also it is actually sand binding plants, and the capar it plays the root is a very important play in the manufacture of the leaf 52. Otherwise, the leaves and the young birds are edible, good source of the uric acid. Then Dactylo as a hataria, everyone knows about this plant, Salam Punja, and it grows near the marshy land, but still it is very difficult to multiply. So we are also work on the tissue culture, but from the nature, day by day, population is degraded. Once upon when I used to, in the beginning, I used to survey, plenty are there, but now we are hardly to see the plants on the grounds. The Delphinium brunninum, Delphinium castellanum, that is a Himalayan large cluster, very important plant, grow along the extreme altitude around the 14,000 to. Then Inula esmosa, Puskarmul, quite important plants in the Ayurveda system and the solar ecosystem, and it is being cultivated in plenty in the Lahore Spiti and now starting in the Leh Valley also. See, it is quite important plant. There is Himalayan blue poppy. It is quite popular and grow, and these plants come under the critically endangered plants and play a very important role in the solar ecosystem. Podophyllum helianthum, it grows around the low altitude, around 10,000 feet, and the rhizomes are the source of the drug podophylltoxin. In fact, DRDO, we did work we developed the patent, we got 2 patents on this plant for the radio protection. Then Rheum babianum and Rheum specififorme, that is called Rivanchini, quite important plant and plays very important role in the Ayurveda and good source of the anthraquinone derivatives. In fact, Rheum babianum very easy to multiply. Even at the lower altitude, it can be easy to multiply. And the leaves are the good source of vitamin C and other. In European country, this plant is quite popular as a rhubarb. Then the Rhodiola imbricata, it is called a golden arctic root and commonly Srola. And in fact, we did a lot on this plant. And the root are very useful. The root are as a anti-fatigue, restore memory. Leaves are edible. Rhodiola juice, tea, and capsule are available in market. And Honorable Prime Minister has talked about this plant in 2019 during the split of the UT, formation of the UT of the Ladakh. So still, but we are facing a problem. We did a lot of study. We did a complete, my 3-4 students do the PhD on this. But it is not easy to multiply. This plant grows near the snow line. But we are importing this raw material from the China. China is the main dealer, and 2-3 species are very common, like Rhodiola rosea. That is very common. Rhodiola, China is using the Rhodiola ata. That is very and it is also known as Siberian ginseng. It is at par with the ginseng. Sauceria lapa, we know now also play a very important role. Then we'll talk about a few of the edible and spices plant. Like a wild garlic, few species are available as a, and in earlier days when in Ladakh there was no garlic, local people used to harvest the young leaf, they make a paste and dry it and they used it. They are still using now also. Then Sahijira, Bunyam persicum, but it is very difficult to multiply, and still there are no full proof to multiply this, and it is only available in the Dras area. In the absolutely dry condition, it grows, and birds are edible. So in the beginning of summer, earlier the farmer uproot the plant up to the root and they can consume it. Then the carom garbi, that is variety gracile, caraway, local caraway. Sisal microphyllum, yes, Sisal microphyllum, that is wild gram. Unlike the cultivator, it is perennial. It is perennial in nature, and the number of seeds per pot go up to 10. This is a Ferula jacksana as Dr. Sanjeev told about it. So I work on this plant how to multiply. Then we are also working on the cultivation of the cultivating. It is a 4 to 5 year crops. It takes 5 years to mature. We are having the 100 plants, and we are of the different age group. So in coming year we will sacrifice few plants having the age of 4 to 5 years to see the quantum. See origanum, these are all commercial value. See the another quite important plant, that is black gooseberry. This is an unexplored plant, and it is considered as a superfood. Now through the world, China is the main monopoly on this plant. This plant grows typical on the sand dunes. And these are source of the anthraquinone, that is special anthraquinone, that is OPC, oligomeric proanthocyanidin. It is a magical tea. Just you dry the tea, there are no known processing. Just you dry the plant and dry the fruits. You put 3 fruits in the water, it will give the blue colors. So it is excellent source of the. And you see, we snare the cultivation technology, and now we developed a few entrepreneurs. See the contents of all the things. Then the cultivated varieties of the the red gooseberry. Complete through the world, China is a monopoly. They are producing 1 lakh ton of the red gooseberry, and it is China origin plant, and it also grows in the Tibet. And our area, Ladakh area, is very suitable for growing this plant. And there is no need to process. Just you dry the fruits and you can consume it. It is available in the market here also. So Sivathon, good example how the wild bioresources can change the economy. So Indian cold is represented by 3 species. That is Hippopus ramnari, Tibetana, salicifolia. We did quite long back, 20 years back. We did all satellite imagery, how much wealth we are having, around 11,500. See the diversity, how much diversity, plenty, sir. Dr. Pradha sir has visited, he has witnessed the diversity in the Sivak zone. We have selected a few sensors also. Then over the period, we have developed the products like Sivathon Bibre, Apricot Bibre, that is a blend of the Sivathon apricot, then Sivathon herbal tea, Sivathon gel, oil capsule using the supercritical CO2 extraction plant, then antioxidant, some sort of chavan, then adaptogen appetizer, then all this we have developed. And now the product have been commercialized by the local. Now after coming the UT government, we are giving that local emphasis on the local entrepreneurs, and local entrepreneurs, they are quite effective. They have developed the packaging, and they have established the simple graduate non-science student. They have established supercritical CO2 plant. They are within 2 years they are extracting the 100 liter of the Sivathon oil. Besides Sivathon oil, they are also extracting the oil of the rose hip. See what we did lab to lab, develop the complete, then the supply or raw material through the cooperative, then develop complete package, Then we have submitted a report to the Ministry of Agriculture. Based on the data report, government of India, MIDH has included Sibakthon as a horticultural crop for the high Himalayan state. I mean, just 2 months back, government of India has given a GI tag of this plant. See, our quality I have the few local resource observed plant. That is common one is the Mongol, Thar, Kosu, and Karkochu. We are in the process of GI tag of this variety. Then the apricot, that area is known for the apricot. Around 70% of the apricot of India grow there. And the taste is no match. Generally, apricot TSS is around 15 to 20. But one variety we are having, that is Ragchekapo, TSS go to 37. So already see the assessment varieties, how much variation we are having. We have established our apricot gene bank of the 84 assessments. See, the government of India has this year only they have approved the GI tag of the world's sweetest apricot, and we have published the paper in the scientific paper also. And already fresh apricot they started exporting from that area. This area is around the 100 ton of the fresh apricot has gone exported to other parts of India as well as the Dubai, like and for that we have established we are having the herbal garden for the propagation and conservation. And see how the wild plants, how the bioresources can important fragile ecosystem like that. So ultimately the end is the need for the cultivation, conservation, and the sustainable utilization through involving the local entrepreneurs. That you meant. Thank you very much. Thank you.
Thank you, Dr. Saab. It was. कहाँ चले गए आप? अच्छा, it was a very nice presentation. See, the purpose of arranging these talks from disciplines outside of ICR system was intentionally done. And I have 2-3 things for you. Well, your talk was very long, and it was I did not interfere with that, but 2-3 back home things. One for NBPGR to declare your the NAGS. You as a NAGS, National Active Germplasm Site, for the vegetatively propagated materials. That is one thing which I think we should try to pursue. The other is that the NBPGR center at maybe here or Srinagar should lay focus on the collections from that region. So that's these are 2-3 things. You have very nicely explained how the local biodiversity is being documented by you, and then how it is being commercialized. It was really very new information to many of our people. Thank you very much for joining. Okay. Sir, yeah, I know you were part in the family of NATP. Thank you for doing good work. Thank you. Well, give him a big hand. He has come with full preparation. He deserves best. Well, the next person is also from another state, state of Uttarakhand. And of course, he has mandate of all hill regions of the country. Dr. Lakshmikant, who is director of Vivekananda Parvatiya Krishi Anusandhan Sansthan. He is PhD in genetics from IRI, lot of experience from outside, and has developed many varieties of wheat and barley. Well-read scientist, lot of publication to his credits. You will hear from the good work done by him in facultative wheat, utilization of facultative wheat genes. Without taking more time, and I now give the floor to Dr. Lakshmikant. आगे भी मैं आगे नहीं बोला मैंने, लक्ष्मीकांत प्यारेलाल भी होता है तो लक्ष्मीकांत जी को, and but my one request, because I can tell him, he was my neighbor, that now we have kept a ceiling of 15 minutes. Kindly help us. Thank you.
Thank you very much, sir. Honorable Padam Bhushan, Dr. Paroda, sir. Chairman, Dr. Gautam, Dr. Khosla, sir. Dr. Sanjay Kumar, sir. In the audience, Dr. Dillon, and other colleagues and delegates. I have been asked to talk about genetic enhancement of local food system in Northwestern Himalayan region. And if we see why we are talking about local food system, because there is enormous pressure on food system worldwide due to global population growth, rising income, and increasing urbanization. And this calls for need for transition towards more inclusive, resilient, and sustainable food system. UN General Assembly in 2015, they have said that as per SDG, this transition should include consumer access to safe and nutritious food, improved remuneration to the farmers, preservation of natural resources, and climate change mitigation. Here, the role of local food system may play in this transition that has caught the attention of general public, policymakers, and researchers. And particularly during the COVID-19 period, the local food system are often put forward as a more resilient food system. And therefore, over the years, government has promoted this local food system. If we say there is no set definition for local food system in terms of distance between production and consumer, and it can be broadly, it can be a food system in which foods are produced, processed, and retailed within a defined geographical area, and this ranges from 20 to 650 kilometers as per literature. And this can be defined based on marketing arrangements direct to the consumer or different channels. Generally, it has three domains of proximity: geographical, relational, and proximity in values. And of course, the geographical proximity is number one, and others are they add the features to local food system. There are three aspects of local food system. First one is social, building social connections, increasing relationship and shared knowledge between farmers and consumer. The second one is economic, creating opportunities for farmers through developing localized and regionalized market. And third is environmental, strengthening environmental stewardships of farmers and distributor. Sustainable food system, if we see, this is delivers food security and nutrition for all in such a way that social, economic, and environmental basis to generate food security for future generation are not compromised. And food security as defined as when all the people all the time have physical, social, and economic access to food in sufficient quantity and quality to meet their dietary needs for an active and healthy life coupled with sanitary environments. This local food system is important for ensuring food and nutritional security because it is well adapted to local ecological, socio-cultural, and economic setting, form the functional food for particularly the hill farmers due to nutraceutical properties and nutritional value, and therefore we have to refocus on the plant diversity, particularly within the local food system. This role of plant biodiversity within local food system in Northwestern Himalayas, when we discuss, there is local and regional biodiversity, which is very crucial for nutritional security of small farmers. And within this local food security, there are large number of plant species which are beneficial as food and provide micronutrients, avoid malnutrition by providing nutritionally rich meals to the communities. It is deep-rooted in local resources, environment, expertise, and heritage. and it plays a significant role in sustainable food production, encouraging practices that promote biodiversity. If we talk about the Indian Himalayan region, this shows from northwest to northeast region. And if we look at the status, 53.8 million hectare area is there, and it shelters 34 million people, and majorly hill farming community that survive livelihood farming, that is subsistence farming on insignificant rainfall. Agriculture is the primary sector, contributing 45% of gross total regional income, and more than 90% farmers are marginal farmers. And there are several constraints to hill agriculture: moisture stress, poor soil conditions, short growing season, then irrigation is very meager, facilities are there, then social economic limitations are there, like small holding, ignorance of farmers, poor productivity, pre and post production management, marketing network, labor shortage, and lack of entrepreneurship. Then climatic limitations of high rainfall and humidity, low temperature and low light intensity, floods and seasonal droughts. And then infrastructure restrictions are there, and above all, the management limitations are there. There is a huge extension gap and poor motivation, lack of farmer incentive, and like that. Coming to the main crops which participate in local food system, particularly in mid-hill regions, these are local Himalayan food crops. They are an ideal choice for healthy whole of diet approach, healthy, nutritious, and sustainable diet, making them a great alternative to the generic grains. And a mention was made about lal dhan in Himachal. There are different types of lal dhan in Uttarakhand also. Then rajma, it is a source of high protein, and millets. There are a number of millets which are grown in hills: finger millet, barnyard millet, proso millet, a little millet, and all that. They are rich source of calcium, iron, and fibers. Then amaranth, which is called a superfood. It is a gluten-free food and rich in protein and manganese. Similarly, buckwheat, a mention has been made, and it is again a gluten-free and rich in fiber, magnesium, copper, and manganese. And then horse gram is a traditional pulse crop, which is rich in iron and essential oils, and used for treatment of kidney stone. And then black soya bean, Dr. Prodha sir was mentioning in the morning. It is a native of Uttarakhand areas, and it is high in oil and protein, and it is being used for the treatment of jaundice. If we see the status of plant biodiversity in Indian Himalayan region, total 18,940 species has been mentioned, and out of this 8,500 are endemic species, and these are the major genres. And these crops, within crop, the varietal diversity is much. And around 2,500 plant species are being used in Indian medicine system, and more than 1,750 in herbal system. To collect these germplasm valuable resources, more than 300 crop-specific exploration has been made, along with the NBPGR. NBPGR is the main player, and more than 30,000 accessions has been collected from this. And within this, the traditional agro ecosystem, 273 cultivated species, 898 wild relatives, 744 wild edibles, and 590 plants having industrial potential has been characterized, has been documented. And there is a distinct ethnic food culture and local knowledge in Western Himalayas. And in Uttarakhand, indigenous food system are self-sustaining, land-raised cultivation of native or naturalized crops, then raising the indigenous livestock breeds, and gathering the wild food from agroforestry and forestry areas, making different farming situation and commodities. This is one of the famous traditional food system of Uttarakhand. It's known as Bara Naja, mixing of 12 cereals, pulses, and oil seeds, and it ensures nutritional food requirement, fodder requirement, maintains the soil fertility from small holding and rain-fed agriculture. These are the source of carbohydrate, calcium, iron, and energy. These are for protein, and overall, this provide food and nutrition security to the communities. And you see, if we have a look on this, this gives a food security, nutritional security, maintain the agrobiodiversity, then climate resilience is there, and environmental security is there, and they are organic by default. So this provides a strong human and plant health and sustainable cropping. Having said this, I am coming from an institute which is a multi-crop, multidisciplinary institute, and we have around 17,500 germplasm in our medium-term module, which has been used for the improvement of different mandated crops. And this is the distribution of different crops in the germplasm holding. Till date, we have developed total 192 varieties has been notified from this institute. And these are the breeding methods which has been used in different crops, including the modern ones. This I have put to show that the local germplasm has done a good job for varietal development at our institute. Out of 192, almost 25% varieties has been developed through direct use of the local germplasm, or use them as a parent in the breeding program, be it paddy, finger millet, barnyard millet, amaranth. Similarly, this maize also, one northeast landrace has been used, and indigenous germplasm has been used here. And then lentil, rajmash, and horse gram. Local germplasm has been used for development of these varieties. And similarly, in soybean and black soybean, this 65 and 201 is a black seeded that bhat. Then toria, piyaj, and lasun, local germplasm has been used. These are some latest additions which are good for ensuring nutritional security. This is QPM. QPM, we have almost 5 or 6 hybrids. And now this year, one vitamin A rich hybrid has been notified. This amaranth is a crop which is being talked as a very nutritious crop. And this is one I would like to mention where we have changed the grain color of that finger millet in a white one. And this is a cherry tomato, which is a high source of vitamin C. Having said that, when we took these materials to the farmer's field, you can see that in farmer's field, the gain is from 18 to 56% in different crops. These are glimpses from different places. Now there is a future challenge because population growth is demanding more food. So the production environment will make it difficult to maintain the same rate of productivity, and current food production scenario do not suffice, and therefore transformation of food system would be required. The possible approaches will be either we have to shift in dietary shift, then food waste reduction, closing yield gaps, increase in arable land, improve productivity. This depends on the development of new technologies, including new crop varieties and precision agriculture. And I have grouped these methodologies in 2 slides. One is non-molecular conventional, where we have to increase, because we have to decrease the time development for variety and increase the genetic gain. This rapid generation advancement, single seed descent method or bulk population method, though we are not getting time gain in bulk population, but we are saving the resources. And then double haploidy method and shuttle breeding. This is a molecular breeding methods which are applied at mass, marker state backcross breeding, marker state pyramiding, genome selection, and genome editing. This is a possible strategies which we can follow to meet the SDG 2 and SDG 3 for local food system, diverting more investment in agri-food system, Then creating awareness of nutritional benefits and promoting their marketing, bridging the gap of nutritional composition in daily meals through dietary diversity or biofortified crops to tackle the triple burden of malnutrition, nutritional disparity, and food security, bidding for increased yield and nutrition in faster and efficient way by integration of modern tools, techniques, local biodiversity for sustainable, resilient food system. I acknowledge the support given by all listed here. Thank you very much for your patience hearing and giving me this opportunity.
Thank you, Dr. Lakshmikant, for a very comprehensive presentation. You know that this is one of the oldest institute, which has celebrated 100 years, and 100 years this year, and they have a lot of work done in crops and crop germplasm, and we are proud of the work done by the scientists there. Thank you, Dr. Lakshmikant. We will not have questions. We will have one or two questions in the end. Please take note of that. Some students were sleeping in the back. I have a question for them. What is horse gram? Student in the end, वो जो सो रहे थे. What is the meaning of horse gram? क्या होता है? चलो ठीक है, इसको ध्यान रखना. उठ गए ना? That's good. Thank you. With this, we have the next presentation. Very interesting presentation from Kashmir, Jammu Kashmir. And Dr. Mahendra Kumar Verma will be making his presentation online. Have you connected him? Yeah, he's connected. Well, Dr. Mahendra Verma is director of ICR Institute known as Central Institute of Temperate Horticulture, located in Srinagar. He has a long experience of working on 24 different fruit crops. He's a well-decorated scientist, and he has visited many countries and has worked outside also. With this long experience, he is now heading that a very important institute for the temperate horticulture. Dr. Verma, you can make your presentation.
Sir, good afternoon, sir. Sir, am I audible to all of you?
Yes, you are audible. Please go ahead.
Okay, thank you so much, sir. And really, this is a very important occasion for me. And I don't want to miss this occasion because this is the conference for the Northwestern Himalayan region. And officially, I wanted to participate as a physical, but because of some of my other issues, I could not make it available. But I requested personally to the organizers, especially Madam Dr. Anuradha Agrawal, and she made it possible for today. So really, I am thankful for all of you, sir. Honorable Dr. R.S. Paroda, sir, who is the brainchild of this whole conference, Dr. Gautam, sir. I really wanted to thank you, all of you. I wanted to talk to you about the temperate horticulture, especially the fruit crops. So what is the current status and how we can harness its potential? Especially, I'm going to talk about the fruit crops. See, this I'm going to cover the nutritional security, how we can have through the temperate fruit crops. Then what is the national and international scenario? Temperate fruit crops as a source of the livelihood, and what are the varietal development going on India in the abroad, and what are the protection technologies. If we talk about the health of the human being, I think the human health is composed of the three things mainly: the physical health, mental health, and social health. If these three things can be combined together, I think we can have the best of the best human health. Globally, if you talk about the major cause of the diseases, then there are about major 10 diseases. This has been reported by the WHO. Out of these, about 7 diseases are non-communicable, and they are a major cause of our death. But what are the source of the nutrients through the horticulture crops? How we can how we can combat all those things by mainly the immunity or using these nutrients either in the form of the fresh fruits or in the value-added forms. Cancer is one of the major cause of diseases world over, but at the same time, we have the gift of the God or the nature as a superfood. As if you talk about the major anti-cancerous nutrients, there are many nutrients are available, and these are not available in almost all the fruit crops, but only few fruit crops have in the concentrated forms. Like we have the blueberries, goji berries, grapes, and mangosteen, and these are providing many of the nutrients like the selenium, folic acid, vitamins, and the carotenoids and the anthocyanins. And health, this heart is again one of the important aspects which we are already facing. So there are many fruit crops which are very, very beneficial to our health of the heart. Likewise, brain, in the aging of our human beings, the Alzheimer is one of the issue. For that one, there are many of the fruit crops or the horticulture crops. They are going to play a very important role, especially in terms of the vitamin K, lutein, folate, and beta carotene. And nervous system, it is more or less similar with this Alzheimer, dementia, all those things. But again, we have the options, but through choosing the diet, through the horticulture products. See, here recently, we have faced a lot of problem through this COVID-19. But what was the solution behind these all COVID-19 issues? It was only through the supplementation through the nutrients. So they can be made available through the horticulture crops. And you see, these temperate fruit crops are very, very vibrant, very colorful, very, very nutritious. There are a range of the fruit crops we have right from the through this trans-Himalayan region, like the apple, pear, peach, apricot, walnut, hazelnut, chestnut, and the minor fruit crops. Say all these fruit crops, but there are selective fruit crops have the major content of these all nutrients, and there are certain fruit crops they can also going to play a very important role. So I have summarized these nutraceutical compounds which you can extract, which you can utilize in the form of the fresh fruits, mainly as in nutraceuticals. Mainly we are getting if through the polyphenols, it may be through the flavonols, anthocyanins, and the tannins. And these are some of the fruit crops like the blueberries. There is hue and cry world over that blueberry is very, very rich. Likewise, there are other fruit crops like this apricots, cherries, strawberry, and plums. I have made a summary of these all nutraceuticals among these temperate fruit crops. So here we can see that for the this one ORAC capacities, we can get this rose hips and raspberries, especially for this vitamin C and total flavonoids and anthocyanins. So these are some of the fruit crops we can choose according to the concentration of these all nutraceutical compounds. Especially anthocyanin is one of the compounds which is having the anti-nutritional compounds, and this antioxidant compounds here, Elevara plum, although it is very, very uncommon, but it can be harnessed. Likewise, there are many fruit crops for the vitamin C and tocopherols. So these are some of the nutraceutical compounds we can harness from the temperate horticulture crops. But what is the scenario? We are having very small area in case of the fruit crops, but significantly we are having in the temperate food crops around 10.37% area and 12.38% production, which is mainly around 70% for the apple productions. So there is need to harness for the other fruit crops. But at the same time, our demand is increasing because population wise, we are #1 in the world now. So there is need to focus on these food crops. As per the information of this PIB, which is recently published by the Ministry of Agriculture, that productivity of these temperate food crops in our country, if we compare globally, that is not satisfactory. So there is need to enhance or improve the productivity. So this is the biggest gap. If we leave this grape, because it is not grown in the temperate region, it is now shifted to the tropical region, although it is a temperate fruit crops. But in almost all temperate fruit crops, the productivity is very low. But the potential is very, very high if we compare with the advanced countries. So there is potential to increase the productivity by 2 to 3 times. At the same time, there is a negative trade-off balance. Means we are importing a lot of material of this either in the form of fresh fruits or the valued products or the processed fruit. So there is negative trade balance of around 13 lakhs 30,000 $760,000. So it is one of the scope. If we can meet the demand of our domestic requirement, then we can have the better opportunity. So what is the major concern of the temperate fruit? That we have the smaller area and the productivity is also less. So how it can be compensated? It can be compensated either through this vertical expansion and entering into the high density systems. There are many challenges has been listed in our country, that what is the major cause of low productivity and major causes of this kind of the thing is limited land we have, because most of the area is either lies in the mountainous and the hill region where the soil depth is very low. Soil fertility is also low. There is monoculture, limited varietal spectrum. There is no adoption of the high density, and certified quality planting material is also in scarce, and clonal root stocks also not available as the requirement of our country. So there is need for the systematic plantation. At the same time, pollinators. There are the senile orchard mostly, especially in Uttarakhand and the Himachal Pradesh, and lack of integrated approach for the disease integrated pest management. There is insufficient post-harvest management likewise. So these are some of the challenges. But how we can meet out these challenges? If we want to meet out these challenges, then we can convert these challenges into the opportunities, because we have the better productivity levels in these fruit crops and there is a huge market demand. And now these days, there is increasing awareness about the nutritional value. So we need the nutraceutical rich fruit crops. There is fast increasing economy. We can provide the produce to our country, not only to our country, but the other countries also. At the same time, there is need for the diversification. Wasteland can also be utilized. And these fruit crops are having the resilience against the climatic vagaries, and there is scope for the processing, export, and the huge potential for the businesses. But it can be achieved through making a strategic planning, that we have to go for the high density orcharding, diversification, and adoption of the new varieties. But how they can be adopted? Our institute is working.
वर्मा जी जरा जल्दी करिए भैया.
Sir. Okay. Through this genetic enhancement, so we have collected around 2,636 genotypes in case of the fruit crops. So here, these are some of the marvels of the apple breeding. They have gained a lot of gain, and not only in the country but internationally also. And we have identified that in the different maturity groups, as per the availability of the chilling hours, we can grow these some of the varieties. For the new generation apple production, especially for the high density, this variety has been introduced in almost all these temperate regions, especially for the Jammu Kashmir, Himachal Pradesh, and Uttarakhand, like the Super Chief, King Rod, Jiromin, Meme Master, Red Lamgala, Meme Master, and Shinigo, and the rare develops, they are doing very well. And our institute is also developed this scab resistant varieties, which are also promising as compared to the Prima and Priscilla, which are very acidic in nature, but these hybrids are having very promising characteristics. Likewise, in case of pears, these are some of the varieties we can harness, especially in case of the apricots. The productivity wise, especially these varieties are especially for the fresh consumption purposes. And in case of the peaches also, there are many varieties. This cherry is making a very good effort almost in Himachal Pradesh and this Jammu and Kashmir, because available the low chilling as well as the resistant against the rain-induced cracking. Almond, although it is very specific to the climatic requirement because it needs a dry summers, and we don't have except this Kashmir Valley, because Kashmir is only the monsoon free zone, because summer is needed in the dry conditions. Walnut is a very potential fruit crop, not only for the Jammu and Kashmir, but almost all the Trans-Himalayan region. And CITS has already developed the world-class varieties. They already expanded in about 500 hectares in our country, and we are providing almost all these 10 varieties to the country. And root stock is playing a very important role in not only in the case of the apple, but in the case of pear, apricot, peach, cherry, almond, and walnut. And the one of the aspects that how we can achieve the goals of our country, then the production technology, that is mainly through the high density technology, but it should involve, it is a package of variety, then root stock, training system, spacing. If we can combine all these three things, we can achieve the goals. I have compared almost all the production system, not only to our country, but globally, that the productivity levels are very, very achievable through adopting these technologies. So these are some of the peaks of our institute, where we have attained almost around 50 to 60 ton per hectare in case of the apple. And indigenous varieties also we have tried in these varieties also 40 to 55 tons. And many varieties, they have been classified for different purposes in case of apple. And this is the future of the apple, because in case of apple, the columnar variety may be going to play a very important role in the near future, because they are especially low chilling and they are having the columnar habits. They can be grown either in your kitchen areas, smaller areas, so they can assure the nutritional security. And our institute already started the breeding work in this program, because all the varieties are the patented ones. In case of the pear also, identity is playing a very important role. Likewise, in case of peaches, then plums also, and apricots, sweet cherries, almonds, we already established these high density orchards. In our country, this is the first institute that we achieved around 4 tons per hectare productivity, because our product is hardly 1 ton per hectare. But through the adoption of the new varieties under the high density system, we can achieve the productivity to the 4 tons per hectare. Again, the low chilling areas also having the potential to expand the apple cultivation. So these are some of the varieties in case of the apple. Then in case of pear also, in peaches, a lot of variability according to the chilling hours, ranging from the 50 chilling units to the even 1,000 chilling units available. And they have already been exploited, not only this Trans-Himalayan, but in case of the plains or the subtropical areas also. In nectarine soap, plum also, and almond also, it can be grown in the subtropical region, but only for the green almond, not for the dry almonds. Crop diversification in another area, although my friend Dr. Chaurasia has already spoken, there are a lot of fruit crops, they can be exploited on the larger scale. And in case of olives, we are trying very hard since last 50 years, but again, there is need to focus on the production technologies for this olives. Then walnut propagation is one of the challenging aspect, but we have tried and we already given this technology to almost all these states through the establishment of this budwood banks as well as through the production of the quality planting material. Then the insect pest management is one of the aspects. Here, mainly we are trying, especially for the disease diagnosis, then how we can assure the quality planting material. And recently, the government of India has sanctioned our institute for the CPP, Clean Plant Program. So we are going to establish the centers for this Clean Plant Program at the Srinagar and the Mukteshwar in case of Uttarakhand, as well as the PEQ centers. So I wanted to conclude that the health and livelihood are the prerequisite for the survival of the humankind, and fruit and nut crops are the real backbone of the humankind and the economy. Continuous varietal development is essential to meet the diversified needs, and adoption of the recommended strategies for the production of the fruits and nut crops is the key to achieve the goals. So with this one, I just wanted to thank the organizers who has given me this special opportunity to share my information with all the distinguished delegates and the all attendees to this conference. And this is my team who is playing a very important role for developing the varieties and the production technology. With this one, I just wanted to thank you one and all. Thank you so much, sir.
Thank you very much, Dr. Mahendra Verma. It was very, very useful talk. And we were close to the lunch. I think we don't eat any lunch now. We had a lot of fruits. And so thank you very much for this great presentation. Well, 2-3 points are there. Number one, which NBPJ should look into, whether this has been declared as the what do we call germplasm bank, NAGS. That is one thing. Please have a look on that. The second is that 2 important areas in fruits. Number one, introduction, because many of these fruits are introduced, exotic. So these systematic efforts for importing material for research purpose should be always there in your programs. The second is that there is a good scope for screening material right from rootstocks onwards. Rootstocks are critical. So please see that these areas are reflected. The presentation of all these people were very interesting. They were dealing with medicinal plants, fruits, vegetables, and other related materials. We have now variation. We will have the next presentation. Thank you very much, Dr. Verma. People were very appreciative of your talk. And your presentation will be shared by the delegate amongst the delegates also. Thank you very much.
Thank you, sir.
The next is Dr. Jagdish Singh is here. Okay. Dr. Jagdish Singh is Scientist G in ICFRE, Himalayan Forest Research Institute, located in Shimla. He is the head of the ये क्या है आपका head of the institute है? You are head of the institute?
I am a head extension sir.
Director बन जाना चाहिए अभी.
Director तो सर नहीं.
चलो बन जाएंगे इसके बाद.
ठीक
है. He has 26 years of research experience in the field of forestry, including medicinal plant, and more so in extension. He has developed varieties in Kutki, in Jatamasi, in Bankakadi, and he's going ahead with the commercialization of these varieties. This institute is located in Shimla, very important institution. So that's why we thought we will have a presentation from this institute. Please go ahead. You know the time constraint.
Yes.
10 minutes. Okay.
Thank you, sir. Most revered Dr. R.S. Paroda, Dr. P.L. Gautam, Dr. P.K. Khosla, chairman of this technical session, Dr. P.L. Gautam and Dr. P. V.D. Sharma ji. Thank you very much for giving me this opportunity for speaking in this very relevant seminar, national seminar I take this opportunity to thank Dr. Moore Singh, who was constantly in touch with me and motivating me to talk on this very important topic, the status and role of agroforestry in Himalayan agriculture production system. I will share just my few works which we have carried out in our institute rather than focusing on many things. As all of us know that India is a very vast country, and there is very high pressure on the natural resources. It occupies 2.47% of the geographical area, and it harbors almost 17.76% of the world population and 18% of cattle population. You can see the tremendous amount of pressure on our natural resources. We have only just 1% of the forest forest in the world forest, which has to be meet the needs of both human and cattle population. And this extraordinary stress on the forest has reduced per capita forest availability to tune of 0.7 hectare in a country, as against the world average of 0.8 hectare. So you can see that how much pressure is in our forest areas. So agroforestry, for the definition for the students, I think, as per the National Forestry Policy 1988, the objective of having 33% of the country's area under forest and tree cover from present level of less than 25% cover at this time. And so that for meeting this, the 33% of the country's area under forest, we need to forest almost 15 million hectare of degraded forest to be regenerated, and 28 million hectare under agroforestry / social forestry program. So there is much work to do. As one can see that there are benefits of agroforestry. All of us know that it provides the habitat for pollinators, it increases the tree crop, shields livestock and crop from the wind and extreme weather condition, of course, slows runoff, reduce soil erosion, and improve the water quality, build soil health, and also sequester the carbon, etc. These are the benefits of agroforestry. I don't go the much on this. Hanji, sir. These are the traditional agroforestry systems which are prevalent in the Himachal Pradesh. As far as Dr. Saab has told you that I will share my experience. I have developed some intercropping models of medicinal plants for diversification and income generating amongst the rural communities. As all of us know that Himachal Pradesh, in Himachal Pradesh, there are almost 84% of the farmers are marginal and small. So in that case, we say that you do the cultivation of medicinal plants, but the question is where they will cultivate these medicinal plants. Small land holdings already there. But in that case, I thought that why should not some medicine plant, especially of the high temperature medicine plant, should be grown in the intercropping models, particularly in apple orchards or cherry orchards. So while coming to this mind, I just submitted the one project to Department of Biotechnology in New Delhi, and they happily funded this project, and I will share some. These are initially, I have chosen the 5 medicine plants for intercropping of these medicine plants, particularly the Aconitum heterophyllum, Picoraza Karua, Angelica glauca, and then Valeriana jatamasi. In the morning, sir has already highlighted that there is it's a challenging task that we should get the quality planting material. For that, it is I want to tell the house that HFRI has already developed the varieties of some of these medicine plants based on the high AI contents and the yield. So, which we are going to mass multiply them and giving to the farmers later on. So initially, I have tried these four or five medicine plants in cropping of these medicine plants with horticulture plantation. You can see the scenario in Himachal Pradesh. This is particularly when I was in school, all these areas were under paddy crops. Now it has turned out to be a horticulture. So under this horticulture crops, we are integrating these medicine plants as a this is the scenario. If during the initial phases, I have made some this kind. You can see the horticulture plantation. There are enough interspaces. So in the interspaces, I have made the nursery beds where we can intercrop these medicine plants. One thing I have assured a farmer that if you are going to cultivate these medicine plants in your horticulture crop, one should go for the organic farming, because in apple orchards, people do a lot of sprays and etc. So that might affect the quality of the products produced later on. But I insist that you should go for the organic farming. But in case of Angelica glauca and Valeriana jatamasi, we go for the essential oil. So essential oil is we get by distillation methods. So the effect, the insecticide effect may be nullified thereon. So these are some of the uses of the medicine plants. I need not to mention here. You can see the photographs, vermicomposting. These are the glimpses of the picture. You can see the photographs. Intercropping of Aconitum heterophyllum with horticulture crops, Angelica glauca. This is Picoraza carua, Valeriana jatamasi, and then Polygonatum verticillatum. This is Angelica glauca, Picoraza carua again, Valeriana jatamasi. These are the utilizable parts. Aconitum heterophyllum, this is the roots. Polygonatum verticillatum, jatamasi, then Picoraza carua. These are the commercial parts which we sell in the market. Then one of the question was that, okay, we are getting these products very well in the market, in our horticulture plantation. But what are the AI contents, whether it's present there or not? So when the project period was over, we harvested our medicine plant samples from the intercropping model and same time from the natural condition, and compared the contents, especially if you see the Picoraza carua, Picroside 1 and Picroside 2, natural habitat 4.33, intercropping model, a total 1.58. There is, of course, there is some reduction in terms of AI contents, But I think, Acha, sir. Only in case of Picorella there was some reduction, but others you can see that there was no significant reduction in terms of valopetrate contents in Velanigetamansi and also in Polygonetum verticillum in terms of alkaloid contents, etc. So I mean to say that when we take out the samples from our intercropping model and went to sell it in the market, the local vendors were readily available, ready to buy our samples. So I can conclude that one can successfully intercrop these medicine plants with horticulture plantation, provided if you go for the organic. Another thing, most of I think most of you may not seen this plant. Have you seen anybody can see? Have you seen this plant? Well, it's a Polonia. It's a native species of China. It's a very fast-growing species, just like a poplar. Under ideal condition, within 4 to 5 years, one can harvest it and sell it to market. So I was in Dehradun, and I was very much fascinated by this plant and tried to introduce in Himachal Pradesh also. If it's a very fast-growing site, one must try to integrate in our AF system so that we can meet the bona fide need of food, timber, and fodder, etc. So I have already introduced these species in a different agroclimatic zone of Himachal Pradesh. Can you believe that this is the 1-year plant? In Kullu, it had attained the height of 15 meter with a GBH of 35 centimeter within 4 years. If you visit now in Kullu in Dhalpur, there is a local bus stand wherein some of plants are still there. You can see it live there. This is the Paunta in Johoro in this is in Dharamshala, Solan, Darja in Solan. You can see the plants growing in the bunds, agriculture bunds. Beautifully it's growing. In Dharamshala, then Badagaon, Shimla. If you visit our institute, you can see these plants. In Palampur, we have intercrop these plants in tree. Beautiful flowers in the especially springs during the spring season. Lots of flowering is there, wherein lots of bees are there. So मधुमक्खी पालन के लिए बहुत ही एक आदर्श जो है वृक्ष जो है साबित हो सकता है ये. Then I have studied some of the existing agroforestry system in different agroclimatic zone of Himachal Pradesh. बिल्कुल सर. Okay. Yes, sir. बिल्कुल sir. These are the existing some of the systems in Himachal Pradesh, acacia base, then salix base in high areas. But last sir, Populus nigra base in high hill zone of Himachal Pradesh. So thank you very much, sir.
Thank you. Time was a constraint. It was a different kind of presentation. In fact, I thought of we will make a reference of sacred groves, sacred forests. I thought of that there will be reference of some of your like pineatum, populatum, arboretum, etc. Please put that information in this presentation. That will be quite useful. We will appreciate that. We had constraint of time. You can further enrich it. Morsing, make it more on genetic resources. कहाँ है morsing? ठीक है, नहीं, ये भी serious नहीं था अभी. ठीक है, okay. There are two things. Either we break for lunch, then we have the poster presentation, or we have the poster presentations, then have big lunch. This is a rapid. I don't know how rapid. So, and there will be timer, electronic timer. After that, I can't help. So the time given is 3 minutes, or rather 4 minutes. Very good. They will be with us. And timer भाई लगा दो, मेरे से मानते नहीं है लोग, ठीक है? तो अब आप लगा दो. So the first rapid oral presentation is by R.K. Pamarthi. बहुत सारे co-author है इसके साथ, Mr. D.P. Sernwal. And दूसरा नाम नहीं पता चल रहा है, चेतन है अंत में. Then P.K. Singh. Yes. Okay. You are going to make presentation expedition of PGR diversity in North-West Himalaya of India.
Yes, sir.
Please go ahead. You are Paramarthi?
Yes, sir.
Okay, good.
Good afternoon to one and all. Myself, Ravikishore Pamarthi, working as a scientist in the Division of Plant Exploration and Germplasm Collection, ICAR MBPGR, New Delhi. And now I am presenting the expedition for collecting PGR germplasm diversity in the parts of northwestern Himalaya, India. Actually. And this is my explored areas and villages. It is mainly Jammu Kashmir and Himachal Pradesh. These are the major collections, and target crops are grass pea, lentil, faba bean, linseed, mustard, and malva species, and other seedable jowar also there. And here downside I given Himachal Pradesh, that is agroclimatic zones, and Jammu Kashmir also agroclimatic zones. And sir, this is I followed the explored strategies adopted, which is focusing on collecting as seeds and more focus on wild species and crop progenitors. And I depend on the ITK documentation and herbarium specimens of silent and new species of potential. And what are these are the major hurdles, and this is a scientific outcome. And this is Vicia faba collections. And these are the byproducts, and some people are using as a splitted pulse also. And these are the three diversity, that means color diversity of the Vicia faba. And this is one of the potential crops. So this is Lathyrus sativus and Lathyrus opaca collections. And one more thing is there is no germplasm of Lathyrus pyrrhicus and Lathyrus ochras. Actually, these species also we have to collect in the next thing. And so these are the cowpea collections. And so these are the some of the list of wild species, Vicia tetrasperma and Solanum virginianum, Solanum torvum, and Solanum violaceum. And so by additionally, I collected the orchid species also. Out of this, and 4 orchid species we sent to National Research Center for Orchids, Pakyang, Sikkim also. They are maintaining in field gene bank. And so these are the some of the herbarium specimens of different wild species we collected and deposited in the National Herbarium of Cultivated Plants in New Delhi. And so this is, and sir, after this exploration, what is the work? That is a characterization of the species, and most probably as a botanist, actually we categorize that is a crop and wild species, and we developed the morphological key, that means additional what are this. And this is Elisine indica. It is widely available in India all over, and under harsh conditions also it will grow. And this is cultivated species, Elisine corcana. In this Elisine indica, we developed one additional key, that means morphological distinction, and how to, that means easily we can identify the keys. And so this is Saccharum also wild, Saccharum spontaneum and Saccharum officinarum. And Saccharum spontaneum, what is the difference? That is culm and stem difference also we given. This is morphological key Saccharum spontaneum. And sir, And sir, more there is a additional case. Actually, Indian Center is also that means very famous for the Solanum germplasm. Actually, this is locally highly available. That is, sir, here I represented the photoplate of Solanum virginianum. That means the plant to seed. That means this is useful for the easy key identification of the wild species. And here we given a Solanum diphyllum. And sir, one interesting character is one interesting thing. It is a case study. Everyone generally we know that is Arevella viscosa. That is a synonym of Cleome viscosa. It is widely available as a weed in entire India. And so this is one study is that is it is a commercial production of seeds while undergoing exploration also in southern India, Andhra Pradesh and Telangana. They are using for the commercial production of the these seeds, and simply they will harvest the plants and they will keep on the roads and they will dry after the thrashing by the vehicles. They will collect seeds and winnowing, and they are using as a I think probably that is Jakia Alu. It is a very famous in Uttarakhand. And sir, this is for enhancement of that chili powder. That is a flavor, sir, actually. And we published it is in Grace journal. And sir, while coming to conclusion, there is some unattended crop species and medicinal aromatic plants, forage crops and agroforestry trees, some ornamental species also there. And we need to strong collaboration with other organizations. That means for tapping the wide diversity. And some border regions also, that is tough to collect the germplasm, that we have to do the thing. And lost or uncultivated. Yes, thank you, sir. Thank you.
Thank you very much. It
Yes,
was
sir.
nice, and we will take note of some of the things which you have presented. They will be reflected in the recommendations. The next presentation is by Saramvista Naik. She is not here. Then we move to the next Bipan Guleria, who is from Vice from our University of Horticulture and Forestry, based at Jaj. Co-authors are Amol Vashisht, Renu Kapoor, Rajesh Kaler, धर्मेंद्र कुमार. पूरा शहर है भाई, बहुत ज्यादा लोग हैं. ठीक है. अच्छा, ठीक है. His presentation is interventions for conservation, productivity enhancement, and nutrient assessment of medicinal and edible forest species. Yes, Bipin ji, presentation करिए.
ये शुरुआती slide पीछे करेंगे. When there was inauguration session, I was just thinking that what I have done is irrelevant to this because I am a man of forestry, silviculture. So biodiversity, but I thought that my all objectives are met over it. But Dr. Sanjay said is almost met, local, commercial utilization. And I have worked on Cordia mixa lusuda, and we are successful in developing 5 strain of it. We have quantified and characterized this chemical analysis through NB, the CSIR Palampur. We have published very good paper in American Journal of Food Sciences. I'm thankful to Dr. Sanjay and his team for helping me when I was doing this work. Next. These are some of the objectives what we do with the local species. Next. चलता ही नहीं है.
चल नहीं रहा है. जरा बात करो. बात करो भैया.
ये आपका सिस्टम फेल है सर. मैं तो ऑन टाइम. मैंने तो सोचा कि 3 मिनट में कंक्लूड कर दूं. मैंने इसलिए आपका भी वेलकम नहीं किया. मैंने कहा 1 मिनट मेरा खराब हो जाएगा. कोई बात नहीं. ये एक ऐसी स्पीसीज है जो हम कहते हैं बहुत ज्यादा हिमाचल में होती है, लेकिन जब मैंने इसका सर्वे किया तो सिर्फ 46 प्लांट मिले और इसका सीड बहुत डैमेज होता है, ये होता ही नहीं है. और इसकी इतनी यूटिलिटी है कि जितनी भी ड्रग्स बनती है आयुर्वेदिक ड्रग उनके फॉर्मुलेशन में चलता है. और मैं आपको दिखाऊंगा बीच में जब ऑन होगी कि हमारे इस इंटरवेंशन से लोगों की इकोनॉमी में कितना फर्क पड़ा है. और हमने इसको केमिकली कैरेक्टराइज किया. एंटी कैंसर इसमें प्रॉपर्टीज हमने 52 केमिकल्स हमने इसमें आइडेंटिफाई किए हैं थ्रू CSIR. और इसके अलावा जो है ये हमने इसको हाई डेंसिटी में ला रहे हैं. और फार्मर हमारी प्लांट डिमांड, चलिए इस दौरान हमारी प्लांट डिमांड जो है लगभग मैनी टाइम्स इस स्पीसीज की बढ़ी है एंड वी आर गेनिंग नेम इन दिस स्पीसीज। इससे पहले हमारा हार्ड पे काम था एंड वी आर लीडर इन दैट इन द होल वर्ल्ड, होल कंट्री। जी सर, देखिए इसमें हमने इंप्रूवमेंट का जो मेथड लिया वो बड़ा सिंपल लिया, क्योंकि फॉरेस्ट्री में बड़े पैसे कोई खर्च नहीं चाहता। तो हमने जो जेनेटिक मेथड से जो पढ़ाए जाते हैं जोबेल की बुक में, वो हमने छोड़ दिए। उसमें यही था कि 10-12-40 साल के बाद स्पीसी निकलेगी, कुछ निकलने वाला नहीं है। देन वी ऑप्टेड द हॉर्टिकल्चर अप्रोचेस, दैट इज वेजिटेटिव मेथड्स। वी सिंपली सिलेक्टेड द प्लांट्स इन द फील्ड, वी सर्वेड them, we did phenotypic and genotypic advanced parameters, all that, and then we selected the strains, and those strains were brought to our station and we just multiplied through vegetative means, and we have standardized many things and we also characterize them. Next is, चलते जाइए अब मेरे हाथ में आ गया ये सर। ये देखिए, it is found in all the world, all over the world, but it's a dry area species, but found all over the world and mostly used in desert area, and it can be a good climate resistant species in future. This is what we have selected, these areas, different areas. This is the genetic parameter we have studied the species. These are the method we have tried, but I've told you. These are the methods. This is the technology, simple technology. We have simply captured a variation and kept it at that space. We didn't bother about the stabilization of, because vegetatively the variation whatsoever they may be stable, may be unstable, that is there because of that vegetative propagule, that variation will not change. What is doing horticulture paper, we have tried in forestry and we are successful and we are getting good response regarding this. This is the technology, but we have standardized. These are the 5 variations which we have found, and we have applied to NBPGR for their accession number, and shortly we will develop as a variety and get it recommended in the university as well as through NBPGR. These are the 4 or 5 where we have done multi-location trial also, so that the species variation and what the product we get has some variation or not. These are some of the chemical characterization which we have done. We have found 52 phenols, then amino acids, then chemical analysis, flavonoids, all has been standardized with high precision in CSIR lab. These are the some of the things which we have done. And one good thing what we found is rare plant which fruited in first year, and we have submitted the paper in this US journal, and it is under review, because it's very rare that in first year some tree species bear fruit. And what we have found through CSIR, what we have analyzed, their chemical, the level of the plant phenols and all are almost equivalent to the fully grown tree, which means which bear fruits after overcoming the juvenile period. So this is the new thing we can, biotechnology other people can try, that make the tree young at very fast pace. The future, there is some future hope also with our finding. These are some of the chemical which we have noted our variations. And these are some of the methodology which we have standardized. ये तो चल ही रहा। ये दिस इज मेथड, मैं आपको एक क्लास में स्लाइड दिखाना चाहता हूँ। ये देखिए, जैसे हमने इंटरवेंशन की, इसका 1 किलो 2 किलो फ्रूट भी मार्केट में नहीं मिलता था। जैसे हमने इंटरवेंशन की है,
बारिश हो रही है,
इसका प्लांट जो डिमांड हमारे से आई है थाउजेंड्स में हो गई है। वी आर सेलिंग अराउंड 9 to 10,000 plants every year, a grafted plant to the north region. So this is the simple intervention done by us, can do this wonder, and people are demanding it. We are in demand. With this, I thank you all. Thank you, sir.
Thank you very much. Well, this is very important tree, and I think collection का भी कुछ करिए। Scattered होते हैं इसके plants जो होते हैं, तो इसको collection का program में इसको डालना चाहिए हमें, इस तरह के minor fruits, and ये medicinal plant भी है। Next and the final in this series is Dr. D.D. Sharma. He is from Shoolini University. Co-author is only one, Sharia. Topic is reaching the unreached farming community through recent extension methods. He is extension person.
Now,
Look.
good afternoon
Sharmaji,
and
please go.
namaskar to all. There is no use of any technology or innovation unless and until it reaches the man behind the plow. And here comes the role of extension education. Yes. Now, there is a still wide gap between the rich persons and the poor fellow. Though we have tremendous production, we have increasing the production we have achieved because of the green revolution, but still there is a gap. Now, adoption is not an instant act. All we know, a farmer must undergo through 5 stages, and these are before you: awareness, interest, evaluation, trial, and adoption. And unless and until we disseminate any technology which has certain characteristics, the farmer will not come forward to adopt it. And the technology must contain these traits: relative advantage in terms of profitability, simplicity, trialability, communicability, and predictability. Yes. Now, this is the adoption model I am using of our respected professor, renowned Professor Dr. Raghveer Singh, PAU Ludhiana. He said that he gave this model because there are 4 reasons why a farmer doesn't come forward to adopt our technology. And these are ignorance, unwillingness, inappropriateness of the technology, and inability of the farmer. Then, yes, these are certain challenges which we are facing in agriculture, like declining water table, deterioration in the soil health, and outbreaks of new disease and insect pests are coming. Environmental pollution and climate change. Yes, Indian agriculture is at a critical juncture now. Now, these are the main focuses we want that if you want to compete in the at the global level, 3 things we will have to keep in mind. Our focus must be on higher productivity, low cost of production, and high quality produce. Next one is. Now, this is the paradigm shift we want from our conventional, traditional extension system to market-led extension system. Our conventional, traditional system used to give more emphasis on dissemination of technology. But in this new system, we want that our farmers must be able to. We want to enable our farmers to get optimum returns out of the enterprise. Earlier, our main focus was this farmer research scientist and this linkage, but we have extended this to the market as well. And earlier, the farmers are not required to maintain records. But here in the present system, the farmer have to maintain record because we want that he must know what is the benefit cost ratio. Then, yes. This is the crisis the present extension worker has to face. 4 types of the crisis the extension worker has to face nowadays. One is this knowledge crisis, efficacy crisis, and what happens if the extension worker gives any wrong information to the farmer can sue him in the court also. The extension worker must be very, very careful because he will have to give accurate and up-to-date information to the farmer. And second, we'll have to provide the training to the extension worker to update their knowledge and skill. If we don't do it, they will not be able to perform their multifarious duties. And now this is the model I have given based on my experience and on my for the last 34 years experience. This model is based on just our healthy body, because whatever the input we take in the form of good food, balanced diet, and if all the systems they are working very good, and that comes under our process system, and then end product that we will be healthy. And similarly, the case will go to TOT system, and this is the system we can discuss later on. And how can we reach the farmers? Yes, these are the modern methods by which we can reach. Cyber extension, internet, email, expert system, all you know, there is no need to discuss about it. Internet browsing, video conferencing, community radio, Kisan call center. Yes, this system is working at 3 levels, level 1, 2, and 3. If level 1, the farmers, this problem is not solved, then it goes to the second level. At first level, the headquarters is Chandigarh. And here the agriculture graduates are sitting, and they will have to solve the problem within 72 hours. If these problems are not solved, then okay. And now the toll-free system is, farmer call center, 1800 180 1551. Thank you very much.
Thank you, Sharma ji. Ladies and gentlemen, this comes to the end of this session. Long session, but very interesting session. Not because both of us were co-chairing, and not because that there were so many presenters, but it has lot of content, lot of material, emphasizing the importance of minor fruits, vegetables, and the local food systems, medicinal plants, and so on. A lot of information has come in, and hopefully the presentation will be shared with you people. And you can also ask questions, open some site where question can also come. You can go on improving this. That will be very good. We will not have any question answer because it is going to rain outside. And then there is a problem for taking you to the food site. So with this, we will, you will bear with us that I am concluding this session with the permission of my co-chair that you would like to say something. Okay.
My only remark is Dr. Sanjay has given us a clue that you are cultivate and then commercialize it. Because so far, all our efforts in agroforestry, tree crop, animal systems, whatever these are still a theory. There are very few success stories. I'm talking especially the hills. I'm not talking about the plains. Plains, there is a success story. But we should now go to that direction. Then putting the processing unit along with the medicinal plant, that is also key to success. But if the farmer grows any species of aromatic or herbal plant, what he will do? I have seen when I was a director of extension education, it was a problem. People used to come every day. Yeah, hum kya kare? Hamare to medicinal plant lag gaye. And there is no such system. But if the processing of the herbal plants is at the rural or the block level, then there are buyers. People can buy your oil or your the powder material from the herbal plant. All those things are to be taken into account. Thank you very much.
Thank you, Dr. Khosla. We had two very sincere co-chair, reporters. Dr. Gautam started the stage and Dr. Sharma is on this side. Sharma ji, एक शब्द कहेंगे? ठीक है, ठीक ठाक है. बस he says it's okay. So with the permission of all people here, आप कहेंगे कुछ? We come to the close of the session. Some formalities by the anchor. Yes.
So we'll be proceeding towards the felicitation ceremony. So quickly we'll do that. हाँ जी sir.
कैसे कैसे है तो बुलाओ किसको बुलाओ ना.
Okay, so I would like to invite our co-chairs, Dr. P.L. Gautam and Professor P.K. Khosla, sir, to felicitate the speakers of the technical session 1. Dr. Sanjay Kumar. Okay, sir. Okay, sir. Dr. Sanjay Kumar, Chairman ASRB. Thank you. Second speaker, Dr. O.P. Chaurasia, Bihar, Leh, Ladakh. Thank you. Third speaker, Dr. Lakshmi Kant, Director ICAR, VPKS, Almora. Fourth speaker, Dr. Jagdish Singh, ICFRE, HFRI Shimla. And a special thanks to our speaker who have joined online, Dr. M.K. Verma, ICAR CITH Srinagar. Now, I would also like to request Dr. R.K. Tyagi, Vice President ISPGR, to felicitate our rapporteurs for the technical session 1. Dr. Kuldeep Tripathi, Scientist ICR, NBPGR, New Delhi. A big round of applause, please. Thank you, sir. Second rapporteur, Dr. Vinay Kumar. Dr. Vinay Kumar, Shoolini University. Thank you, sir. For felicitating our conveners, I would like to request Dr. D.K. Vatsa, PC, CSHP, KV, to felicitate Dr. B.D. Sharma, Eternal University, Baru Sahib. A big round of applause, please. Thank you, sir. Second, we have Dr. R.K. Gautam, Head of Evaluation Division, ICR, NBPGR, New Delhi. Thank you, sir. Now I would like to request Dr. B.S. Dhillon, former Vice Chancellor, PAU Ludhiana, to felicitate our co-chairs, Professor P.L. Gautam. A big round of applause, please. And our second co-chair, Professor P.K. Khosla, sir. Thank you, sir. Thank you, everyone. And now we'll be proceeding towards a very important session, that is a lunch break. Okay, so that we'll be having at the parking lot, and volunteers, please assist our guests. And a very important announcement for the poster presenters. Posters will be assessed during the tea break, and delegates are requested to be present during that time. Yes. Sir. So we'll be like meeting after 1 hour, exactly after 1 hour, and 45 minutes. Okay. And remaining posters will be assessed tomorrow during the tea break. Yes, sir. Conclusion of second session. कितने बजे? After conclusion of second session. All are requested to please share your presentations for the technical session too. Please.
I invite Dr. Sudesh Kumar Yadav, please come here. Guys, yeah. Respected dignity on the dais and off the dais, I have the great privilege to introduce our co-chairs, Professor Valdesi Dhillon. Professor Dhillon has a brilliant academic career, starting from his graduation from Khalsa College, Amritsar in 1963-67, to MSc in genetics plant breeding from India's one of the best agriculture university, PAU, Punjab Agriculture University, Ludhiana. Then his PhD from world's renowned agriculture institution, IRA, New Delhi, in 1967 to 69. The icing on the cake was that he got several internationally recognized fellowships, including fellowship, very prestigious fellowship from Germany, 1976, 77, 76, 78. Then another very prestigious fellowship, that is Alexander von Humboldt Fellowship in Germany in 1988, 89. Then again he got one European fellowship, then University of Hohenheim Fellowship in Germany, 1990. He has a brilliant career as a scientist, starting from his alma mater, PA Ludhiana, as assistant maize breeder, then rose there to the director research, then also he served for a short time in Simit, Mexico, internationally recognized institution, research institute. Then he was the director IRA. Before that, he was the ADG in ICR and a full-term director of ICR NBPG New Delhi. And he served as the pinnacle of agriculture administration, education, and research as the vice chancellor of very prestigious Punjab Agriculture University, Ludhiana, for a decade, starting from 2011 to 21. He has several awards and recognition, starting from his academic career, IRE Gold Medal, very prestigious in 1974, ICR Rafi Ahmed Kidwai Memorial Prize in 1986-87, then Punjab State Council for Science and Technology Appreciation Certificate in 1993, then Indian Genetic Society Dr. Joginder Singh Memorial Prize in 97-98, Om Prakash Bhasin Award 2006, then ISPGR's very prestigious Dr. Harbhajan Singh Memorial Award in 2009-10. He also got DST's JC Bose Fellowship 2013, NAS Recognition Awards, Punjab Academy of Sciences Lifetime Achievement Awards, Simit Maize Champion for Asia Award in 2018, Dr. A.N.L. Dhawan Award, Lifetime Achievement Awards, Maize Technologist Association Award in 2020, Krishi Samman, Ceremony Samman Lifetime Achievement Award 2020, and most importantly, the Government of India bestowed him the Padam Shri in 2019. Besides, he has two very prestigious fellow of two academies, Indian National Academy, Science Academy, and National Academy of Sciences, India, and Punjab Academy of Sciences. His research area is plant breeding, especially he's a renowned, internationally renowned maize breeder. And we know him as a doyen of quantitative genetics and plant genetic resources and biotechnology. So we welcome you, sir, from our core of the heart. Our co-chair second, Professor Atul Khosla, a young and dynamic vice chancellor of this very prestigious Shoolini University. He has done his BTech from India's one of the best IIT Kanpur, and MBA from JBIMS Mumbai. He drives a new initiative at Shoolini, initiating partnership with industry and top global universities, starting new innovative academic programs
transforming a traditional system to new methodologies of pedagogy and initiating a skill-based curriculum by building one of India's most dynamic and cutting-edge education technology platform. He has served with the McKinsey and Company and as a consultant for more than 25 years. And he advised clients not in India, but also in Asia, North America, Europe, and Australia. Professor Atul was an advisor to MMC's global board on building the company's global operating platform. In addition, Professor Atul led Oliver Wyman's initiative to build a global risk advisory operations business in JB with a global outsourcing measure. Professor Atul is also served as Dean of Faculty of Management Sciences and Liberal Arts at Shoolini Institute, and he teaches finance and strategy. He also a guest and visiting faculty at several Indian global universities. So with these words, we welcome both of the co-chairs, and I invite our conveners, Dr. Dharampal Walia, to introduce the lead speaker. Thank you.
Thank you. In this session, we have one keynote speaker and 3 invited lectures, but I'm sorry that there is a little bit change in the program. Shri Ashish Barwale has to go, and we would like to introduce first him. Shri Ashish Barwale graduated in science from Cornell University and did his MBA from Harvard Business School, Boston. And he has international exposure of public-private partnership since he started his journey with International Division of ITC and handled a number of research projects to disseminate knowledge and investigate solutions for low agricultural productivity in India. He is working on to reduce post-harvest losses of agricultural production in India. He has introduced science of genetics in horticultural industry to solve the needs of growers and the consumers in India. And now Sri Barwale is focusing for creating an organization which contribute to increase horticultural production and also establish domestic nursery industry in India. I would like to invite Sri Ashish Barwale to deliver his talk.
Thank you, Dr. Sir. Thank you very much. Thanks for this opportunity. Though I have passed by the road many times, the first time I entered the university. So thanks to the organizer, Dr. Paroda and Dr. Gautam. Tyagi Saab kahan gaye? Vice President Agarwal, and for this opportunity to see this unique place. I have not seen such a place earlier. I have seen many places in Himalayas when I was in ICR. So thanks for this opportunity. Gentlemen, coming to the program, I have taken permission from the co-chair. He will be giving some comments at the end. You all must have attended the forenoon session. And if you see the difference between, I feel proud of NARS. Don't think that I feel otherwise. But if you see the difference between the presentation by the gentleman, CATH, he had listed 10, 12 points, all are relevant, all are, even he has mentioned processing, etc. also of the fruits. But when you see the presentation, which I like the most by Sanjay Kumarji, Dr. Sanjay Kumarji, industry world is missing in our presentations. And the reason is when SAU's Agriculture University came to existence, first one was 1960, Pantnagar. PAU was third, second was Orissa. At that time, we didn't have enough to eat. So our focus had been on production. There should have been some correction maybe in last 20 years or 30 years. So that is the time. My colleague said that, sorry, we have to rearrange the program. In fact, I felt happy when I was told. I was thinking myself that this presentation should come first. And my request, Ashish, you have 15 minutes. We will give a ring. I have asked them. For me, I have never, my colleagues from NPG are here. मैं कभी भी कोई भी मीटिंग विच नहीं छड्डी और रात ਨੂੰ ਲੇਟ ਤੱਕ ਮੀਟਿੰਗਾਂ ਚੱਲਦੀਆਂ ਰਹੀਆਂ ਕਿਉਂਕਿ ਡਿਸਕਸ਼ਨ ਤੋਂ ਨਿਕਲਦਾ ਕੁਛ ਨਾ ਕੁਛ ਲਿਮਿਟੇਸ਼ਨਸ ਦੀ ਗੱਲ ਹੋਈ ਸੀ ਐਕਸਟੈਂਸ਼ਨ ਵਾਲੇ ਜਿਹੜੇ ਸੱਜਣ ਸੀ ਜਿੰਨੇ ਤੱਕ ਅਸੀਂ ਇੰਟਰੋਸਪੈਕਸ਼ਨ ਨਹੀਂ ਕਰਾਂਗੇ ਵੀਕ ਪੁਆਇੰਟ ਕਿਹੜਾ ਵਾ ਉਹ ਤਾਂ ਹੀ ਪਤਾ ਲੱਗੂਗਾ ਇਸ ਕਰਕੇ ਸ਼ੀਸ਼ ਟੇਕਿੰਗ ਪਰਮਿਸ਼ਨ ਫਰਮ ਯੂ 2 ਮਿੰਟ ਬਾਅਦ ਵਿੱਚ 3-4 ਕੁਐਸਚਨ ਨੇ ਸੋ ਇਫ ਯੂ ਕੈਨ ਫਿਨਿਸ਼ in 12 minutes or so or 13 minutes, I will, or we all will feel very, very happy. Young ਬੱਚੇ ਬਹੁਤ ਆ ਸਾਨੂੰ ਉਸ ਪਾਸੇ orientation ਦੇਣ ਦੀ ਜ਼ਰੂਰਤ ਹੈ. We all the time focused on farmers. You felt happy that we have lack of farmers in Kisan Melas, right, during last 10 years or so. But that's all. When I have talked to my colleagues in maize, I said that you have failed me. I tried everything to produce hybrid seed of maize in large quantity. 300-400 क्विंटल से ज्यादा प्रोड्यूस नहीं कर पाए क्योंकि हमारी ओरिएंटेशन है और साइड पे. So senior colleagues and other participants and students, we have an opportunity to listen to a person from the leading, or I will say topmost seed company in India. And just one point more, his grandfather started business in Pusa Savni with the help of Dr. H.B. Singh, and they have excellent relationship with the IERE and NBPGR. And Shri Barwale ji, his grandfather, got World Food Prize also. So Ashish, please.
Presentation.
Respected Dr. Paroda, respected Dr. Gautam, Professor Dhillon, Professor Khosla, dignitaries on the dais, students, ladies and gentlemen, thank you for inviting me here. For me, this is as much of a learning experience as it is for you. As Professor Dhillon said, I will try to keep it short, describe what we are doing in our role in this industry, and then welcome any questions. So for today's presentation, as Professor Dhillon said, I come from a business that has worked towards the development of the agriculture industry in India, primarily through seeds. Today, I would like to focus on our horticulture division, which has primarily taken on the responsibility of producing planting material and introducing new genetics, specifically for the apple crop. I think it's important for us to first describe our values and really how this business started and what we represent. And for that, I think it's important to talk about my grandfather, whose vision was always to put the needs of the farmer first. I think that's been our guiding light, and we continue to follow that in all our endeavors. So I'd like to start with the overall situation of apple in India. As you know, apple is a very common crop in India. You may not know, but apple takes up about 300,000 hectares under cultivation in India. And it's at the present time, it's the second largest area anywhere in the world. So barring China, we have the second largest area. That's a large area, but unfortunately, we look at the second and the third column. It's not where we would like to be. Our productivity is not second highest. In fact, it's one of the lowest in the world at 7.5 tons. And that leads to a low overall production of between 2 and 3 million tons, given every year, average of 2.27 million tons. I feel this is as much of an opportunity as it is a challenge. And it's just about how we perceive this. We look at it as a great opportunity to increase production and contribute to the development of farmers in India. And I will describe some interventions that we are trying to make to help towards this cause. First, to identify the problems related to apple productivity, there are a number of issues. Of course, we have environmental factors which are not really under our control. We have to learn to adapt to the situation that we have on the ground. We also have the problem of genetics. You know, when apple was first introduced more than 100 years ago in the country, it was primarily one variety, which is the Red Delicious, which still makes up more than 90% of our area under cultivation, and this has its own challenges. We have the challenges of apple being produced through very old, traditional, more hobby type of cultivation mechanisms. So it's not really industrial agriculture as it is in the rest of the world, but more so, I would say, a hobby type of agriculture. And I'll talk a little bit more about that in the presentation. Something that's very important is the use of new rootstocks, primarily dwarfing rootstocks, which have really kind of been prevalent all around the world in the last 20 odd years. It has just started to come into India, but this is one major factor which contributes to the low productivity. And then we also have other factors like non-availability of the right type of inputs, soil nutrition, testing, and things like that. You know, and we always ask, right, like, why is it important for us to increase productivity? Of course, we know that it contributes to the development of farmers, increase their income. But the question always is there a market? If we do produce more, will there be a market for our production? Just to give you a reference point, I mentioned China earlier. China today produces 40 million tons of apples. We are at 2.5 million tons. Right? If you see the per capita consumption of apples in India, it's 1.5 kgs, whereas it's 10 kgs plus for the rest of the world. So our belief is that the demand for apples in India continues to increase. That's also represented by a very large import of apples into the country. So you see, we have more than 400,000 to 500,000 metric tons of apples being imported. So we're actually paying farmers from other countries to produce fruit for us. And therein lies the opportunity. So coming to today's topic, I think it's related to the introduction of new genetics. And given our history of being a research-oriented seed company, I think this is the first step that we wanted to take, was to introduce the best genetics that are available in the world to Indian farmers. And the first step in doing that was the introduction of the Geneva rootstocks. The Geneva rootstocks are bred by Cornell University in their Geneva station. It's a very well-renowned program of very historic repute. The goals of this program are multifold, and I'll describe that a little bit more. But the idea is to produce rootstocks which are naturally dwarfing. And the reason to have dwarfing rootstock is to increase the number of plants in a certain area, which results in higher planting densities. So even though your per plant yield would go down, but you're moving from, say, 200 to 300 plants a hectare to more than 3,000 plants a hectare. This also contributes to a more two-dimensional type of structure. And the idea is to allow more light penetration onto the tree, so that the tree produces more reproductive growth or fruits rather than vegetative growth or green leaves and stems. So if you have a very traditional orchard, you have a lot of fruit on the outside, and then as you have lower light penetration towards the inside, you have lower number of fruits, leading to low yields. This also enables more scientific management of the farm, easier application of fertilizers and pesticides, easier management of harvesting. So there's a number of added benefits in addition to that. In addition to dwarfness, as you see on the slide, there are other factors that the rootstocks also contribute to, and some of those are resistant to replant disease. So in Shimla or Himachal, primarily we have no fresh land available, but primarily the plantings will be done on used lands. And replant disease is a phenomenon which is very prevalent, which results in a direct impact on lower production. And these rootstocks are known to be tolerant to those replant diseases, in addition to other diseases like woolly aphid tolerance, crown and root rot Phytophthora. These rootstocks are very well established in the US now. As you see the numbers on the slide, more than 100 million rootstocks have been sold and used in the US, and in other parts of the world as well, the use is increasing. So they have demonstrated potential on the farm. And we are very excited to start introducing these into India. There are a number of selections that we're focusing on here. And if you just compare to the seedling rootstock, which is right on towards the right of the slide, which is the normal length, what we call 100% in terms of height. And then you go towards the other end on the left, which is the absolute increasing in dwarfiness. So for the Indian market, we are focusing on some of the highlighted ones that you see, G213, but also G41, G890, which is not on the slide here, but a very powerful one, and 969. And this is also to adapt to the environment that we have in India, where we need both freestanding trees, but also we need the highly dwarfing rootstock, which requires trellises. So for example, in Kashmir, where there are flat lands and we can adopt trellis systems, we would like to go for the very highly dwarfing rootstock. Whereas for the terrains in Himachal, which are more difficult to have trellis systems on, we would like to have the freestanding trees. And that's where the less dwarfing rootstocks, that 890 and 969, come in. And these are rootstocks that allow for the same precocity, so earlier fruiting, disease tolerance, and early bearing. So I would give the same benefits, but without the highly dwarfing nature. In addition to introduction of new rootstocks, we're focusing on introduction of new varieties. We have tied up with breeders that have introduced what the US calls, or the world calls, club varieties. The idea here is to work with farmers to produce these varieties which have high color, good sugar content. They are able to survive in less cold conditions, and when you don't have a reefer setup, and and give those same characteristics that the consumer desires, without losing their ability to the crunch that you like or the color that you like. So I'll just speed up here just to tell you a little bit more about. Yeah, so we have the license to produce these rootstocks. We're increasing at a rapid pace. Today, our tissue culture lab can produce close to 8 lakh or 800,000 rootstocks annually. We have about 100,000 plants in the ground this year already. And from next year onwards, we'll be able to see some of those results. I will just quickly mention the profitability here, like why should we move to high densities? You can clearly see that even though the investment is higher, the benefits of moving from 10 to 70 metric tons, quicker fruiting, higher operational profit. So at the end of the day, the farmer has to gain dramatically. We are working closely with the government and educational institutes, the ICR system, both for import of the material, trialing of these varieties, as well as MOUs to help us take the knowledge, so the extension related to these activities, to the farmers. I think that's pretty much it. I just had some more pictures. So this is just to show you what the difference between the two systems are, going from a low density traditional system to a more high density, high productive system. So you see more red, more fruit, less green. So more reproductive growth, less vegetative growth. And these are trials from on the ground activities already in India. So it's a proven technology, and we are trying to scale it with new genetics. I think that's pretty much it. We have some photos of our labs, but I'll be happy to answer or take more questions or any more points of discussion. Thank you.
Thank you. Thank you, Ashish. Thank you very much for keeping time. Questions, please, because he's to leave. He has a flight. Hanji, Dr. Tyagi Sahab.
Ashish, it is very, in fact, excellent presentation and something new you are trying it here. And in the field, it is seen that, so congratulations to Mahiko and your whole team and Mr. Raju Barwale and your grandfather. My question is that now I think you are in the stage that the technology is established and it is be scalable. My small question is that how are you planning to scale it up? Do you have your own farm, or you are making a farmer community or leasing the land or something like that? So what is the strategy to upscale this technology?
Sure. Thank you, sir. Sir, we at 7-Star, we are focused on 3 aspects of the business. One is the identification and introduction and trialing of new varieties, multiplication through our nurseries. So I did not mention here, but we are able to now produce close to 6 lakh of these finished plants, what are called whips or feathered plants. And then also the extension required. So our belief is it's not enough just to deliver the plants to the growers. We will have a team that works with the growers to get to that productivity of 50 tons. And there are a number of aspects related to that: nutrition, as you know better than I do, pollinators, right application of inputs at the right times. So our goal to scale up, one is to have the ability or be able to produce the planting material. That's, I feel, very essential of the right kind. Second is to have our field teams in both Himachal and Kashmir. They are already in place to help and guide growers. And thirdly, we feel that the system needs to be closed. What I mean by that is that we will buy back, especially for the club varieties, the fruit from the growers, because these varieties have to be sold under brands. You may have heard of brands like Pink Lady and Jazz and Envy. So we are working with the clubs to promote and create the marketing to generate the demand. They are already being imported into the country. We already see Pink Lady fruit, for example, inside the country. But the idea is to provide a platform where we are not growing ourselves, but we will work with growers, give them the guidance, give them the planting material, and provide them a market at the end of the day, so that they don't have to go anywhere else and sell the fruit to us at a fair price.
I have a, can I?
Yes.
So first of all, thank you, Ashish. Intriguing and amazing presentation. So I have one stupid question, and there are a lot of experts over here, so excuse this stupid question, but I've always wondered why the Himachal apple loses its crispness very quickly, while apples from the US or what we import from Australia are always so crisp. So the question I have is, I'll just 2 minutes, 1 second, sorry.
Yep.
Is it a genetic issue or is it a supply chain issue? So I've always wondered. I'd love to hear the answer, because I've never been able to get the answer from my dear scientist friends. They make it so complex in terms of the answer. I think the second question I have for you is, in terms of the business model, are you ready to take the risk in terms of sharing profits with the farmers, in terms of the business model where you provide the rootstock and you participate in the growth of the farmer's business, or it's your pricing is purely based on the rootstock that you'll sell and finally the produce that you'll buy from them?
Yeah. So the first question, and I know there's a lot of learned people here, but what we have learned in the last couple of years, we have been working on it. There are 2 aspects to this. There is definitely a genetic component, where certain types of fruit or fruit that are bred to have a longer shelf life. So that is definitely a component that you can breed, or probably the varieties that we are working on or have in the country. They are not genetically the best suited for a longer shelf life. But that said, there is a second very important component, which is the post-harvest handling of the fruit. For example, if you go to any of these very well-developed countries like New Zealand or the US or South Africa, within 6 hours of harvest, your fruit is actually in a cold chain. And it's treated with the right temperature, humidity regime. A lot of the fruit is also chemically treated. There is a molecule called 1-MCP, which is an ethylene inhibitor. It basically prevents the fruit from ripening. And most of the fruit that you are consuming, which is imported, is treated with that, if not all. I would say that 95+% of the fruit is treated with that chemical. And now you see, even in India, most of the fruit that is being stored, for example, is being treated with that chemical. That said, I think the genetics plays a very important role, because if you don't have the right genetics, if you have bad genetics to start with, you cannot improve it. The 1-MCP or the post-harvest handling only maintains what you have harvested. So I think it's a combination of these two factors. To your second question, I think we are open in terms of the models that we want to work with. I think we have a model in which we just are willing to sell the tree, a superior tree of superior genetics, and then the farmer has the freedom to do whatever they want with the fruit. We have the club model where we want to offer these services with a buyback arrangement and technical guidance. So we help the farmers get a good quality product. We sell the farmers our planting material. We guide the farmers through the production process, help them get good quality, good packouts, and then also buy back the fruit. Even in terms of the buyback, we have different models. So we are happy to give them a one-off price at the farm itself. If they would like to partake with us through the journey after the actual selling, we are also talking about a minimum price at the time of harvest. And then they partake with us based on what the material is sold at finally. Maybe it's 3 months down the line or 4 months down the line. Then they get a share of that as well. So it's really, I think we don't know what is going to work, but we are taking it with an open mind. We haven't done the first harvest yet. But the idea is, and I think in the core, I think what's really important for us is that this will only work if everyone in the value chain is benefited. So the farmer planting the new varieties must get a better price. We as marketers must be able to make our margin on the produce as well. So it has worked in other places, and I hope that we can work with a model that can work in India as well.
Okay, I think we should. Please.
Using this material. And are you also introduced to the pollinizers?
Sir, actually, there are common pollinizers, like, for example, Golden Delicious is known to be a pollinizer that works for these. The challenge has been that I think in India, we are not. Yes, sir.
The problem is that the existing pollinizers do not synchronize with the flowering of the stock assigned. So that is one important point to take in consideration.
Sure, sir. And yeah.
Okay, Sheesh, we will just like to save some time. And this presentation, your presentation should act as a motivation.
Thank you very much.
Should act as a motivation for public sector also, that we can do something. I have 2-3 points for the.
Sorry for the interference, sir.
Just a moment.
Sir, felicitations.
Acha.
Okay, so before we move on to our.
One minute, please. Dr. Tyagi and Dr. NBVGR colleagues, I'm not sure, please keep sitting. I'm not sure if we are giving due importance to rootstocks in our collection, in our field gene banks. Because, no response now, just to note down. If I'm wrong, I will be happy that we are doing good work. You see, since I am born, when I'm studying at Khalsa College also, horticulture, 3rd year, Jatti Khatti is used as a rootstock, all citrus plants, etc. We are. So we are. Oh, congratulations then to Dr. Rana and Noor Singh in charge of. And we should give importance. If we give it is very good. PG was not giving. Then second is Dr. Agarwal. If ICR can do something, we are very, very shy. I mean, state agriculture universities, very, very shy in importing the germplasm. Even Himachal government doing better. Punjab farmers are doing better than PU. I tried, but how we can motivate agriculture universities to introduce and have lessons for further multiplication? Maybe some amount. If you remember when we got 100.
He needs to leave, so let's facilitate him.
Just 1 minute. So some money for this thing. I mean, I said if you can keep. And 2 more points for later on.
Thank you, sir. So I would like to request Professor Atul Khosla, sir, to kindly felicitate Dr. Ashish.
Two more points regarding research. I don't know if we can convey, if the society can convey. First one is she showed the photographs of apple orchard. It was a normal tree. I saw in houses, some houses in Germany, trees like mango and jamun, old apple trees. Now you cannot recognize sitting in a tram or in a car that if it is vineyard or apple orchard. So we should also give importance to pruning and training in tropical. Mango, jamun, etc. Jamun is emerging as an important crop because of diabetes, etc. But how to pick fruits? Then other one next is breeding program. How many agriculture universities are doing breeding? PU had breeding section. It was just scrapped. Then again we set up that. And here again, Dr. Agarwalji, breeding is a very, very long term. Oh, I was happy. Dr. Gautam was happy that we worked in crops. Every year raised 2 or maybe sometime 3 generations. But fruit breeding means 20 years, 15 years, etc. In scorecard, you have to then, if you want to promote hybrid breeding or pedigree method, etc., any method in fruits, scorecard में जिसने पहले शुरू में काम किया उसको भी नंबर देने पड़ेंगे. Only then breeding will be taken up. Otherwise, वो बस स्टोरेज etc. उसके बाद टेस्ट कर लो कैसा है उसका खाने में टेस्ट कैसा है और etc. कैसे simple. So with this we move on to the new era of genomics. I'm also a student. I may ask some questions which are yes. When we were student, that genetics is now upside down. And I have said it everywhere, and I will say it even now that I have seen DNA only once in the practical Dr. V.L. Chopra. He just in a beaker with the glass rod did some stirring and then showed that here is the DNA. So that is all I know about DNA. But now it is time we should know more. And it is very good that we have 3 presentations on genomics. One is keynote address and 2 are. So it is time for us to learn something. So, please.
Sir, thank you, sir. Now we have Dr. S.K. Yadav, keynote speaker. Dr. S.K. Yadav is presently Director CSIR IHBT Palampur. Dr. Yadav is a renowned biotechnologist having vast experience on metabolic engineering of plants and microbes for value addition. He has transformed plant products into value-added products through enzyme-based bioprocesses. For example, he has developed low caffeine tea through gene silencing Dr. Yadav has published more than 200 research papers, having more than 2,800 Google Scholar citations. He has authored 3 books and he has also 17 patents into his credit. He has been bestowed with many awards, including S. Ramachandran National Bioscience Award, NAS Recognition Award, INSA Young Scientist Award, Nasi Reliance Industries Platinum Jubilee Award, and he is also having fellowships of different academies, including National NAS, NASI, and also Boys Caste Fellowship. Dr. Yadav has been also named as 2% of top scientists of the world by Stanford University. Now may I request Dr. Yadav to deliver his talk.
Most respected Dr. Baroda, Dr. Gautam, Dr. Dhillon, my dear colleagues and young students, a very good afternoon to all of you. So actually, one of the presentations was already made by Dr. Sanjay Kumar, who might have covered the whole activities which IHBT is doing. I missed that presentations because I was engaged in some other meeting in the morning in Chandigarh and I reached late. But I will try to not cover all those activities which he presented, but I will give some basic fundamental science which my laboratory did, and it will be beneficial for the young students and it will lead many more opportunities to develop many more valuable products out of that. So it will run. So this slide you might have seen from where, okay. But it is not going backward. It is going forward.
Pointed towards the computer.
Yeah.
Starting से कर दो.
So this is the institute. This slide might have been shown by Dr. Sanjay again. This institute is actually developing technologies by utilizing Himalayan bioresource, and we are trying to develop sustainable technologies out of that and to support the bioeconomy of the country. And we have been working on all kind of bioresources ranging from plants to animals. And the technology development in the institute is in 5 different areas: agrotechnology, biotechnology, chemical technology, dietetics, nutrition technology, and environment technologies. It has some problem with that, I don't know. So in this presentation, I will cover some of the fundamental metabolic engineering pathways. One is caffeine biosynthesis pathway in tea, which is a major biosynthesis pathway for caffeine in tea. Also flavonoid biosynthesis pathway in tea, because catechin is mainly present constituent antioxidant molecule, which is health beneficial compound in the tea. So I worked on these 2 metabolic pathways in tea. Also present some work on steviol glycoside biosynthesis pathway. You know that stevia is one of the sweetener plant, and it has more than 300 times sweetness to that of sucrose. So I worked on the steviol glycoside biosynthesis pathway and tried to manipulate that pathway, and also attempted to, if we can manipulate this pathway in alternate systems so that we can produce similar kind of molecules in the other systems as well. Similarly, the picroside biosynthesis pathway in Picrorhiza curva, and a little bit to work on the saffron development biology, and also on the biological relevance of prickles, molecular basis for the formation in the rose. That what are the molecular bases for the formations of prickles in rose. So tea, we all know that this This is known. This belonged to the Thiaceae family, and it is India is first in consumptions, and as far as its production is concerned, we are second in positions for its production, and it has a flavonoid content of around 30 to 40% of dry weight, and caffeine is around 3 to 6%. So these are the two major constituents present in tea. Since tea contains a lot of caffeine, and this is not useful for the children's, and particularly also not useful for the pregnant women. So to handle that situations, and flavonoid on the other hand are very important antioxidant molecules and health beneficial compounds. So to get the benefit of these flavonoid compounds and to reduce the ill effects of caffeine, we manipulated this pathway in tea. First, we understood the pathway for the synthesis of caffeine in tea plant, and the whole pathway was deciphered, and we identified that caffeine synthase gene, which is responsible for the synthesis of caffeine synthase enzyme, which was found to be regulatory enzyme of this pathway. And if we silence this gene at this level, this will not produce the caffeine to the extent which is normally tea plant is producing. So this caffeine synthase gene was silenced in the tea plants. The construct was prepared and it was transformed in the tea plants, and through tissue culture techniques, we developed the transgenic plants, and we evaluated these plants, and then the caffeine content was reduced around 40 to 60% in tea plants. This has opened up several questions in mind that through gene silencing, by using this gene, could not generate the tea varieties with 100% caffeine, with 100% no caffeine, but there was still 40 to 60% caffeine was there in some lines of these plants. This has opened up the opportunity that there might be several isomers of these enzymes might be present in the systems. Also, there might be alternate pathway for the synthesis of caffeine in the plants. To address that questions, we further elucidated this pathway and then identified that there is a alternate pathway existing in the tea plants, which is responsible for the synthesis of caffeine in the tea plants. Then we also conducted the transcriptome analysis in 3 different cultivars. You know that there are 3 different cultivars of tea are existing: Chinri, Cambod, and Assamica, depending upon the size of the leaves. And we did the comparative analysis of these 3 cultivars. And we also conducted the transcriptome in the bud leaf, which is actually used as a commercial tea making planting source. Also conducted the transcriptome in the 6th position leaf, which is an old leaf, which is not commonly used for the tea making. So having analyzed all these data, we have observed that the caffeine and flavonoid content is maximum in the young shoots, which is actually used in the tea preparations in all the three cultivars, though the relative content of these caffeine content and flavonoid content was different in these tea varieties. So the caffeine and tea content which was analyzed in these tea cultivars, it became important to understand that in tea, actually during winter it goes under dormancy period. Tea is not usable during winter seasons, and tea leaves undergo dormancy period. To address that questions at the molecular level, we analyzed and found that through transcriptomic and genome sequencing analysis, there are several transcription factors and the phytohormones which are responsible. Also, the regulations at the epigenetic levels of these genes was found to be the turning point in case of tea, that the regulators which are shown with the red mark, the down regulations, and the green mark up regulations, these transcription factors are actually fluctuating during the winter and the summer seasons and could be responsible for the regulations of the synthesis of these metabolites in these plant systems. Therefore, these kind of machinery are very important to regulate. If the transcription factors which are upregulated during winter seasons, which are responsible for dormancy period, if we downregulate those transcription factors, there are chances that we could get tea, commercial tea, even during the winter seasons. The proteome analysis was also conducted to understand that whether the reflection at the protein level is also same to that of the transcriptome level. The genes which are showing upregulation and downregulations during different environmental conditions, whether that response is reflected at the proteome level. Therefore, we conducted the proteome analysis in all these different tissues. And if you see that there are some useful proteins, 3-4 proteins, which are differentially regulated in these cultivars and which could be responsible for these kind of modifications in the tea varieties. Coming to the flavonoid biosynthesis pathway, which I already stated that tea is synthesizing around 40% of its dry weight, the flavonoid content, and catechin is the most prominent antioxidant molecule among flavonoids. To identify that why this flavonoid biosynthesis is so robust in tea, though the flavonoids are synthesized in most of the plant systems, and to understand that the pathway was deciphered and the genes which are involved in the synthesis of this pathway were identified, and we have cloned all the genes and we overexpress these genes in the model system to see the effect. Since in tobacco also these flavonoids are synthesized, but to a very much lower rate, lower extent. And the expression of these genes, when analyzed in the tobacco, the expression level was significantly lower compared to the expression level of similar gene in the tea plants. Therefore, the genes which are shown in the green mark, F3H, DFR, and ANR, they were overexpressed in these plants, and FLS gene was silenced. I suppose I'm getting 20-25 minutes. I completed those. I prepared my talk according to that only, but if you want to me squeeze my talk, I can squeeze wherever you want. So these genes were overexpressed and these FLS was silenced, and to see its effect on the plant systems, we observed several observations we identified, and because of shortage of time, I have to run fast because there are so many data. These genes, the DFR, ANR, they were overexpressed and they were found to be generating the plants which could tolerate several kind of stresses. So these genes which are actually producing antioxidant molecules, they are fighting with the oxidative stress which is generated during stress conditions. The F3H gene, when was overexpressed, this is very prominently enhancing the root length. If you see the root length, the F3H genes from the tea, when overexpressed in the other plants, they are enhancing 2 to 3 times more root. This could be very useful technology for developing transgenic plants or the plants which could sustain under drought conditions, because the root will go under very deep in the soil, and they can survive even under drought conditions. I can skip the mechanisms also. We have elucidated the mechanisms, that the whole mechanism, that how actually it works, that it modulated the pectin biosynthesis in the plant systems, and how reactive oxygen species level was reduced by overexpression of these genes. We also elucidated at the epigenetic level. First time we have shown worldwide that the flavonoid biosynthesis pathway is actually under stress condition, is epigenetically regulated. And we published that in the Journal of Experimental Botany, and later on also convinced that these pathways are very useful, and they are involved in the epigenetic regulations of these kind of systems, and that paper also published in Plant Journal. We know that the PPO is polyphenol oxidase, and which is actually responsible enzymes which is catalyzing the oxidation of catechin in the green tea and responsible for black color in the black tea by oxidations generating thiaflavins and thiarubigins. If we do not want these thiaflavins and thiarubigins in the tea, then we have to silence the PPO genes. So towards that effort, we have initiated silencing the PPO genes so that we can get the maximum of catechins rather than those colors. So these kind of modifications can be easily made by using the techniques of genome editing, and that we are following through genome editing, silencing of PPO genes in tea plants. I can skip these detailed data, that how we analyzed and how it is affecting the plant systems. The program cell death is governed by that. We are also conducting genome editing for caffeine synthase. Earlier I have shown the silencing, but now genome editing is a more significant technique for doing maximum silencing of the caffeine biosynthesis in tea. The second pathway is steviol glycoside. That pathway is actually the bifurcations from the corinoic acid biosynthesis leading to the gibberellic acid synthesis in most of the plants. But in stevia, actually it is bifurcating towards the synthesis of steviol, which is present only in the stevia plants. So we identified all the genes and characterized, and then see the effect of these genes, that how they are actually regulating the synthesis. With the first gene, which is the K13H gene, when it was overexpressed, it is leading to the synthesis of steviol. And when it is silenced, it is not producing the steviol in the plant systems. So this is how we validated that the existence of these genes are important for the synthesis of metabolites. Then rest of the UTG UGTs which were identified from this pathway actually overexpressed in C, because there are several kind of UGTs present in the plant system leading to the different activities. But to see whether these UGTs which are present in this plant are affecting the other pathways or not, so to see that there are several modifications were observed in the plant systems when these were overexpressed in the plant systems. So I'm skipping all these data because of the shortage of time. And this is one of the important pathway, because now genome editing is one of the useful technique which we might have realized, and SDN1 and SDN2 have been approved by the government to accept that as a commercial crop as well. So keeping that in mind, in stevia we need more of leaf rather than the flower and the seeds to have a commercial productivity. To address that questions, our group has identified one of the genes actually which is responsible. If we silence that gene, it would produce more of leaf in the stevia. So that would enhance the productivity in terms of leaf in stevia, which is a required entity. Similarly, in Picrorhiza curva also, the pathway which is responsible for the synthesis of picroside 1 and 2, which are the essential metabolites in the picroside, and the GPPS pathways, actually the whole pathway was understood by our group, and we identified one small subunit and two large subunit actually, and they work together, all three subunits combined together, and then they show the activity and produce these picroside 1 and 2, and they are differentially produced because of the different level of expression of these genes in the systems. We have proved through yeast to hybrid system as well as BIFC systems. So I can skip this data as well. So in saffron also, actually, there are a lot of environmental changes. Responsive genes are actually triggered and down-regulated during the environmental changes, and the flower formations, vegetative growth, they are actually determined because of that, and the genes which are actually differentially expressed during these times are also could be a potential candidate to regulate in case of saffron. So that work is also going on, and it is very useful for the young students to learn that. So these are the PBF family of genes which has identified 6 FT genes and 2 TFL genes and 2 MFT, which are flower transformation genes, which are actually regulating the flower formations and the flower known formations in the plant system, which are already known in other systems. And now these are being manipulated in these systems to understand and to get the benefit of those genetic regulations in the saffron. So we are doing the genome editing in that, and similarly in case of flower also, the prickles formations and how it is regulated, and can we get the prickleless rows. Actually, that work is being conducted at the genetic levels, and the genes which are responsible for the formation of prickles, though it has advantage and disadvantage, and towards understanding that how it is formed and what are the genetic regulations which are involved in case of rose, that is also being conducted. I think this is the last slide that CRISPR-Cas mediated gene editing is also being worked out to enhance the tuber yield, and this work is being conducted in collaboration with the CPRI. Dr. Gaurav Jinta is actually doing that work, and the SCS gene is actually which is involved, and if SCS gene is silenced, then Solan will lead to faster and bigger tuber formations in the case of potato. So that could be a game changer in case of potato for more tuber formations. So nowadays, for the benefit of the students, that artificial intelligence and machine learning tools are very important in agriculture field, and they are coming up in a big way. We have been leading 2 projects in this field. I am not covering the details of that aspect, but it is very important to involve artificial intelligence and machine learning in agriculture to speed up the productivity as well as the desired amount of produce from the agriculture field. So I'm skipping all that. I think that's all from my side.
Thank you, Dr. Jadhav Sahib. Thank you
so
very much for wonderful presentation, and I will say very outstanding work. Sorry for the time constraint. Let us please have the chair. Maybe at the end you have some questions, some queries. There must be many because your work is so interesting. Next gentleman is Dr. R.K. Chhota, and I request Dr. Walia to please introduce the speaker.
Now we have another speaker, Dr. R.K. Chhota. Dr. R.K. Chhota is working as professor at CSK HPKB Palampur. Mainly he is involved in teaching at UG and PG levels in the field of agriculture biotechnology. He has experience on improvement of underutilized legume crops of northwestern Himalaya, like horse gram, rice bean, and ajuki bean. He is known to sequence the genome of horse gram in variety HPK4. Now he has published many papers in high impact factor journals, including BMC Genomics, Euphytica, and molecular breeding. Now may I request Dr. Chhota to deliver his talk, please.
Thank you, Dr. Balia, for giving the introduction. So, respected Dr. Prodhaji.
I would now kindly request.
Doctors, any questions for Dr. Yadav? I have some.
I will now request Professor B.S. Dhillon and Professor Atul Khosla to kindly felicitate Dr. S.K. Yadav.
So, good afternoon to all. Respected Dr. Prodhaji, Dr. Gautamji, Dr. Dhillonji, and eminent scientists present in this hall. So, I thank organizer to give me the opportunity to present my work on conserving the genomic resources by using the genomics. So if we see the loss of agrobiodiversity, so the human footprints on our planet is currently threatening the biological diversity. So wherever we go, we always threaten our biodiversity. So our these natural habitats are shrinking. So the result is we are having 2% of the total biodiversity have extinct, 7% critically endangered, and 10% of the endangered, 90% vulnerable, and the 8% are near threatened. So if we see the total, about 40% of the species are under threatened. So loss of the biodiversity, in the every 20 minutes, we are adding 3,500 people on this earth. And at the same time, we are losing one species. So most of these species, we can say that 80% is due to the our human intervention or due to the human being. So these are some of the causes. I will not discuss in detail the causes of the loss of the biodiversity. And my topic is basically on the crop biodiversity present in the northwestern Himalayan region, and what are the different approaches, genomic approaches to conserve these resources. And finally, the little bit work I have done in the horse gram by using all the genomic information for the conservation of the germplasm. So, so conserving the genome. So conserving the bioresources is increasingly recognized a keystone toward the potential of the biodiversity and natural resources for the future generation. As we know that the conservation of the biodiversity not for our generation, but it also for the future generation. So the innovation in the revolution now going on in the genomics, so that genomics approaches can be clubbed with the present our conventional approaches for the conservation of the biodiversity. So we are having the limited resources for the conservation, so that genomic resources should be mainly focused on the plant species that exist and that experience high extinction threats or play a crucial role in the ecosystem restorations. So obtaining the whole genome sequencing in most of these plants is not possible under the present circumstances. So we can use the tree of life. So whatever the genomic information present in the related species, though information can be used to conserve the related species. So in our conventional plant breeding method, we are using the phenotyping for the identification of the desirable plant types. And nowadays, with the advent of this marker technology, transcriptome and other genomics techniques, we can select the plant at the molecular base. So these approaches can also help to differentiate the plant at a molecular level, so that we can identify some of the trait-specific plant by using the molecular techniques. So if you see the Hindu Kush Himalayan region, this is one of the main region having a lot of biodiversity of the bird, and we are having the 4 biodiversity hotspot of the bird present in these regions. So 35,000 species we can say present in this Hindu Kush Himalayan regions, and in these and because most of these plant species are endemic to these northwestern Himalayas, and if any species lost in these regions, it will be lost forever. So crop diversity in northwestern Himalayan is also a rich source of the biodiversity presently here, and Himachal Pradesh is also endowed with a lot of fauna and flora biodiversity. And at Himachal Pradesh Agriculture University, so we have conserved 366 land races of the different crops. And out of these, some of the land races has been released as a variety. For example, 26 variety has been released as such in the for the cultivations. So these are some of the endemic biodiversity. We see the naked barley present in this Spiti Valley, or the buckwheat present in the Lahore and Kinnaur area, and some very specific land races of the maize present in the Chamba area. So these are just glimpses of the biodiversity present in the different crops. For example, in case of the Rajmash, if you see a broad valley, very small valley, and in that valley, you can see the 4 different land races are being cultivated by the farmers. So these are the traditional crops with the potential land races. For example, the red rice, maize, barley, rajmash, kulthi, and mash. So potential land races have been identified at the university levels, and some of these land races has been registered with the PBFRA for the conservations. And these are land races released as a variety by the university. For example, in case of the Himban, Basba, Hanso, these are the actually land races and later on released by as a variety by the university. And in addition to some of the native crops are also present in the Himalaya region. For example, the amaranthus, buckwheat, chinnapod, rice beans, kala jira and millet. So traditionally it was grown by the farmer. Now the cultivation has been decreased to some pockets, and this needs to be bioprospecting, or we can say nutritionally, these crops are very rich. And by advocating that the consumption of these native crops or the these crops can help the farmer health. And these are some of the potential land races identified at the university level. And in addition to these, some of the native vegetables are also present in this northwestern Himalaya. For example, this is the cucumber. So cucumber, that is the this year also this farmer this farmer award is given to this farmer who is growing this cucumber in the Paprola area, and Genome Saber award is given to the Kala Jira people of the Kinnaur area. So if we see the plant genome, this resource management, so these are different activities being done at the for the management of the plant this genetic resources. So modern molecular approaches can help or can help to take all these activities. So we can use the this modern molecular approaches for all these activities. So although genetic diversity has long been recognized as a fundamental to all the levels of the biological organism, but genomics is often neglected in the biodiversity assessment and conservation. So gap between to generate the data, study biodiversity, and use of this genomics is due to the limited funds are available and the limited knowledge transfer and collaboration. So very limited collaboration between a molecular biologist and a conservationist. So this linkage to be developed between the molecular biology and the plant scientist. So integration of the genomics into the conservation to take genomics effectively into the realm of the conservation of the plant diversity, several initiatives have to be taken. Firstly, the prioritizing of the variety, which type of the variety to be taken for the genomics studies. So all the species should not be taken for the this genomic study, because with the limited resources, we can target only those species which having the threatened or had the endangered species. So genomic approaches in the biodiversity conservation, we have basically 4 different approaches: the DNA barcoding, or in this meta barcoding, reduced representation of DNA, maybe the GBS and other approaches, transcriptome studies, and whole genome resequencing or sequence. So these are the 4 different approaches which can be used for the conservation of the biodiversity. If we see all these approaches, the information level decreases from the genome level to the barcode level, but the practicability this increase from the when we starting from the barcoding, there is less information, but the practicability is more as in case of the barcodes as compared to the whole genome sequencing. So this is the barcode techniques. Initially, this the COI, this cytochrome oxidase subunit is used in the animals to recognize, to characterize, and in plant system RBL and MAC2 in the chloroplast DNA, and in the this fungi ITs in ribosome RNA. And so these are the different regions of the genome which can be taken for the barcoding of the different genomes. So DNA meta barcoding is an other improvement. So here we are taking the next generation sequencing platform, or information can be used to conserve the different varieties. So in barcoding, we are taking the one variety at a time, but in case of the meta barcoding, we are taking many variety at a time and sequencing and comparing the with the reference of what type of this new species is there. So the next approach, the reduced genomic representation. So this is generally when we are having the small DNA, this sequencing, we are taking a small genomic part and can be compared with the other. So in this, this red sequencing or the hybrid red sequencing can be used for this type of the biodiversity analysis. So gene expression. So gene expression data have given rise to a new conservation framework by characterizing this genetic variation in the natural population. So by using this gene expression, we can identify the lines which are more stable under the different environments, because the gene expression, they are expressed in the different environments. So we can select the plants on the basis of different genes which can express in the different genotypes in the different environments. So whole genome sequencing. the whole genome sequencing data offer a unparalleled power as compared to the other, but the cost involved in this is very high. So just I will go through this case study. So this is the orphan legume, whatever this genomic approaches has been used in the horse gram, in the kulthi. So first we have different land research collected all over the Himachal Pradesh and developed the this molecular fingerprints by using the SSR marker. So these are the 18 different land research collected from the Himachal Pradesh, and we have developed this 10-digit barcoding, DNA fingerprinting, and the QR code for all these lines. So by clicking the QR code by the mobile, you can identify this particular land research is there. And after this evaluation of the about 700 lines, and we have now reduced to the 360 lines, then used for the molecular characterization. So when we use the by using the SSR marker of the 360 line, we find that there are the basically two main gene pools are. One gene pool belong to the southern India, and other gene pool of the northern India. And two green lines are the two wild species included in this study. And by using the structure analysis, we are also the same result. We are finding that the two gene pools are present in the horse gram germplasm. So reduced representation studies will also, so we also do the red sequencing of this 90 horse gram lines. And of these, because the due to the narrow genetic base, so we get only the 340 SNP in these, and on basis of 340 SNP, we identify, do the diversity analysis of these 90 lines. And because we have also generated a genomic resources about the more than 10,000 SSR marker we have developed in, and these SSR marker are used to construct. This is the first linkage map developed in the horse gram, and on the basis of phenotypic data, we also able to identify some of the QTL for the important traits. And because after that SSR marker is not working, so we also go for the SNP of the SNP analysis of the 96 line. And on the basis of this Manhattan plot, we have identified some of the SNP which are linked with some of the traits of the genomic code. So we also do the done the gene expression by taking the two different lines, and genes has been identified which are stable under the drought as well as the normal condition. And we also consider first this reference genome in the horse gram. So we identified that about 36,000 gene has been identified, and about 259 has been this megabase pair has been sequenced in this. So we also evaluated all the 96 for the nutrition profiling. So we done the nutrition profiling using this NMR, and by using the different amino acid profiling, by using all the secondary metabolites. So we characterize all the 96 germplasm of the horse gram and identify some of the lines which are having the higher protein content, some of the secondary metabolites like that. So because horse gram is known for the kidney dislocation, so we also identified some of the land races which are having the high inhibition efficiency for the this calcium oxalate. So this, for example, in the Barmore kulthi and this Karso kulthi, they are having the high efficiency for the this calcium oxalate inhibition, because they are preventing the this kidney stone. So this is the concluding remarks. Fully sequenced and annotated genomes have been made available for only a small number, so we can think for to include more number of these lines for these, and the urgent need to focus the research question. Sorry, sir, for taking more time. Thank you, sir.
Yeah, thank you very much, Dr. Chota. Thank you very much for presenting forth ideas for use of genomics in germplasm conservation, and then exemplifying that with the horse gram data. Wonderful, very good presentation.
Thank you, sir.
Maybe question at the end of there. Now, next presentation is by Dr. R.K. Sharma from IHBT, Palampur. Dr. Sharma, please. First, something about. Yeah, please.
Thank you, sir. May I introduce first, please? Dr. R.K. Sharma is working as a senior principal scientist at IHBT Palampur. He has vast experience on genetic improvement, conservation, and sustainable utilization of Himalayan plant genetic sources, particularly medicinal and aromatic plants. He has contributed significantly in developing and licensing of 23 cultivars for commercial cultivation, including Him stevia, rich in riboside A. The purified riboside A has no effect on blood pressure or glucose homeostasis. Dr. Sharma has handled 33 R&D projects, published 122 research papers, and guided 18 research scholars. Now he has targeted genome mapping in tea and stevia. Dr. Sharma has been bestowed with many awards, including CSIR Technology Award, Indo-US Technology Research Fellowship, and also elected as NAS Fellow. May I request, sir, please.
Thank you very much for your introduction. Most Honorable Professor Paroda, Professor Gautam sir, Organizer Khosla sir, many Chaurasias on the dais, Professor Dillon, Professor Khosla, Yadav, Dr. Yadav, and Dr. Paul. Thank you very much for giving me this opportunity. Although since morning, people have spoken, so not much left for me, but I will try to justify my presence and hope I'll activate some of the young guys here. Thank you very much for this kind opportunity to interact all of you, please. Thank you very much. So in the morning, sir, I was really matching with your idea. And my question is that do we really understand the Himalayan bioresource? So because I think there is like this time, there is a terrain also change because of the so much degradation and environmental effect, and then climate change. And then terrain is so tough. So how it has to be channelized? So there is since morning people are talking, there's a lot of data is available. Now, how we can have that data available to all of us, and how the interface has to be created when the data has to be placed on one place. I work in the area of molecular genetics and genomics. My director has presented before, Dr. Sanjay has presented. I will try to align, I deal whatever is that at the genome-wide level. So there's a lot of fascinate. This Himalayas really fascinate, and it has a lot of land, right from the Trans-Himalayas to North-West. And it is the custodian of the large number of the species out of this, if you talk about the IHR, it has the 1748 species. And there are the different categories. There are the some which is very, very interesting. They are existing here and they are endemic to this place. And this is make this Himalayas very unique. And we follow some of the approaches, need to understand that, the passion. So the major issue is the non-availability of the conservation and domestic. Like we take the rice, since morning, there's a lot of rice are there. In case of these genetic resource, we don't have even the superior cultivar. And then main is the chemical library. So genomic library and chemical library of these medicinal plant could have been there when the COVID came. We could have AI and other things wherein that prediction has been taken and we could have find some solutions. So that data has to be generated. So at IHBT, and this is just for your kind information, what is happening. Actually, there is a Earth Biogenome project, how we are going to use what is the existing international biodiversity for the next generation. And although India was also participating, but that COVID came, things have gone in a different manner. And as in the morning that ICR has, what is the happening at the national level? There was the ICR NATP large scale genome germplasm conservation driven. And in the CSIR very recently, we have the phytopharmaceutical farm, which is which has the club, as was mentioned in the morning, that it has a technological and the cultivation. The resource are going to the society and the phytopharmaceutical drug. And similar program DVT also have. So what is the game changing? Game changing is this technology. Now there are the platforms are available wherein that where the phenotyping cost is, the genotyping cost is lesser than the phenotyping cost. And what we are using this whole genome transcriptome and resequencing to understand this bioresource. So my group is basically use this next generation genomic technology. We identify the markers in these plant resources. We create a lot of genomic resources that talk about the transcriptome, genome, whole genome, resequencing. And we try to find out some of the diversity characterization, core germplasm using GWAS, TWAS. And we are also provide some of the authentication system by doing DNA barcode. And this is some kind of the scientific impact of my research. So far, my group has created 71 databases of the medicinal, functional databases of the medicinal plant. And we have the DNA barcode of the 150 medicinal and aromatic plant. And they are the genome-wide molecular marker databases created like functional database markers. There are different kind of the markers and technologies. And whatever the technologies we are developing, we are licensing to the growers. These are the recent publications from my group. And these are the plant species wherein we target. We target tea, stevia, and there are the number of the medicinal and medicinal plant. Most of these plants are the endangered one. And the key activities, like we create the genomic resource wherein we identify the key gene regulator and pathways, and then development of the high throughput genotypic platform. We go for the resequencing and we do the GBS and all these things, and we use this information or the genome-wide identification. This is very important plant wherein we collected the diversity entire geographical range. And this is the sap pollinated in nature. And while we are doing this analysis, we find there are only the 2 gene pool available, and there are a lot of interventions are going on. So it gives a kind of the information. Either these 2 populations are descendant of the 2 genetic pool we are existing, or either they are the remnant of the 1 population with time scale has been divergent. And then we also identified what is the source and sink, such that that can be manipulated. So this we have done in case of by using a different kind of the organs, whole transcriptome sequencing. We elucidated entire pathways, and we targeted what is the source of these metabolites and what is the sink, such that there the non-destructive methods can be developed, and this can be translated for the synthetic biological approach. Similarly, this is one plant with the Trillium goninium, wherein we have collected the diversity from the entire region, and we elucidated the similar kind of the pathway. We find out all the genes. There is the steroidal saponin biosynthesis pathway work here, and we identify a lot of large number of the marker, which has been eventually utilized for the diversity characterization. And there are despite that the low level of the diversity, there is a lot of differentiation is there, and where the conservation plan can be initiated. Likewise, in case of the Picrorhiza curva, this is the plant which is highly outbreed plant. But despite that, we find some of the populations here, they have the number of the private alleles. And these are the like Trilokinath population in Himachal Pradesh, which is the kind of the unique. So those kind of the information has to be taken into the consideration for the conservation and domestication while developing the gene bank. Likewise, this is the plant which is in the highly trait. And it is very difficult to get this plant. Like the local farmers, even despite the intervention of the forest, they are not allow you to enter this plant. And it has a lot of commercial value, but it is endangered without having a resource. So we use the transcriptome approach, and we use the interlogous system to predict the candidate, how the isosteroidal pathways are connected, and what are the major target, like starch, CYPs, UGTs, aquaporins, and the transporters by which you can do some kind of the intermingling, and such that we can upscale these metabolites accumulation in this plant. And it also, we find out what is the source of these metabolites and what is the sink of these metabolites, such that if one has to go in for the organ culture, one can go for some kind of the synthetic biology interventions. This is again in case of the Angelica gloica. This plant is very, very important. In the morning, so it has been talked. We elucidated and the pathway, and there are the two biosynthetic pathway operate here. One is the ferulic acid biosynthetic, which is entirely work in a stem. And interestingly, one is the phthalate pathway, which work in the rhizome or root systems. This is the one part which we lead the program at the national level, which is the tea, which is very, very important. We characterize the entire germplasm of the tea in India, and we identify the core, and then we initiated, we happened to be the very first premier guy. We identified some of the varietal in the Himachal region, which has been registered. And these are the major outcome, which the characterization of the entire germplasm, we identify some of the core collections, and we created a lot of database, genomic resources, and that gets a lot of lead. Like based on this core genotypes, we identify all the source of the biotic resources and the quality characters. And we created all the genomic resource related to that. And what we are doing right now, we have the collaboration, my group has a collaboration with the Kenya and Sri Lanka, and wherein we are targeting the NGS effort to resequencing and find out some of the functional variation which can be directly utilized for the genome editing and all. This is one place of the program which my director has already talked about. This plant has the ability to synthesize the 60 steviol glycoside. Out of these 60 glycosides, there is 3 glycosides which are commercially very, very important. There are one is the major and 2 are the minor. One is the rubidoside A and rubidoside D and M. So what we are, and there is a bitter aftertaste. So what we are doing, we are characterizing, we have created the diversity, we characterize the diversity, and then we identify what we are using this for resequencing to find out the functional variations. And whatever the germplasm, we have the unique center there. Whatever the germplasm we are collecting, we are conserving at the high altitude center of this medicinal plant. And in addition to that, we also provide some of the services here where we collaborate with the line department where we authenticate. And also these barcode has been utilized not only for the validating, also for the utilizing of for the industrial purpose. So these are the varieties which has been released. These are the 23 cultivars. There is a business strategies. We create a lot of MOUs, and then we goes to we transfer these technologies. And these are the way forward. In case of we work for the Himalayan, in case of the Himalayan bioresource, we work with the conservation, exploration, domestication, and we work closely with the herbal industry. In case of the tea, there is a lot of need is there to work with the tea industry, because if you see the situation here, if you minus the internal market, there is a lot of challenges our tea is getting in international market as far as the price. So the quality has to be improved. And then in case of the stevia, we have worked for this non-caloric sweetener industries. This is my group, and we get a lot of fundings from the CSIR, NTRF, and DBT, DST. Thank you very much.
Thank you, Dr. Sharma. Thank you very much. Wonderful presentation. Very high quality work. Please have chair. Maybe we have discussion at the end. So next, please. Yeah. मैं कह दूं मेरे पास लिखा है ये मेरे पास है अच्छा so now 6 minutes 7 minutes 5 minutes 5 minutes each please. Rapid oral presentation. First one is by Akshay Singh from NBPGR New Delhi. Characterization and course and development of amaranth. Please. Please start. Please start.
Good afternoon to all of you. So, title of my presentation is Characterization and Core Set Development of Amaranth using High Density 64K SNP Array. We have taken Amaranth hypochondricus, also known as grain amaranth, in our study. So, grain amaranth is very important pseudo cereal, has recently acquired global attention and is recognized as a superfood or millennium crop nowadays because of its high nutraceutical values, such as high quality proteins, unsaturated oils, dietary fibers, flavonoids, vitamins, and essential minerals. सर आगे फॉरवर्ड नहीं हो रहा है
आप वहां से कर दीजिए
एक मिनट हो गया. Despite the extensive gene pool, the large size collection and insufficient information resulted in minimal utilization of germplasm in breeding programs. So construction of the core or mini core collection is an efficient method for managing genetic resources. And SNPs are the most abundant and uniformly distributed markers along the genome and therefore can be used for effective and precise genetic analysis. And this is the methodology we have followed for our analysis. First, DNA extraction of the 917 Amaranth hypochondricus extraction, which is including released variety, land races, and elite lines. Then genotyping of the 917 genotypes using in-house developed 64K SNP array. The next step, missing genotypes were imputed using Beagle software. Then SNP pruning was done using Tassel. At manual allele frequency greater than or equal to 0.05. Then population structure and genetic diversity assessment of the total collection. Then core set development using R package. And final step is genetic diversity assessment of the core and comparison with the total set. This is the distribution of the 24,203 pruned SNP markers across 16 scaffold of Amaranth hypochondricus. Figure A shows the distribution of the 12,409 genic pruned SNP markers within 1 MB window size, and figure B shows the distribution of the 11,794 intergenic pruned SNP markers. In both the figures, scaffold 2 contains the highest number of SNP density, and scaffold 12 contains the lowest number of SNP density. Now, next is structure analysis. Showed the distributed the 917 accession into two population P1 and P2. And next is the phylogenetic analysis. Cluster 917 accession into cluster 1, first, second, and third. Cluster first contains only one accession. Cluster 2 contains only 3 accession, and cluster 3 contains 914 accessions. Cluster 1, cluster 2, and cluster 3 correspond to the population P1, and some part of the cluster 3 of the tree correspond to the population 2. And PCA analysis also showed the also distributed the population in 2 clusters, and cluster 1 in red correspond to the population 1, and cluster 2 correspond to the population 2, and some admixture type of genotypes also present. Now, core set development. A core set collection of the 917 Amaranth genotypes were developed using Core Hunter software. So at the 12%, at the 12%, 112 accession were considered to be the representative of the entire 917 accessions. 10 types of possible alleles here. Possible alleles A, comparison of the allele frequencies. Here 917 accessions, and for core set 112 accession. These are already similar, and this graph also show the similar, almost similar type of frequencies in both total core collection and core set developed. And our kinship analysis also amaranth core collection illustrated low genetic relatedness, suggesting that the ideal amaranth core set for the further molecular and genetic studies. And this is a genetic diversity assessment of the core collection, similar to our total collection. It also structure analysis also distributed the whole population, 112 accession in two population, C1 and C2. And this PC analysis also showed similar cluster 1 correspond to C1 and cluster 2 in red correspond to the C2, and some admixture type of the accession also present. So the genetic diversity indices of the core set was compared to the total collection to assess the reliability of the core set. Here is the genetic density, heterogeneity, and polymorphic information content and myelin frequency are almost similar for the core collection and total collection. These indicated that the selected 112 accession represent the whole population. So now the conclusion is SNP array are useful for characterizing amaranth germplasm and providing new insight in understanding the genetic diversity level and genetic structure of amaranth population. And our core set will be utilized for genome-wide association studies, trait discovery, and will prove useful for future breeding programs. And the information related to the population structure and genetic diversity analysis of amaranth hypochondricus proved to be beneficial for further genomic selection, marker-assisted selection, and geo studies. Now, my PI is progressing. Funding is, thank you.
Thank you, Dr. Saab. Thank you very much. Please have a seat. Now, Dr. Jyoti Kumari, presentation is on search of novel donor germplasm for powdery mildew resistance in wheat, mini-core. She is from NBB Delhi. Okay, NBB Delhi.
Yeah, very good afternoon to everyone. I will talk about very good afternoon to everyone. I will talk about search of novel donor germplasm for powdery mildew resistance in wheat mini-core. So as we all know that the population of world is increasing at an alarming rate, and by 2050, the population of India will be 1.66 billion and world population will be 9.8 billion. And as we all know that wheat is the important food staple crops for 2.5 billion population. And to feed the world population, we need to increase its productivity by 70% by 2050. But the major production constraints for the wheat production are shortage of arable land, scarcity of water, and climate change. Moreover, we also have other productivity constraints due to biotic and abiotic factors. So therefore, we have to develop new generation wheat cultivars which should possess tolerance or resistance to plethora of stresses. Now, among the several biotic stresses, next, please. Yeah, among the several biotic stresses, powdery mildew is the major disease which causes significant losses, and it is most prevalent in northern, western Himalayan region and peninsular region of India. This powdery mildew resistance is governed by polygenic genes, and therefore the characterization and evaluation of this must be carried out under multi-location environment under different hotspot locations. Till date, more than 240 powdery mildew resistant genes have been reported. Out of that, 19 PM resistance genes have been cloned, but these are not deployed commercially due to negative linkage drag, as most of these genes are belonging to wheat progenitors and related species. as for example, the right translocations have been associated with bad duck traits. So therefore, we have to search body mildew resistant genes in the common wheat germplasm and cultivated genes, including land races. So therefore, we have to search plant genetic resources, specifically core set, mini core set, for the body mildew resistant germplasm from the gene bank. Next, please. So to fulfill this study, we designed the hypothesis that mini core are diverse set of genetic resources, and second one, the wheat mini core possesses body mildew disease resistance. And for these two objectives were designed, like estimation of genetic diversity in wheat mini core, and second one is the identification of body mildew disease resistant donor germplasm in wheat mini core through multi-location evaluation. Next, please. Yeah, so we have taken up a mega characterization of entire wheat germplasm, 22,416 accessions, and this was characterized for the core set development and characterization database were prepared. And as we all know that we cannot evaluate these all large germplasm for all the traits, so we have to develop the core collection. So based on the characterization data of 34 characters, we developed the core set, which comprises 2,226 accessions. And although the core sets are also not sufficient to evaluate for comprehensive traits, so we designed to evaluate mini core sets. Yeah. So core collection, the concept was given by Frankel 1984. And in our study, we evaluated 2,226 accessions. And after that, it was used for the development of mini core collections. The concept was given by Upadhyay and Ortiz, which proposed the concept of mini core collection, which comprises 10% of core and 1% of entire collection. We can see here that Shannon-Weaver diversity index was more in core collection in comparison to entire collection, and it was more in mini core collection in comparison to the core collection. These are the glimpses of some variability. Next, please. Here we can see that wheat mini core possesses the genetic diversity. So based on Euclidean distance and ward agglomerative method, we found 6 clusters. And out of that, clusters 1 and 3 are possessing earliness and high grain weight genotypes, and cluster 6 is having late maturing and low grain weight genotypes. So these two groups can be crossed to get the material for the integration purpose as well as the genetics study. And here the 2C principal 2C biplot, 2D biplot also showing the diversity, and principal component 1 is having major effect by grains per spike, spikelets per spike, and grain weight per spike. Next, please. Yeah, so after the development of core set and mini core set, so we have to deploy these very important material for the trait discovery. So here, mini core set was deployed for biotic stresses, avitic stresses, grain quality analysis, and agronomic traits. So here I am presenting body mildew resistance test. So in the first year multi-environmental trial, the locations were taken up Palampur, Almora, and Wellington. These were the hotspot locations. And second year evaluation were taken up at Palampur and Wellington. Next, please. So these are the methodology for adult plant resistance. It was done in the field condition in augmented block design at all the locations. 2 resistance checks and 2 susceptible checks were taken up. And then infected rows were taken up at 20 test accessions. And then scoring was done following the 0 to 9 scale. Similarly, we also did seedling stage resistance at Palampur following CRD design, and the 7-day-old seedlings were inoculated, and seedlings were scored after 10 days after inoculation, following a method of 0 to 4 scale. Next, please. Yeah, so here, based on the scoring, so we could find that at Almora, 34.5% of the germplasm were resistant, at Palampur, 35.78%, and at Wellington, 43.18%. So we can say that here that body mildew isolate from North Himalayan region is the more virulent in comparison to the isolate of peninsular region. And here we can also see that yellow bar is showing the tetraploid genotypes. So we can see that almost at all the locations, the tetraploid species are more tolerant to body mildew disease in comparison to the bread weight. Next, please. Here we can say that we could also screen for the yellow rust disease as well as black and brown rust disease at Wellington and yellow rust at Palampur and Almora. So based on the overall environment, we could identify here 15 indigenous accessions, which were the multiple disease resistant tolerant, and 6 exotic accessions, which were the tolerant to all these diseases. Next, please. Next, please. Some of these genotypes were also utilized in the crossing program. Next, please. So coming to the conclusion, we can say that based on our study, that core and mini core are the diverse set of genetic material. It can be used for the genome-wide association mapping for the identification of traits. And powdery mildew isolate from North Himalayan region is more virulent in comparison to the isolate of peninsular region. And tetraploid wheat species are more tolerant to powdery mildew in comparison to the hexaploidy wheat. And next, we have identified here multiple disease-resistant genotypes. Those can be used for the allele mining study. I would like to acknowledge and then ICAR, Director ICAR and BPGR, then collaborators in the consortium research platform on agrobiodiversity platform, and seminar organizer for giving the opportunity. Thank you one and all for listening.
Thank you, Dr. Saab. Thank you very much for very interesting presentation of practical value. Now I request Dr. Madhu Patyal, the presentation, identification and development of yellow rust resistant sources in wheat using conventional, molecular and double haploid breeding. Ma'am, I don't know what type of presentation your will be and how many marks we will give. We are also give some marks, but I congratulate you that you are the lone author. Yeah.
Sir,
Just making presentation for 5 minutes, 6 minutes and 15, 16 authors. Are we promoting that's a tea party papers? I call them tea party papers. The whole tea group. I will come to that later on in my concluding remarks. But just I wanted to thank her and congratulate. Yeah. I am not giving the marks, but I will in my paper, I will say there are more than, I think 3 persons who are to give awards. So I'm going to announce him here itself in the beginning itself. I'm just going to recommend her name without any marks. It is up to the organizer whether they consider it or not. Yeah, thank you. Thank you, ma'am. Please, welcome.
Honorable dignitaries on the dais and off the dais, a very good afternoon to all of you. My presentation is on identification and development of yellow rust resistant sources in wheat using conventional, molecular and double haploidy approach. As we all know that wheat is important seed crop around the world, and no doubt the production of wheat has increased. But still, as Madam Jyoti has told, that with the increasing population, we have to increase the food production of the wheat. So there are different climatic adversities, which include biotic and abiotic stresses. And when we talk about biotic stresses, yellow rust is the main important biotic stress, which is affecting the wheat yield. In one of the study, it has been found that 88% of the world production, it is being affected and it is being vulnerable to yellow rust. So we have to manage this yellow rust. And for this management, we have different approaches, which involve conventional breeding, along with fungicides and other approaches. And in this, when we talk about the most eco-friendly and cost-effective approach, we talk about the breeding approaches, that is the development of resistant varieties. And for this, we have conventional, molecular, and double haploidy approach. No doubt, as we all know, that conventional breeding approach, it has developed many varieties of the wheat, and a number of success stories are there. But still, as it is time consuming and is also affected by the environment while when we go for screening of our material. So we have to supplement this approach with help of our molecular and biotechnological approaches. And one of the approach that we cover for supplementing this breeding program is that double haploidy approach. In this, we go for, there are different approaches for double haploidy, but in our case, we have taken Impyreta cylindrica, a wild grass which is closely related to the wheat and is found abundant near the wheat field. So we have crossed the F1s, which are produced either by hybridization of winter into spring or spring into spring wheat. And F1 is then crossed with Imperator cylindrica, followed by embryo rescue, sorting, and development of haploids. Thereby, we go for doubling of haploids through colchicine, and when the double haploids are produced, we go for the screening of those double haploidy using conventional host pathogen screening and with the help of molecular markers. In our study, we have found we have developed number of double haploids, and from this we have developed DH1, which is resistant to all the races of yellow rust and adult, also having adult plant resistance along with DH4. We have DH7 and DH8 having seedling resistance, and DH18 which is having adult plant resistance. Along with this, molecular screening have found that we are having DH1 with LR34 gene, which is an adult plant resistance gene. This is molecular screening of different DH lines, and for yellow rust, brown rust, and we have found that most of the lines, they are having LR34 gene and YRSP gene. And from this, we are fortunate enough that we have registered our first double haploidy genetic stock, that is DH1, which is winter wheat, and it has been found by crossing of our own variety HS542 with China 84, which is a winter wheat. So many of the characteristics of both the varieties are there in this, and it is resistant to all the races of yellow and brown rust at seedling and adult plant stage, along with LR34 gene. We have also worked on the project with our popular variety of Almora VL892 and 829, and we have went for LR34 and YR integration of the genes, and thereby going for the molecular screening. In this, we are lucky that we are having DH23, which may be probably registered in coming years for its resistance to yellow and brown rust. So in the end, we can say that conventional breeding, if it is complemented with the double haploidy approach along with the molecular approach, it will be facilitate the conventional breeding programs and will result in development of number of genetic stocks which can be used by the breeders or persons who are engaged in rust resistance breeding. As Dr. Norman Borlaug has rightly said that rust never sleeps. So we have to be far ahead of this, and we have to keep on breeding new genetic stocks and varieties, so ahead of the new race. With this, I thank you all and all who have helped me directly or indirectly. Thank you.
Thank you, ma'am. Thank you very much.
Thank
Please take seat. Thank you very much. Next presentation is by Dr. Yadav himself, because Dr. Sharmila is not here. The presentation is on morphological characterization of magic population, reveals extensive genetic variation for morpho, physiological and yield related traits in bred wheat.
Yeah. So respected dignity on the dais, of the dais, as my student not feeling well, so I have to present that one. Next, please. Yeah. So we have developed the magic population. This magic population is multi-parent advanced generation intercross. The term was coined by Mackay and Powell in 2008. And the first population, magic population, was developed in the Arabidopsis, the modern genetic plant by Kovar et al. 2009. And these magic population uses the multiple foundal lines which are intermediate and self for the several generations, resulting in a diverse populations whose genomes are fine scale of mosaics of all founders. So these magic population are a very powerful tool to detect these fine scale QTLs
for several traits in the same population. So this is very good advantages for generation for detecting the several QTLs for multiple traits in the same population. So this the approach we followed. That first we have selected the 5 parent which have been identified based on different traits, and we intermitted those using the 3 simple crosses, and 1 parent which was the highly tolerant for the heat stress tolerance was used as both male and female to use both its the genome like parental genome and through female side. And we did the 2-way crosses in the oxygen nursery in 2017 and the 4-way crosses in 2018 at Delhi by crossing in all possible combination, including the reciprocals. So, and then we go for 3-4 generations helping. And so this is the now reels are in the generation 8 stage. So these are 5 parents, the APEC crop and NW10414, then the SD2864, very good variety for late sown condition, having the high 1000 grain weight, and other the component traits for heat stress tolerance, and the EP2338 and these other genotype genetic stocks were used for development of these 5 parental population. Of course, we develop 8 parental also and biparental also, but we are not discussing here. So we have advanced these by intercrossing and helping to different generations, and you can see the lot of variation for different traits, including heading 50%, anthesis, and number of component traits for heat stress tolerance. So these are the different. You can see that in that 2021-22, in that Rabi season, there was sudden heat in early March. So we will see that how much variation we got in that one. So we gave this topic to our student, PhD student, and she did the phenotyping using 23 these traits, which are some of the physiological traits, some of the morphological traits, and some of the yield-related traits. So this these are the box plot analysis. You can see that during the these 2 types trials we conducted for evaluation, for characterization these population, magic population. One was the mid of the December, which was the late, and one was the mid of January, which was the extreme late, so that we can expose our generation during the grain filling period to the very high temperature, like more than 35 degrees centigrade. You can see that a lot of variation was there for different traits. Like here, chlorophyll content was of course less in case of the extremely late. Similarly, this year canopy temperature are more in the extremely late, and all similarly number of characters were reduced in that case, but only this leaf rolling and vaccinate they increase in case of heat stress tolerance. So similarly, other characters, their number of characters got reduced. So and also got the variability and variation in this condition. And we found that these were grouped into the late sown genotypes. So that lines, there was 5 tail lines into 3 clusters, and under extreme late under 2 clusters. So number of particularly the 1000 grain weight was associated with the grain yield. And other characters was like grain length and grain width. Particular grain width was associated with the 1000 grain weight and yield also. So for the conclusion, we find that a lot of these magic populations reveal a wide range of variation, not only in the late condition, but also in the extreme late conditions. You can see the values are there. A number of important characters like spike length, plant height, a number of spike length per spike, and 1000 grade, they all got reduced in the extreme late conditions. However, these are up to like 50%, like in 1000 grain weight, and 55% in chlorophyll content, and like number of grains per plant more than 69% in a certain lines. So 1000 grain weight showed highly significant association with grain width, grain length, and number of grains per plant under both late and extreme late sown conditions. And these magic lines would provide useful germplasm sources with diverse allelic combinations, offering a greater chance of detecting QTLs for different traits simultaneously. These magic lines have been now genotyped using 35K breeders SNP chip for identification of PTLs. So we acknowledge this our student got the fellowship from PG school, that graduate school now from IRA, and director ICNM New Delhi for providing research facility and NICRA project for funding. So thank you very much.
Thank you, Dr. Jadhav sir. Thank you very much. Next presentation is by Dr. Avantika Moria. It is on genome-wide association mapping of grain quality traits in rice using single locus and multi-locus models. Dr. Avantika, please.
Good evening, everyone. The title of my presentation is Genome-wide Association Mapping of Grain Quality Traits in Rice using Single Locus and Multi-Locus Models. Rice, as we all know, the rice is a staple food crop for people across the globe, but the increasing population growth rate and high quality standards has created a niche for the development of superior quality, healthier rice. So we have undertaken the study to explore the genetic architecture of grain quality traits like aroma, head rice recovery, and the chalkiness percentage using genome-wide association studies. To achieve this, we first performed the phenotyping for the HRR, aroma, and PGC percentage. Then we obtained the genotypic data set from the 3K Rice Genome Project available at Rice SNP-seq database. Further, we filtered the SNPs at MAF greater than equal to 0.05. And these high-quality filtered SNPs were subjected to GWAS analysis, and the potential candidate genes were identified using Rice Genome Annotation Project and the Grameen database. We have phenotyped the 198 accessions obtained from IRI, which is the representative of the 3000 Rice Genome Project, and we performed the correlation analysis for these traits such that we found the grain aroma was positively associated to HRR percentage, and grain aroma was negatively associated to chalkiness percentage. The genetic differentiation analysis was performed to avoid the confounding SNP effect such that the principal component analysis and the phylogenetic tree distributed the accession into 3 clusters such that the first cluster and the second cluster were comprises of the indica genotypes, and the third cluster comprises of the indica genotypes along with the osporo and tropical japonica and temperate japonica. Further, the linkage disequilibrium analysis were performed. We found that LD-decay varied across all the chromosomes such that chromosome 12 has the fastest LD-decay and chromosome 9 has the slowest LD-decay. The SNPs were distributed evenly such that 1.28 SNP per kb was present, which is sufficiently dense enough to perform the GWAS analysis. Both single locus and multi-locus GWAS analysis was performed to avoid the false positive associations such that 39 common QTNs were identified, out of which 7, 13, and 19 were found to be associated to aroma, HRR, and chalkiness percentage respectively. The pink dot over here shows the association which were present in multiple models, and the blue dots shows the association which was present only by a single model. QTN QAR12 was found significantly associated to aroma. QTN QHRR72 was found associated to head rice recovery rate, and QTN QPGC23 was found significantly associated to chalkiness percentage. We found 75 clone genes in the vicinity of 100 kb distance of the detected common QTNs. Further, we evaluated the local LD blocks at 95% confidence interval, such that 54 KB block was obtained for QARR with 5 functional candidate genes. 4 functional candidate genes were identified for PGC, and 5 candidate genes were identified for head rise recovery rate. 4 key annotated genes were obtained, which were putatively regulating aroma, head rise recovery, and PGC, which can be further utilized for functional characterization in future and marker-assisted breeding for improving grain quality of rice. Thank you.
Thank you, ma'am. Thank you, Dr. Moria. Very good presentation. Next is by Rogel S. from TNAU. Mapping and mining of major genomic regions conferring resistance to brucut in background. Dr. Rogel, welcome. You have come from such a far off place. Yes, very good. I'm very happy to see one presentation from SCU also. We have 70 plus SCUs. Only one.
Okay. Respected chairs, co-chair, rapporteur, and fellow participants, myself, Ragul Subramanian from Tamil Nadu, and I'm going to represent my research work on mapping and mining of major genomic regions conferring bruchid resistance in black gram. As we all know, black gram is one of the important food legume crop of Indian subcontinent, primarily for its essentially involved in daily diets of which richness of protein content. In case of North-West and Himalayas, the cropping pattern is based on rice pulse and maize pulse only, with an area of production regarding 12,000 hectares, which is almost very, very less when compared to the production requirement. So, though we have those production strategies, still we have more production limiting factors such as that storage plus infestations like bruchid, which is Callicebruchus maculatus, and cause both quality and quality in storage in the subtropical and tropical areas. It caused nearly yield loss up to 90% in a storage condition, as it is the field 2 storage pest. And this is the storage pest Callicebruchus maculatus. It is also called a cowpea weevil. It is first originated from West Africa and distributed throughout the globe. It is sexually dimorphic, so that it can be easily distinguished. Male and female can be easily distinguished. So the beetle is as I said earlier, this is a field 2 storage pest. So maximum infestation will be caused during the storage infestation only. If you go for a 3 months of period, it will cause entire devastation of the storage crops. Then for this study, regarding a storage pest bruchid, if you are using pesticides or some other means, it's not a eco-friendly approach. So for being getting an eco-friendly approach, we are using a genetic improvement in it. For that, we have selected MD1 as a female parent and recurrent parent, and TU68 is an identified donor parent for us. It's from the previous study of us. So MD1 is a high yielder in South India, and then TU68 it is developed from the Trombe, which is having resistant to the bruchid. So this is the bruchid screening procedure. As I said, the bruchid is a sexually dimorphic, so male and female can be easily distinguished. So that the identified 5 pairs of butyl related into the 50 numbers of selected, 50 numbers of seeds in a closed and protected condition. And then we allowed it for 25 days. And then after that, the adult emergence will start. Based on that, we have to take a daily observation to count number of adult emergence, seed damage percentage, seed weight loss, and mean developmental period. So to identify the QTL for bruchid resistance, we analyzed nearly 625 SSR markers. And then based on that, we identified 46 polymorphic SSR primers between MD1 and TU68. In the biparental mapping population developed from MD1 and TU68, we surveyed all the 46 polymorphic masses, and the genotyping has been made. For the phenotyping, as I said earlier, the screening procedure is used. So to check the robustness of the identified QTL, 2 more validation population also generated simultaneously. Genotyping and phenotyping are done for that also. This is the intensity of damage done on F2 mapping population. Here we show the greater number of variability present in F2 mapping population from the highly resistant to highly susceptible ratio. Then based on the results, there are 3 QTLs which is found for adult emergence, seed damage, and developmental time in a linkage group of linkage group 5 and 8. It is accounted for 17% of phenotypic variations in a LOD range of 3.34 to 3.49 in a 1,000 permutation test. So the identified QTL information is taken on the validation population also for its robustness. Based on that, 2 markers, CDG 020 and CDG 302, which is identified for this potential involvement in brookit resistance. So this is the results. 3 QTLs were found for the LGG 5 and 8. And then this is the genetic map of identified QTL regions. And this is the validation population. For that, these markers have a robustness in having shows more than 22.47 to 23.309% variation explained. Then to identify the candidate regions within the QTL region, we taken the flanking markers information and then involved in biotechnological tools like BLAST, and then using the reference genome of azigubine through Vigna genome browser. By that, we identified potential genes which is having a defensive response against XBORI insects, which are FBUX proteins, cellular repeats, like that. So for the identified QTL regions will be involved in marker selection and marker backcross breeding to incorporate the resistance in the high yielding varieties. Further QTL sequencing through whole genome sequencing method also is in the pipeline. So soon we expect good things. Thank you. Thank you, organizers and co-organizers for the better approach.
Thank you, Dr. Raghav. Thank you very much. Thanks for going to insect resistance. Little bit away from the other presentations. Now, Dr. Pooja Patania, molecular and tipal morphology in delineating vegetable and amaranthine species complex. Please.
Good evening, everyone. I am Pooja Patania from National Bureau of Plant Genetic Resources, New Delhi, here with a brief presentation on the topic molecular and tipal morphology in delineating the vegetable species complex conserved in Indian National Gene Bank. Vegetable food group is an important component of the human diet, and worldwide expansion was reported in terms of consumption as well as cultivation. And among the vegetable amaranth is important because it is the rich source of vitamins, proteins, various minerals, and carotenoids. Amaranth belongs to the family Amaranthes, and it includes approximately 70 species, out of which 17 are grown for its vegetable leaves, whereas 3 are grown for its food grains. The most popular vegetable amaranthus species are Amaranthus tricolor and Amaranthus bleatum. These are some of the examples of the vegetable amaranthus species found in India. Out of these, Amaranthus viridis, Amaranthus spinosus, Amaranthus bleatum are the few examples which are found in the different regions of the Himachal Pradesh. Taxonomical delimitation is very vague in vegetable amaranthus because of the remarkable morphological diversity, adaptation to the wide range of eco-geographical region, and the frequent hybridization. So the present study is focused on 2 species which are widely consumed, Amaranthus tricolor and Amaranthus bleatum. Identification of these 2 species is difficult through its morphology, as it shows a lot of continuous variation, as well as the vegetative parts are highly similar. The diagnostic character for identification of these species is tipal morphology. And if we want to do the identification at early stages of its vegetative growth, a molecular intervention is required, where we can use the barcoding loci data, which are effective in identification of the species, as well as in studying the phylogenetic analysis. Here we can see the leaf color variation in both the vegetable species. Here we can see from dark purple, reddish purple, purple to different shades of green color are found in the leaves. In case of the tipal morphology, in Amaranthus tricolor, the ovate tipal is found where its tip is acute. And in case of Amaranthus bleatum, the taper shape is lanceolate with acute to acuminate tip. However, in both the cases, the taper length varies from approximately 1.1 mm to 2.2 mm. For molecular study, we have amplified the ribosomal DNA sequence, which consists of the ITS1 5.8S and ITS2 region. And while doing the pairwise multiple alignment of the consensus sequence, we have found total 8 parsimonic sites, out of which 4 are lies in the ITS region 1 and 4 in the ITS region 2. And while we have performed the phylogenetic analysis with the outgroup and the authenticated sequence from the NCBI GenBank for Amaranthus tricolor and Amaranthus bleatum, we have found the 2 major clusters, and both the clusters are closely associated with the Amaranthus viridis. In the first major cluster, as we can see, except the sample number 19, 17, and 21, all the samples lies 100% with the standard barcode of Amaranthus tricolor. Whereas in case of the second cluster, except the sample 27 and 24, all the samples lies 100% with the authenticated sequence of Amaranthus bleatum. However, as all we can see, the sample number 27 is significantly deviate from the second cluster and found in between the standard sequence of Amaranthus tricolor and Amaranthus bleatum. So I would like to conclude with the diagnostic character which we have used for identifying the species, that is taper morphology, is found used in distinguishing the species, found prominent in identifying the species holistically. Whereas in case of the Amaranthus bleatum, the taper shape is lanceolate, whereas the taper apex is acute to acuminate. And in case of the Amaranthus tricolor, the taper shape is ovate with the taper apex is acute. Consensus ITS sequence is generated for the DNA barcode for identification of the vegetable Amaranthus species. However, while we have done the phylogenetic analysis, some variants are found in both the cluster. However, correlating the DNA barcode variation with the varietal classification require further morphometric analysis and more barcoding loci sequences. Thank you.
Thank you, Dr. Saab. Thank you very much for making some presentation taxonomy, which is now very much neglected. Thank you. Thank you very much. So 3-4 quick questions, please. We are running quite late. Young.
Nobody is asking. I can have question to Dr. Chauta.
No, let us. I have many questions, but we will come and do that later on if time permits. Nobody? डॉक्टर साहब अगर यंग बच्चे कोई चलो एनीवे चलो
Dr. Madhu, have you tried what are the yield level of these DS lines? Have you tried that? Have you evaluated the DS lines you have produced? How do they compare with the checks in terms of yield? Okay.
The idea is generally DH are poorer and maize too, they are poorer. That may be the reason. So up.
My question is to Dr. Chauta that you discuss about the DNA barcoding and DNA meta barcoding. How you use this DNA barcode information for intra-species variability, especially for conservation purpose?
Sir, actually, in our case, we use the this only the between the different germplasm of the this horse gram, but in intraspecies we have to go for this chloroplast this DNA for the because it's RCBL and MT, so they are described to be used as a barcoding of the different species levels. Yes, sir.
You would like to say something?
Sure. So first of all, thank you, everyone. It's been a long day. I think there's one more session left, so I won't take much time. But I have three thoughts for all of us. First, I was sitting over here and I realized how difficult it is to be a student. I didn't understand much of the technical stuff, not being a biologist myself. And I was telling myself, Dr. Paroda, that, when I go speaking about my topic, how difficult it might be people in the audience. So that was my first learning. But great presentations, all of you. My thought to the presenters who were presenting at the end, who gave short presentations, is as you grow in your profession, learn to talk about the so what. The so what is that 2-minute thing that you want to convey to the audience. I think that's an important thing for you to understand. Some of you were a little all over the place. So that's at a broader level, my thought to you. I know it's not technical, but I think it's an important part of a career. From a trace discovery perspective, like I said, I'm not an expert, but many years ago, I worked on a big strategy project for a company called Syngenta in Basel. And we were looking at biofuels, and we were looking at something that they call the water strategy. At that point of time, they were thinking about how should Syngenta react to scarcity of water that will happen in the next 50 years in the planet. And at that point of time, they started looking at things like, and that was my first experience of terminologies like trace discovery and genomics and other specific things that we spoke of today. So the Northwestern Himalayas, as we all know, as we all discussed, have a lot of biodiversity. What I'm told is there will be specific genes around cold resistance, around drought resistance, around the biodiversity that exists around medicinal plant properties, I think was spoken about in the morning. So it's also important for you to start thinking about some of these traits that can be isolated possibly, and hopefully make the Western Himalayas conserve its biodiversity, but also more importantly, take these particular traits to crops and plants in other parts of the country and the world. So these are my very high level thoughts. Like I said, excuse me for my ignorance of biology. I left biology in standard 10. But a fascinating discussion and a fascinating set of presentations. Thank you.
Thank you, sir. Yeah, I have some questions and queries, but I will restrict to one and then 3-4 general comments. The only one point which I want to mention, that's about 2 papers. Different species of wheat are clubbed together in core, mini core, etc. Then, in case of rice, Japonica, Indica, all together. I will go with one species or only with Indica, not Indica and Japonica. One thing is, something is apparent there. We don't need to go to, until we work on systematics, that is something else. Secondly is when we calculate and also variance or R-square was also presented in rice. We need normally independently distributed data, which I think assumption will not be fulfilled when we have data on different species and different types as wheat and rice. So that is the comment. There are other on presentation. I will leave those because of paucity of time. Then one query to Dr. Sharma. You said that collaborated on rice, tea with Kenya and Sri Lanka. Do you need permission from somebody sitting at Delhi for such collaborations? Actually, there was a choice. Yeah. Do you need some? Yeah. It goes to headquarters. CSIR has the international ISP department, and how much time do they take? So there was a collaborative program because the program was that. So they didn't took much time, but the Sri Lanka took 1 year. Yeah, here I think we need to do something. It takes years and years. Please have a seat. Please have a seat. It takes years and years to have any collaboration on germplasm work in NARS. Then next is, I think somebody is noting the point because that's, and Dr. Agarwal has done a lot of work. We have made progress, but still it is a limitation. Then I had the opportunity to interact with wheat maize program, And I came to know that registration, this is for NBPGR, that registration guideline have been changed, made registration and has been made very, very difficult. So please have relook. When I was there, we said that, okay, if it is mentioned in annual report of the institute, of the university, then we should go for registration. Make it simpler. We want to register, we want to show it is our germplasm, otherwise somebody else will use it. Then very good studies on nutrients, nutritional traits. I think seeing what is happening for last 3-4 years, we should also lay some emphasis on climate change. Stress tolerance, abiotic stress tolerance. Then about authors, ये नहीं अच्छा नहीं लगता है. हमारे टाइम में ऐसे था कि ऐसी प्रेजेंटेशन है, ये एब्स्ट्रैक्ट है, तो 2-3 जो मेन जिन्होंने काम किया है, और जब अगर फुल पेपर जाना है तो उसमें आप नाम डाल दो. टीम इज आल्सो इम्पोर्टेंट. आजकल तो वैसे वो भी काम गड़बड़ हो गया. अदरवाइज reviewer and editor used to see it whether so many names are justified or not. But still, if you can. Another equally important point which disturbs me. Acknowledgement, head of the department, director NBPGR, DGICR. It is their duty. They are not giving you money from their pocket. और ऐसा लगता है जैसे किसी डायरेक्टर किसी कुछ करने नहीं देता है. It reflects very badly on the system. Please. तो हो जाए यार, हो जाए. बार क्यों बदनाम कर रहे हैं सिस्टम को? हो जाए. कोई एक आधा ऐसा होगा तो आपने कल कहा था कि ब्लैक शीप हर जगह होती है, तो हो जाए. अगर होता है एक आधा तो मतलब क्या सोचेंगे डॉक्टर खोसला साहब? हाँ जी, सारे ऐसे नहीं है. मैंने आपका रोका था. मैंने रिटन इंस्ट्रक्शन दी थी कि जिसने नाम देना है मेरे से डिस्कस करे. रिटन इंस्ट्रक्शन 2 times. मेरी पब्लिकेशन एज डायरेक्टर एनबीपीआर कम है, पहले की ज्यादा है, बाद में ज्यादा है, जब यूनिवर्सिटी छोड़ गया था. एनीवे, I feel concerned about the system. Then all presentation from the 3 presentations are there. Main 2 from IHBT and 1 from our system. And then all 5 minutes, only 1 from SAU. Where do we stand? Our IHBT, this is congratulations to IHBT. I am not against them. I am not against them. अगर वो 32 वैरायटीज कहते हैं हमने रिलीज कर दी, अगर वैरायटी भी उधर से आनी शुरू होगी तो आपका राम राम है. सबसे ज्यादा इम्पैक्ट अपना वैरायटीज पे आ रहा है. फर्स्ट थिंग. देन ऑफ कोर्स मशीन. अगर ऑन ग्रीन रेवोल्यूशन वैरायटीज को मिली 100%, पर अगर सोइंग डेट चेंज हुई, सीड रेट चेंज हुआ, सीड डेप्थ चेंज हुई, इरिगेशन शेड्यूल चेंज हुआ, न्यूट्रिशनल एप्लीकेशन, फर्टिलाइजर एप्लीकेशन चेंज हुई, एंड ड्रमी फॉर थ्रेशिंग अगर ना आती तो गेहूं घर में नहीं जाना था, मानसून में रह जाना था. सो सभी ने कंट्रीब्यूट किया. एवरीथिंग इज इम्पोर्टेंट, बट प्लांट ब्रीडर वी आर लकी दैट सबसे पहले सीड आ जाता है. तो अगर सीड ही आ गया CSIR से, एंड माई वरी इज दैट दे टॉक ऑफ बिजनेस स्ट्रेटजी. डॉक्टर शर्मा ने यही वर्ड यूज किया था. तो हर जगह बिजनेस ना आ जाए. अगर बिजनेस आ गई तो फार्मर तो जहाँ 64% फार्मर और हिमाचल दे हैव लेस देन 1 हेक्टेयर, हाउ दे विल फिट इनटू द बिजनेस. और जहाँ तो कोऑपरेशन हो ही जाए, पंजाब हरियाणा में तो कोऑपरेशन नहीं होगी, वहाँ कोऑपरेटर्स नहीं आएंगी. हमारे तो ब्लड में यही है, लड़ाई करनी है. हाँ, वो रेवोल्यूशन ही ऐसे हुआ है. सब अग्रेसर हिंदू कुछ से आते रहे. साउथ इंडिया तो बचा ही रहा, मिडिल इंडिया बचा रहा. तो थोड़ा सा लग रहा है, बट एट द सेम टाइम देयर इज ए प्रोग्रेस. कंग्रेचुलेशन एनबीपीजीआर. बहुत फर्क पड़ गया. मैंने 2005 में छोड़ा था. वी आर मूविंग विद साइंस. 30th कंग्रेचुलेशन. बट IHBT की तरफ देखो. वाई डॉक्टर तो IHBT कर रहा है, पालमपुर यूनिवर्सिटी क्यों नहीं साथ कर रही? वैसे ऑफ कोर्स अच्छा था पेपर डॉक्टर साहब का, कहाँ जहाँ बैठे, अच्छी प्रेजेंटेशन थी हाउस ग्राम पे, बट स्टिल just adjoining है. There should be collaboration, not can be, there should be collaboration. They have certain strength, we have certain strength. So with that, pleasure and thanks to organizers, Dr. Prodha Saab, Dr. Gautam Saab, Vice President Dr. Tyagi Saab, and Radha for this opportunity. And thanks to Dr. Khosla and Junior Khosla Saab. Dr. Saab, बहुत मन खुश हुआ आपकी maintenance of the development of the campus and maintenance. Wonderful. Thank you very much.
So this was indeed a very wonderful session. Thank you, everyone. Now I would like to request the co-chair of the technical session 2, Professor B.S. Dhillon and Professor Atul Khosla, to felicitate our invited speakers. First in order is Dr. R.K. Chahota. A big round of applause, please. Thank you. Next, we have Dr. R.K. Sharma. Big round of applause, please. Thank you, sir. Next, I would like to request Dr. Lakshmi Kant, Director ICR, VPKS, Almora, to kindly felicitate Dr. Monica Singh and Dr. Salej Sood. Dr. Monica Singh. A big round of applause, please. Thank you, sir. So, Dr. Saleh Sood. I will now request Dr. J.C. Rana to felicitate Dr. M.C. Yadav and Dr. D.P. Walia, who were the conveners of this session. Dr. M.C. Yadav. Big round of applause, please. Dr. D.P. Walia. Thank you, sir. Now I would request Dr. R.C. Agarwal, sir, Deputy Director General, Agriculture Education, ICAR, to kindly felicitate our co-chairs, Professor B.S. Dhillon and Professor Atul Khosla. Professor B.S. Dhillon. A big round of applause, please.
Already
Big round of applause, please. Thank you. So now we'll be having a short tea break outside APJ. So we'll be coming back for our evening session after 15 minutes. And an important announcement, like for the benefit of the participants and all the interested researchers, all these seminar PPTs will be uploaded on the website of ISPGR and Shoolini University. If any speaker has any objection regarding it, kindly let us know. We will respect your decision. Thank you so much.
तुमको लेना पड़ेगा ढूंढना पड़ेगा मुझे और बोल अरे कोचियर क्या है तेरे कांटा मार
बैठने की जरूरत नहीं मिलता है ना तो मत लगा तुम 4 चेयर भी लगा
कुमार मैम आप चाय तो पी लो सच्ची में पी लो मैम
मैं आप जाओ मैंने उनके साथ ना करवा देती हूँ तब तक
आप चाय नहीं पीनी ओएटी वाला Sonakshi ma'am. Welcome back, everyone. So we'll be proceeding towards our evening lecture. The rapporteurs for the session are Lokendra Kumar, Dr. Lokendra Kumar, Shoolini University, Solan, and Dr. Anil Kumar, ICR DMR, Solan. I would now request Dr. J.K. Sharma, Vice Chancellor, Baddi University, Solan, to please initiate the session. Over to you, sir.
Ladies and gentlemen, very good evening to all of you. Till now, we have been imbibing the agriculture-related scientific vibes from Dr. P.L. Gautam, Dr. P.K. Khosla, Dr. Dillon, Dr. Atul, Dr. Agrawal, J.C. Rana, and so many others. But now we are heading towards, I don't know whether we should call it as the lecture of the seminar or the extract of the entire outcomes, which all of us need to address in the future, and particularly the young minds, because for them, even the introduction of such people, Dr. R.S. Baroda, like R.S. Baroda, it will be the teaching to them when they will come to know what the task is and what the other things they are. Initially, I would request the speaker of the day, Dr. R.S. Baroda sir, and I would request simultaneously Dr. R.C. Agrawal, Dr. R.K. Tyagi, Dr. Y.S. Negi to please escort Dr. R.S. Baroda to on the seat. I shall be putting few lines only for Dr. R.C. Agrawal, so that later on, Dr. Tyagi, he will be introducing the speaker to the entire house. Dr. R.C. Agrawal, he post-graduated as well as doctorate from IRI, New Delhi, the Premier Institute. Later, step by step, he came to the position of the Registrar General in the PBFRA for right from 2011 to 2019 for a long span of 9 years rather. Thereafter, he has been taking care of the Deputy Director General of Education, Agriculture Education in the ICR Agriculture Division. And he has taken the agriculture system to the great heights. He is the recipient of NAS Fellow, recipient of Dr. B.R. Barwale Award 2017, then Sir Syed Ahmad Khan Lifetime Achievement Award in 2021, and he is the Vice President of the Indian Society of the Plant Genetic Resources. This is in brief few of the lines which I have said about him. Now there is a full page I have, but the time is not permitting to give me more details about him. Now I request Dr. Tyagi to please to brief about Dr. R.S. Baroda.
Good evening, everyone. Respected Dr. Paroda, Dr. Agarwal, Dr. Sharma, Dr. Gautam, Dr. Dello, Professor Khosla, many dignitaries in the front line, and the ladies and gentlemen in the audience. What Dr. Sharma has mentioned, that introducing the speaker like Dr. S. Paroda is also itself is a teaching to particularly the youngsters and even to us who always get the inspirations from Dr. Paroda, who is so active at this age and stage. Not only active, he is updated with all the agriculture developments at the global level. I had the privilege to work with him. In fact, I joined NBPGR when he was the director. And till today, in one way or the other, I am associated with him and seeking his guidance for my career or for other activities or contribution, what I have been doing little bit in my career. To this evening lecture, it's again my privilege to introduce Dr. Paroda. Although he's so towering figure that he doesn't need the introduction, but at the cost of repetition, I would say that his introduction is also a teaching what Dr. Sharma has mentioned. So, sir, Dr. Paroda, sir, and Dr. Agarwal, my colleague, co-chair, please permit me to read the introduction of Dr. Paroda, particularly for the youngsters who will, I am sure, that they'll be encouraged and inspired. And nowadays, you must be seeing the election time in the 5 states, and every party is giving the guarantee, 5 guarantee, 7 guarantee. My one guarantee is in this evening lecture that you will thoroughly enjoy this lecture, even after we are late in the session. And permit me, sir, one instance. I happened to be with him in Bangladesh, and he delivered one lecture. That is, I think I have heard Dr. Paroda many a times in NBPGR, in ICR, outside ICR. But in this lecture in Bangladesh, I believe that auditorium was having capacity about 1,500 audience. It's a big audience. And from all over the universities in Bangladesh, the faculty, the students traveled from different corner of the Bangladesh country to Dhaka to listen his lecture. And believe me, whatever the audience was inside the auditorium, more than 2 times audience was outside, and organizer had to make the arrangement of the audio arrangement outside that hall. I'm sure that you people will be benefited a lot by this lecture. Coming to my assignment, special assignment, what has been given to me to introduce Dr. Paroda. Dr. Paroda, former Director General, Indian Council of Agriculture Research and Secretary DARE, Government of India, is an accomplished plant breeder, a visionary research administrator, development practitioner, and highly sought after policy makers, policy advisors. A renowned agriculture scientist of international repute, Dr. Paroda is undeniably one of the greatest leaders in Indian agriculture scientific community since the 5 decades. Dr. Paroda ably transformed the Indian National Agriculture Research System, where serving as the Secretary DARE and Director General ICR during a period of 7 years. His vision led to creation of more than 30 new institutions in different sectors of agriculture like crop, horticulture, livestock, natural resource management, fishery, agriculture, engineering, social science. This strengthened the NARS system, one of the leading research and development organizations in the world. India's National Gene Bank, where I was fortunate to serve for almost 9-10 years, at New Delhi, is second largest in the world, currently holding about 0.47 million accessions of different crops. Dr. Paroda could seek a grant from USAID to build this entire new complex of NBPGR while serving as director of NBPGR from 1985 to 87. Just see the short period, 2 years, 2.5 years. So this National Gene Bank and the whole complex of NBPGR, most of you have seen, is built up within the 2 years efforts to draw the funds, deriving the funds from different sources and give a direction to establish a National Gene Bank. The Gene Bank was inaugurated by the then Vice President of India, Dr. K.R. Nayan. Besides building the most modern gene bank at NBPGR, he created 5 bureaus of genetic resources of animal, fish, microorganism, as well as useful insects. As a result, India today has the best network of institutions to manage its valuable genetic resources in the different sectors. His deep passion for genetic resources management led him to make special efforts in establishing gene bank, not only in India, but all 8 countries in Central Asia and Caucasus region, what is commonly known as CAG region, while heading the CGI program of CSE Tashkent. And in fact, Dr. Paroda is known as the father of the gene bank. And in that way, in that series, in recognition of his exceptional contribution in the field of genetic resources management of ICRISAT, Atancheru, and the Agriculture Research Institute at Kazakhstan has named their gene banks after Dr. Paroda, and he is nicknamed world over, known as Gene Bank Guru by his friends and admirers. It was his foresight and determination to lead the construction of the unique National Agriculture Research Center NASC complex, where we have gathered, where we have organized several this kind of conferences at national or international level. The NAC was built in record time of 5 years and was inaugurated on 3rd of January 2001 by none other than the then Honorable Prime Minister Shri Atal Bihari Vajpayee ji. Dr. Paroda was instrumental to establish ISPGR at NBPGR 1987, and is its founder president, gave the required boost for running ISPGR, which completed its 37 years of the establishment of this month. Since then, ISPGR has undertaken several activities under his leadership. A special mention is to be of First International Agrobiodiversity Congress held in 2016. It was vision to make IAC, International Agrobiodiversity Congress, a rolling event, and we are happy here that the second IAC was held in Rome, which was steered by Biodiversity International, Alliance of Biodiversity International, and SEAT. Dr. Rana is here. And the third is to be organized in China. His lifetime work in service of national agriculture, especially for the population of science and to link it to society is exemplary and has been duly recognized in form of several prestigious national, international awards, including Padma Bhushan, conferred by the government of India in 1998. I was at loss while compiling this 1.5 page note that how to sum up all these awards, what he has been conferred with for his great contribution. And I really failed to write each and every one. And here I am, due to the paucity of time, I am not naming each and every one, but I can say that you name the award in the country or many in other countries also, Dr. Paroda is conferred with all those prestigious awards. But I would like to mention that recently he has been elected as Foreign Fellow of very prestigious, globally prestigious Australian Academy of Technological Sciences and Engineering, what is called the ATSE. Dr. Paroda had been the founder chairman of GFAR, Global Forum of Agriculture Research, from 1997 to 2002, based at FAO Rome. He also served for more than 2 decades, from 1992 to 2014, as Executive Secretary of Asia Pacific Association of Agriculture Research Institution, commonly known as APARI, in FAO Bangkok. And I also had the privilege to work in APARI till before a month or so. Dr. Paroda also served as Chairman, Farmer Commission of Haryana from 2010 to 14. He was also member of Advisory Committee of ACIR, CABI, WMO, and was Chair of Board of Trustees of ICRISAT and member of Finance Committee of CIMEC of CJIR system. Currently, he is serving on the Board of International Fertilizer Development Center, IFDC, Alabama, USA. For the last 2 decades, Dr. Paroda is serving as founder chairman of TAS, based at Indian Agriculture Research Institute, New Delhi. Ladies and gentlemen, it's indeed very benefiting to the evening lecture on global concern of PGR management is being delivered by globally recognized visionary and scientist, Dr. Paroda, sir. It's my great honor and privilege to invite you, sir, to take this stage and share his immense experience and wisdom with all of us today and your blessings this evening, sir. Dr. Paroda, sir. Forward, backward, forward.
Chairman of this session, and also our colleagues, Dr. R.C. Agarwal, the Deputy Director General, Education, ICR, Dr. R.K. Tyagi, who is also Vice President of ISPGR, both the conveners, Dr. Sharma and Dr. Negi, all senior colleagues, friends here who had been with us all day, dear participants, and I am told that also PG students and staff members of this university have also possibly joined to know more about genetic resource management. First of all, I must thank you, Dr. Tyagi, for a very generous introduction. At this time when we are almost all tired, I don't know how much capacity you still have to hear another lecture, but
organizers did not excuse me and insisted that I must speak on genetic resource management and specifically the concerns that are there which need to be looked at. And in that respect, if we see that there is concern. Can you put this black down, or it cannot be? This row. So when you look at first of all, how much of biodiversity we know, this itself is a question. And now we are in current century, talking about all the advancements and want to use more and more of genetic resources. And these had been the basis for our survival all through globally. But possibly we had been happy with only roughly around 8% of the species identified so far. And when you look at, and when the estimates which are there, I don't know whether these estimates are right or wrong, but when you look at, you have almost estimated species which are more than 10 million. So this itself is a concern. How long will we take to study them? And you would require institutions and human resource to do this. You will require efforts, commitment, and then also the zeal of the people to see whether they would like to understand what they have been bestowed with by the nature. In this respect, then when we look at, there is also another issue that it is not biodiversity, but possibly all civilization was there around the plants, animals, also other living materials and species which could help survive the human beings. And in that respect, we were earlier nomads, but we got settled thanks to, again, the efforts of the women, and therefore role of women in genetic resources has to be recognized. That they insisted that men must settle down rather than being only going after hunting and then becoming a gatherer. And cultivation and agriculture started from there, taking care of good quality of seeds and to be used from season to season for their food, clothes, and shelter, etc. So agro biodiversity therefore becomes important as far as our priorities. It's not that biodiversity is not important, but we from agriculture sector or from the point of view of our human survival have to think of, and in that context, we have to see as to where we are and what we are doing to manage them, and are we effective in managing them. I would not like to go into the details of this. FAO definition clearly tells that when you have agrobiodiversity, it includes the wild relatives. Much was talked about the wild relatives and their use, collected, developed, maintained, improved for the purpose of food, and then fodder, fiber, fuel, health, and nutrition. When we talk about agrobiodiversity, we have to think of not only that agrobiodiversity is confined to your own area, jurisdiction, or your own country. It has to be an issue of geopolitical landscape. It is beyond. They don't recognize the political boundaries or geographical boundaries, and they have been exchanged in the past. We will talk about it later. So when you talk about managing them, you don't have to only think introvert, but you have to be also globally alert and wise. In that context, The recent example was about, I think, 30 years ago. This Uganda black rust, UG99, was identified, and it is a devastating disease as far as wheat is concerned. Among all the rust, the black rust is very damaging. And when this rust was identified, Borlaug became very concerned because it started spreading and came up to Iran. And therefore, the concern was that if it comes to the green revolution belt like India, Pakistan, and South Asia, perhaps it will be much more challenge for the human survival as far as food is concerned. So a global initiative had to be taken, and this is being supported by Bill and Melinda Gates Foundation, continuing till today as an international event, and in which India is also now a partner right from beginning. And we know how many of our varieties are having resistance to this particular race. So we became alert. Fortunately, this disease has not spread it beyond Iran, and for last almost 2 decades, and therefore we have not much of worry which was once created. But what I am going to just mention is that just think of only yourself and not think of in geopolitical context is not a wise step, and would require greater attention, partnership, collaboration, and also initiatives. When we now look at also biodiversity, there is another concern that due to overexploitation, in 18th century, the whole world population, thanks again all those industrial revolution which took place, and Revolution 1, Revolution 2, Revolution 3, Revolution 4, that in 18th century, we all of a sudden became double in our human population globally. And in 19th century, we became again tripled. Now, this never happened before. So we were in harmony till 18th century to a greater extent with the plants, with the animals, with the nature, and with our food requirement. But we ourselves have imbalanced it because of the demographic pressure. And now pressure-wise, we know that India is number 1 in the whole world. We have taken over China only few months back. So we are the most populous country today. In that respect, the overexploitation led to certain identification of hotspots where some of the species being more exploited and getting eliminated, and there is genetic erosion that is taking place. So we have to think in the context of which are the areas, regions where this destruction is taking place. And for example, I was a young scientist in Haryana, and when I used to travel to my own hometown, Ajmer, on the way I will find a lot of plants, what you call is pilu. This pilu is no more existing, which is highly salt tolerant, otherwise material. And therefore, you have to, in fact, now start worrying that many of those things which were there or which are still there are still disappearing before you if we do not take care of it. But it is currently still existing in Kutch region. So biodiversity hotspots become important. Then we know there are challenges that are happening, not only the biodiversity loss, but climate change is also having its toll on genetic resources to a great extent. The pests and diseases, and when the cropping intensity has increased over the years, the pests and diseases also in the tropical conditions which we have in our country to a greater extent, the incidence is much higher, and therefore they also affect the biodiversity quite adversely. Genetic erosion in nature also is an issue, and I'll come to the last part, biodiversity, the access and benefit sharing. So the concerns became that what to do if these are all getting eliminated, and even today when you have many of these you know vegetatively propagated plants and you grow them in the field, when you can't store them through seed, then many of them get eliminated if there is drought, if there is a flood, or if there is a frost or any of those natural calamities that take place. So emphasis was then that please collect whatever you have. You will, whether you know much about them or not, just go, explore, collect, and conserve. And conserve by putting them into the gene bank. So XC2 conservation became a good option before global community, and they started then creating whatever facilities or resources they had, their own gene banks, and started storing these materials. We know that almost 50% of the variability that we have at global level conserved in the gene banks is in the gene banks of these countries: USA, China, India, Brazil, Russia, Japan, South Korea, what to talk of many other countries. I was in Central Asia after leaving ICR for about 6 years, and I had to create in each of those countries which became independent from Russia, whether it is Uzbekistan, Tajikistan, Kyrgyzstan, Azerbaijan, Georgia, Armenia, Kazakhstan. All those didn't have, though Russia had a very good gene bank, which was Vavilovian gene bank. And Vavilov really was the person who traveled all around the world. And that also was a time when he could go, collect, and bring. Today you can't do that. I will talk about it. If I want to go and collect and bring globally and then say that this is gene center, that is gene center, those Wavilian gene centers, 8 which were earlier named, and the best gene bank they had is in a pathetic condition today when you go and see. I had been there and have traveled few times. So, but at one time it was there, but then these countries became independent of Russia. They had nothing. All their material was stored in the St. Petersburg gene bank. So they didn't have anything. So you had to start by initiating some kind of storage facility, and each country had to be helped to create their own gene banks. So many of these countries don't even have, and they don't even have the support from the government to create, because it is not only storing the seed. When you manage, it requires resources to run the gene bank, and a very high cost of it. So these are also the issues when you talk about the management part. I will come to the in situ later. So you have a continuum. The lady right down in Odisha, taking care of your wild rice, Orija, Nivara, and then trying to live with it and protecting it. And many of these people have been then given rewards by the authority which we later created. There is a situation of this kind. There is a situation where you are conserving them into the best possible gene banks. There are also gene banks which are called seed gene banks at the 4 degrees level, which means ambient temperature. And you also have cryo system for preserving, which are vegetatively propagated either through pollen or through buds or through cuttings. And then you have field gene banks. So those who do not have any other thing, they still have the. So there is a continuum, but you cannot say that one is enough, the other is not important. The other part is that when you talk of genetic resources and about their management, there was time when they were exchanged, not only collected, but they were also exchanged as required and requested. And the lessons that we had that time learned in plant breeding about genetic resources was that these are the common heritage of humankind, was the first. And the second was that they are exchanged freely. Now, both these principles don't exist today. I will come to it later. So, if there had not been dependence, our food basket in India would have been entirely different. Just see here what came from abroad and what you are eating today in your food plate. Potato, tomato, chili, carrot, maize, soybean, sunflower, apple. We are saying Himachal is apple state, but it is not our, it came. And if it would have not come, what would have been the situation? Just imagine. So this kind of situation, and still today we are requiring introductions of oil palm, introductions of kiwi fruit, dragon fruit, monk fruit was talked about, and then hing we are importing, and we just do not know how to still cultivate and take full benefit of it. So you require the dependence in terms of, so sometimes when you manage them and then you say, well, I have enough and I don't need any, I think you are mistaken. And that's where we have to still start looking at what we need. And somebody was talking about yellow rust in wheat, and same from Tuticorin earlier. Dr. Nagarajan was in charge, and epidemiological studies were done. He said, sir, if we have to manage the yellow rust, it becomes problem sometimes, not every time, because of the temperature. And when there is a low temperature going early, then there is a problem. And for that, we have to have collaboration with the hot spots of where there is much more, evolution of these rust races. And that is in Central Asia. So he said, if we want to manage, we have to collaborate with Central Asia. Like if you have to manage the black rust, you have to have collaboration with now Africa. So those kinds of situations are again required. And over the years, in fact, this is where my main talk starts, that concerns on genetic resources have become serious issues. They are not as simple now as they used to be. Maybe earlier people were lucky, fortunate, or they were ignorant. But as you make anybody more knowledgeable and mention to, like in this, let me start with Rio, the Earth Summit. The first Earth Summit was held in Rio in 1992, and there that call was given for sustainable development. So everything should be taken care of for sustainability at global level. And all countries, more than about 176, had signed it. They met after 10 years in Johannesburg, in 2002. And then they said it is not the Earth Summit, but it is the Summit for Sustainable Development. So it became Global Summit for Sustainable Development. And earlier they said you should, whatever you have, you conserve and take care of them and share them. But then they said the conservation should be through use, not by just collecting and putting in your gene bank, which you can sometimes call as black box. What is the use if they are only just stored and kept inside and not used? So the emphasis was for your sustainability, you must conserve, but conserve through use. And that call was given. And when that call was given, then the Convention on Biodiversity was established. So after 1992, many things have happened. UPO, I would not like to talk today. It is relating to the plant breeders' right in Europe mainly, and it has become more complicated after 1991. 1978 was much more comfortable, which we wanted to join, but later on we dropped the idea. But in 1992 onward, now the CBD came in 1993 after the Earth Summit. The CBD asked all countries to take care of their genetic resources and have a sui generis system for protection. Because everybody said, these belong to you. If they belong to you, then what is the mechanism? How do you establish that they belong to you? So there must be some kind of legal system, regulatory system, and that's how the sui generis system was called for. And each country started thinking of bringing their own laws, and we also started working for it. And that's how we brought out National Biodiversity Act, and also we brought out the Plant Varieties and Farmers' Right Act, which is unique in the whole world today, because no act there which has farmers' right also included along with the plant breeders' right. And this we had written, Dr. At that time, Gautam was the director, and we started in ICR, and we said, we must have this because you must protect whatever you have, your varieties. And this issue also, management of genetic resources, came when there was patent taken in Germany on haldi. And haldi belongs to India. And the treatment for which it was being now claimed for, and they said that this is our patent, and then we had to fight Dr. Mashelkar from CSIR and myself, and then it had taken us almost 6 months, a legal fight at the global level to establish that haldi is ours, not of Germany, and they had to withdraw. Then came again another act which they took on the taxmati, on basmati, and taxmati in USA, which again we had to fight. So the question is that these issues started coming, and legal requirements became, earlier scientists were exchanging, now the legal issues started entering in. So the issue became more difficult, and then came the Cartagena Protocol on biosafety, and then Kyoto or Nagoya Protocol, which again is another important one. Because if I talk about this whole thing, an international treaty also was signed, which is for multilateral. I think many of you will know that material which we have from different countries in the international gene banks of the international institutes like CIMMYT, IRI, ICRISAT, ICARDA, then that is under the FAO umbrella, being governed by the treaty, which is a multilateral exchange system. But under the CBD, whatever these legal laws which have come, like National Biodiversity Act, you have a bilateral system of exchange, which means you have to directly deal. Here you can have whatever is there in those gene banks, which we have assigned and given accession to, those could be taken by anybody. So the issues started becoming more and more complicated, and many countries have come up with their own laws. Many don't still have their laws, but everyone started then saying, after we brought in National Biodiversity Act, and both of them were brought at the same time, 2001 and 2002, I think. So they both were at the same time, and then even panchayats were told that material of your village area belongs to you. So the permission has to come from panchayat. So people started becoming alert and more catalyzed in terms of their right. And this right had its own concerns, which is a management concern I will mention shortly. So the paradigm shift has taken. We all know, which I told you, that in public domain they were there before. Now the shift is towards genetic resources are not so far anymore common heritage. They are not available freely. The public domain during 20th century turned into diversity for development and diversity for sustainable use and development. So everywhere what happened is that now it belongs to me and I will decide whether I give it to you or I don't give it to you. But degree of dependence has been therefore affected to a greater extent after these laws. And when you look at, say, the entire North America, Latin America, they cannot boost for any, except Mexico, for maize and few species. They cannot boost for any plant which originated from there. And when you talk of, and all this civilization, whether Yellow Valley in China or Indus Valley in our, what you call is Indo-Burma region that time, and then Nile Valley in the Egypt region. So Middle East were very rich. India, the Hindustan region was very rich, and the China region was very rich. The others had all been dependent. So, but they have gained, and that's why when I could get the support from the USA, my argument to them was that you have taken so much of genetic resources from India. In return, at least you must help us to build our gene bank to keep our own seed material. You are still asking us. And they very easily and quickly gave, because they understood the argument. So this treaty has come. Lot of legal issues have come. You have to understand all these legal, policy, regulatory issues in genetic resource management. And this by itself has become a subject. And I would say that NBPGR should also have a department of legal affairs sooner than we are late. So when it is exchanged, earlier you asked me as a scientist, I will send you. Now, if you ask a scientist, then he has to think of what is required under CBD or ITPGRA or under TRIPS, and then some bureaucrat and lawyer will tell whether it has to be given or not. So management part has become a bit in others' hand, not that free. And there are still issues relating to the treaty because many are not aware about the treaty. So I won't go into the details of these. But when we signed the treaty, I was part that time of signing it and agreed for the annex, which is for 64 crops. That was around, 2000 or 19, I think it was around 1995, 1998, something like that. And possibly you had been then going at that time. And so we agreed for 64 crops for exchange under multilateral system. And then that time decided that we will expand it as we go along, because not only 64, many other crops are required for the what we call as TT for genetic resources for food and agriculture. So for food and agriculture, there are many species. Like cotton even is not still included. Soybean is also not yet included. And we thought they will be included later. After 20 years, still situation is the same. Nothing has happened. Because everybody is now not wanting to do anything further, don't want to add, or the lobby, whether it is the private lobby for cotton or for soybean in the US, didn't allow us to include them, whereas we wanted them also to be included. So there are concerns relating to genetic resources, and the major concern which has happened also over the years is that there had been less use of genetic resources for breeding in the national system. And this was analyzed by FAO through a study, and I was also part of it that time. And we realized that more and more of wild and weedy species are required to be used for genetic improvement, for resistance to stresses, as they are resistant otherwise. But then there seemed to be some kind of complacency, dependence on international centers to get the pre-breeding material and select them and be happy with the varieties, which is an easy, alternative which breeders had found. And biotechnology also affected plant breeding adversely to a greater extent in India. Everybody started becoming biotechnologists and lab work, and didn't know how to then use their end products to reach to the farmer, because then you needed again the linkages, and those linkages were broken. So there had been concerns relating to genetic resource for research purpose as well. So I would like to say that when FAO, we had this analysis, then we said what to do. So you have to support, because many countries don't have even the strong programs for genetic enhancement. So again, a global initiative on plant breeding was started. It is still continuing, and this is also supported by Bill and Melinda Gates Foundation. And FAO is supporting many developing countries to make use of more their wild and weedy materials in their breeding programs. Finally, we come to the part of, okay, there are concerns, then what to do at the national level. They are there, they will remain, they are not easy to be solved. Maybe they will take their own time. So in that respect, what you should do, you just sit and just watch, or you act. So think globally what is happening, but you must act locally. If you don't act, then what is the point? And that's the issue which I will like to bring to the notice of our young generation, that when I joined as director of NBPGR, there was not even a single room with the controlled temperature where the seed could be kept for 3 to 4 years. Every head of the division had the air conditioner in their rooms, but no air conditioner even for the seed storage. So, and I was there for only 2 years as director. I should have said, well, it's not my problem. It had been there. It will continue. How does it matter? But the point is, then I had an opportunity to go and see the Japan Gene Bank, the most modern Tsukuba. I went to Korea, also saw their Suwon Gene Bank, went to Vavilov, went to also USA and saw their Fort Collins Gene Bank. And I said, well, where we are. And if you think globally, but don't come and act locally, then there would be nothing done. So you have to catalyze the system, catalyze the policymakers, catalyze your colleagues, and also see that this, whatever is required for the nation is created. So what is required is the action, and then not only one institute on genetic resources. It was again, I will come to that. India is quite rich, as is already known. I don't have to take. And thanks to these mentors of genetic resource work in the country, that they gave support for genetic resource activities. Dr. Paul had published his paper, which is still famous and was cited, the search for new genes. What you need is to search for new genes. Not only to just see the plants and whether you can use that gene for your genetic improvement. So that kind of effort, we started from there. Dr. A.B. Joshi was the director when NBPGR was created. No director of that national institute would permit another institute to be created within the same institute. To tell me whether there is any example. But they were committed. It's not that anything was forced on them. If I force, then something can be done, but willingly. So willingly, and Dr. M.S. Swaminathan was a student of Dr. Harbhajan Singh, who is the, Vavilov, Indian Vavilov, who collected all those genetic resources from very difficult terrains in old times, going on horses and by foot in Himalayas and where not. I mean, he is like Vavilov, where he went all over the world. Harbhajan Singh. And then, of course, people like Dr. R.K. Arora, who are our colleagues. And so when you see that these are the people who gave importance to genetic resources, and these are the people also who were helpful in building the institution. So when we had one institute, and luckily when the opportunity came to me to head the ICR, I said genetic resources are not only plants, we also have animals. The great variability globally, if you look at in animals and the kind of work now the institutions are doing, or the fish, or for that microorganisms, or for that matter even insects. So all these bureaus were created. And because you need a system, if you don't have an institution, if you don't have Shoolini, who will do research for the plants which we are working here and the kinds of genetic variability that is being studied today. So you need such universities, different parts, the institutions, whether it is Almoda or whether it is Leh. But now we have to put our acts together, work together, because these are not the responsibility of only one. We have to have a networking approach, partnership approach, and so on. So you have to have first requirement, and Dr. Borlaug told me when I asked him, what is the secret of green revolution, Dr. Borlaug? Why it is not happening in Africa? You are working, you are the same person, same wheat varieties. Technology is even much better based on the experiences of India. He said, neither there is policy support, neither there are institutions, neither there is human resource, nor there are progressive farmers. So what you need is, the things cannot just happen. So you need, and these bricks and walls don't make these institutions. So you need again human resource, trained human resource, capable human resource, and then also you must have partnership. You cannot work alone, as I mentioned in the beginning. So our gene bank also now competes with the best gene banks. We created a capacity and we made this gene bank, which is earthquake proof, underground, because you do not know, we are in a sensitive seismic zone area. Anything can happen anytime, and then you can't go that, okay, today I have 2 lakh samples, so I build this much capacity. We had built 20 years ago, and still half the capacity we have filled, but we built it for 1 million accessions. Not only for just 2 lakh or that time, whatever numbers we had. So you can compete with the best ones, but then our recommendation was that you cannot really still depend on. So you should have duplication of these in different gene banks, regional gene bank, and even have a duplicate permafrost facility, which was recommended. Like now at global level, after the crop diversity trust was created, this what you call is Svalbard Norway Gene Bank, which has come up. All the material from the international gene banks has been duplicated in this particular facility. We have also recommended to the ICR, our committee was there, I think Dr. Gautam, you were also part of that, and Dr. Dillon, and Dr. Sharma, myself, and Bansal. I think we all have given, 2 years have passed, nothing seemed to have happened, and perhaps duplicate facility, and I think we had recommended duplicate facility in Himachal Pradesh. So you require this to be put, anything can happen. And these genetic resources are not for you and me. These are for posterity. These are for future generations. So that also is a part of management. Of course, you have the acts. I don't have to give into details. But see, after these acts have come, the exchanges have gone down. Universities, private sector is the only one which is able to do it, because they go abroad, they have their arrangement, they get the material, they even pay or whatever, and then they can get the material which comes. But otherwise, the system has been affected adversely. What you also require for the management is that, okay, you have so many institutions, you have so many facilities created, but then whether there is any initiative and action plan, whether there is any mission for genetic resource evaluation, these resources need to be evaluated. Whatever we have now, 4 lakhs, how many of them have been evaluated? How many of them are duplicate? How many of them, in fact, are having useful genes for those particular stresses or challenges that we are facing today? Just by evaluating them, growing them in the field is not going to help. So I was happy that today there were presentations, and even presentations from NBPGR, young scientists, and that they are trying to identify genes. They are trying to identify sources for resistance, and they are trying to go in for genomic studies or genomic editing, and then possibly tomorrow they will be used as and when they are required. But this would require massive effort. This would require a mission mode program, and time is running out. Whatever we have in Himachal, have we evaluated properly? And when we will, how we will use, if they are good medicinal plants, which of those medicinal plants can be commercially exploited, which can be value added, which can be taken full benefit of, and how many of those plants are belonging to us, where we have to take our GI on them. Patenting is also very important. And so there are issues, but then for that you require, and it was at a suggestion to the ICR, a National Advisory Board is there, because there are so many bureau and so many activities. So the bureau was created, this board was created. I happen to chair, and you see Dr. I think Gautam sitting there, and I happen sitting, and others also are there. And but this was there till first, for 3 years it was constituted. I understand after 2014 it has not been reconstituted at all. But what did it do? Why we needed it? See, all 5 bureaus had to develop their guidelines. There were no guidelines for management of genetic resources. So the guidelines had to be prepared by everyone. And these guidelines are now being taken as examples. I was told that in case of fishery, the FAO has taken the guideline of our CIFR from Lucknow as a model for developing for the global level. DSC had not notified the materials that was accessed under treaty for 20 years. So we insisted, and then Department of Agriculture, Ministry of Agriculture notified it for the first time, so that others can make use of it under multilateral system. You require a specific, system for sharing germplasm. So a standard material transfer agreement by which you can give it to private sector. There were no such clear guidelines and procedures. So these are also required as management. Otherwise, how will you manage them? How will you give? Under what conditions? And so many of these information on genetic resources were also not put in the public domain. Now, when we fought the, these cases for Basmati, Taxmati, and also this turmeric, the legal requirement was that what information you have in public domain, which proves that it belongs to you. So the question is, you may have a lot of information, but if you have not put in public domain or published it, then nobody is going to believe what you are otherwise having. So for management, what we have, whether you give it or not, but there was reservation that if you put on public domain, somebody will like to ask us to give the, but unless you tell what you have in the locker, what concern do I have how much gold Professor Khosla has in his locker? Unless he comes forward and tell, I can share and I have this much. So this is in fact an issue again of management of genetic resources. We had to have a mission program, how long we will take time. So we collected almost 2 times the germplasm I talked earlier. And then responsibility of all cannot be with one institute. Horticulture is again amazing diversity. So IIHRB given delegation on behalf of NBPGR to take care of the same responsibility. So you have to delineate And that delineation still is not there, which we had earlier for genetic resource exchange for NBPGR, when perhaps I was, and I think you and I don't know, Dr. Dillo, during your time also, that we used to approve as director what is to be given and sent out. Now you have to go to these babus in the ICR and run around and send the proposal, and they don't know anything about it. And why, they will say, why should we give? You understand why we give and why what we are taking back. So these again are the issues which are there, and the delegation of responsibility under National Biodiversity Authority to NBPGR is still not there. It's a management issue. But how long will it take? Because if you do not have these delegations, how can the things be really taken care of? Anybody will say it is not my concern. So concerns on germplasm use, overall complacency for the breeders, not using much, need for research on traits of interest, which I think is important and has to be given high priority, lack of access to information. We must make sure that we have partnership, we know what we have to do each other, and less use of wild relatives, and restrictions on germplasm exchange, which I talked earlier. And of course, we need more funding support. If you do not have, and use, this is the situation. Among the total collection that we have, just you have 1% the crop wild relatives. And their use, therefore, has to be. But have we evaluated those wild relatives and documented? Have catalogs on them? What traits they have? And you talk of QTLs and whatnot, and you want to have them from the. So our emphasis for research must go now on wild and weedy materials. If we have not gone for nobilization of cane, crossing the sugarcane with the saccharum or spontaneum, the sugarcane would have never come to North India. It was only tropical crop for tropical conditions in South. Because of the nobilization, crossing with the spontaneum, you could bring in resistance to both drought and also to the stem borer and other diseases. So it could come. And you could shorten the life cycle, because in the South it is long duration. Same way, if chickpea genetic resource, if you would have not made it short duration, this is an issue of adaptation again. And that we will have to take care, that you have to adapt. And adaptation will be by going in for short duration materials, by breeding for resistance to abiotic stresses. And the chickpea would have never gone to South, but from 180 days crop, it is now almost 70 to 80 days crop. It is now grown all over India. Arhar would have never gone to North India if it was not also shortened in terms of its maturity. It is almost again that there are 300 days and you have brought it down to 120 days. So it came to North India only just because of that. So there are options and these are opportunities, but they will require proper evaluation, study, and taking full benefit of them. Information I have already mentioned. It requires to be, we need to know what do we have, which institution has what, which regions have what, and which are the hot spots, and which are in the gene bank, which are in the field bank. All this data is very critical and important. And the data about the traditional knowledge, like we collected the germplasm at the same time under NATP, we had also instituted a mission for collecting indigenous knowledge of the farmers, and through KVK's involvement, and that publication is there. I don't know whether that publication is on NBPGR website or on our ISPGR website. I was talking to Dr. Gautam today. It's a 5 years very good effort of going and working with the farmers and knowing what materials they are using, what they are having, and that has been documented as traditional knowledge. So this traditional knowledge is very important, has to be documented as quickly as possible. Otherwise, it will vanish with the people who are aware of them in terms of their importance, and more so in case of medicinal plants, their medicinal value. So this I have mentioned, you need to have the science to be used, harness it more effectively, and you have to have more information exchange. And mention was made, partnership for research, knowledge, what is happening globally, and then also public awareness. So for these required kind of societies like this ISPGR, which was not there, had to be established. There was no postgraduate program on genetic resources, that had also to be started. There were reservations. No, IRI never wanted the PG program on plant genetic resources. So when I became Director General, I said, now it's my chance. I forced that you have to do it. And when I was director, they were saying Academic Council doesn't approve. So the question is that these are also very specific requirements, but the human nature, you don't touch my empire. The empire building system is not helpful for the national system to improve and help the end users who need this support. We are happy by sitting on our chair. I am director of this institute. No one has to come and touch my domain. So that part actually would again require, so this society had to be, when we were not able to publish papers, scientists came and said, sir, हमारे पेपर कहीं publish ही नहीं होते, वो कहते ये तो collection किया है आपने, इसमें science ही नहीं है, तो हमने कहा कि चलो एक society भी बना दो. So this society is now organizing this kind of meeting to catalyze people, to see that in future more initiatives are there. So this society has done a lot. I don't want to go more in detail. There are publications outside. Maybe Dr. Our all leaders, Dr. Agarwal is here, was Vice President, Dr. Tyagi, Dr. Rana, Anuradha, Manjusha, they are all here. They should talk to all these young people and tell more about this society and its benefit, and they should participate in it. This is a source of information and knowledge which is so critical. So I don't have to tell about this first Congress. It was also mentioned that now Tyagi had mentioned that it has become a rolling event. We started it from India, but now it has become like Crop Science Congress, like Soil Science Congress. Every 4 years it is held from one country to another continent. We said genetic resources also are important. So let this also be a rolling event. And it has become a rolling event. So credit actually should go again to this society. And what happened? You bring all the best people, and like the seminar here, the purpose of seminar here is this we could have held in Delhi also. But bringing here means all you can be exposed to this kind of information and knowledge, which possibly otherwise not be there if it was held elsewhere. So International Congress, I can go and I have been participating, but all the time we thought we will like to organize all international congresses in India, whatever were there. And they had been organized quite regularly. So this was held, best people from all over the world came, talked, mentioned, told. Lot of, again, recommendations came. Delhi Declaration is globally now recognized. And again, it tells many of those things which I have already mentioned. So I don't want to go into this, but maybe PowerPoint can be circulated to those who are interested in it. And so all these details are there. And we also recommended that create one international agrobiodiversity fund for partnership, like the Gene Fund, which got created, but that is for genetic gene banks support. But gene bank support has not gone to the national system, unfortunately. It is again only supporting international gene banks. So national systems have not, we worked hard for it, convinced the donors, got that time about more than 150 million to begin with. I don't know how much it has. You were on their board, might have been 300 or 400 million now. But all that money is not available for national gene banks of the poor countries, for which we really created it. क्योंकि वो सारे जो वाइट लोग हैं वो बैठ गए और वो कहते हैं कि हमें सपोर्ट इस जीन बैंक से मिल रहा है, उनको हम क्यों मदद कर रहे हैं. So there are issues. Similarly, you need also to have this collaboration. UN must declare Year of Agrobiodiversity. But since our government had already sent a proposal for millets, so this is kept on hold. But this is already in Prime Minister's knowledge, and maybe after some time, this also can be. And Rolling Stone already has. These are publications. So finally, holistic PGR management would require a way forward. And this way forward has to be that we need to, in fact, have easy access to germplasm, evaluate them through networking, build through partnership, conserve them both in situ and ex situ. And ex situ, I think Dr. Rana will be making a presentation tomorrow. In situ presentation you will be making tomorrow. So those initiatives are required. We have to promote science, use science, and then incentives in the morning was mentioned. That you can't just tell that, without clothes, the lady in Odisha, that you live like this and this wild rice is for you and be happy. You just cannot do that. If you do that, then she's helping the nation to conserve that material, and then you must incentivize, and that incentive must go. If you do not do that, like, in case of those Gene Saviors Community Awards, you give them once award for 10 lakh and then they go, then what? You have to see that those gene banks and the communities are properly managed, their human resource is built, they are trained. Somebody said that there should be institution support, backstopping, then mentoring. So there are issues there which are very, very important. And for that, there is a role of those who are working in genetic resource program. And finally, I would like to end saying that research relating to or management of plant genetic resources is not for only your own sake, for your own benefit or for your own development, but it is for the society. So in your initiative, your effort, you must have your own targets of self achievements, but at the same time, you always must have the person at the other end who is at the receiving end to see that he is benefited through your initiatives and efforts. So these are the issues relating to genetic resource management. Thank you very much.
Uh, uh, please take your seats. So friends, now you can understand that why he is called the father of PGR, why he is called the doyen at international level for this PGR. So please give him a big hand. And standing ovation again, please. He is a man of great vision. आज हमने सिर्फ पीजीआर देखा है, लेकिन अगर आप देखें तो बहुत सारे डोमेन्स हैं. If you see the infrastructure at ICR, universities, if you see the bureaus which have been developed, जो अभी डॉक्टर साहब ने mention किए, like your fish genetic resources, like your microbial resources, insect resources. So you can see that how in the PGR, there was no gene bank when he took charge. Very small gene bank. I think it was just in a very, nobody was recognizing it. But during his very short period, I think 2.5 years, he just built, and that what we are today globally, we are the leader in gene bank. We are the leader in PGR, and that all started during his time. So thank you very much, sir, for this very excellent talk, touching each and every aspect. Whether it's a management, institutional access, benefit sharing, or the policy, every aspect he has covered very nicely. So I'm not the right person to summarize the talk given by such a great personality, and it's not good on my part. But I just want to say कि सर आज गुरु पर्व है और मेरे 3 गुरु यहाँ बैठे हुए हैं जो पीजीआर में जो कुछ है आज हम लोग पीजीआर में वो तीनों यहाँ उपस्थित हैं. डॉक्टर परोदा साहब हैं, डॉक्टर गौतम साहब हैं, उसके बाद डॉक्टर ढिल्लों साहब हैं. और उन तीनों गुरुओं का जो आज परिश्रम है, that all we can see. And सर मैं बस इतना कहना चाहूँगा, मेरे को कुछ थोड़ी सी रिस्पॉन्सिबिलिटी दी गई जो आपने सर इंडिकेट किया, इंटरनेशनल ट्रीटी ऑन प्लांट जेनेटिक रिसोर्सेस. After every 2 years, there is a governing body meeting, which is the highest body of that international body, in which there are about 150 members. In one of the GB, I took an agenda that this GB meeting should be held in India, which was accepted. And I think in a very big way, just to promote again, just to show the Indian dominance, this meeting was held in New Delhi in a very big way. And the government was generous enough to give a budget of 40 crores just to hold that meeting. आप लोग सोचेंगे 40 करोड़ की मीटिंग कराई इन लोगों ने. To have so many countries, to have their arrangement, logistics, to have all the arrangements, it was one of the most successful meetings. In that meeting, again, we took a decision. Again, I got a permission from the government. I again led the Indian delegation that the farmers' convention should be held in India. And this, sir, as you know, very successfully, that meeting again was held in India. Again, more than 50 countries, they participated, just to showcase that what is the importance of farmers' rights, which you indicated, whether it's UPOB or our PPFR authority. And then, sir, if you see the farmers' rights, I think we are again the world leaders. Again, thanks to you, sir, for visualizing this PPFR. Thanks to Dr. Gautam, who could take part in this initial draft of this. I know very well when I was working in NVPR, how Mr. Sahib Singh Verma, when he was the chief minister, he used to come because I think he was the chairman of that parliamentary committee. So how initially they could visualize that how we have to be the world leaders in this farmers' rights. And today we are taken as an example by many other countries कि अगर farmers' rights आपको बनाना है तो Indian legislation की copy आप करिए. Best, one of the best. And though there were many, you could have heard this Pepsi case, other case. A lot of now, a lot of awareness is there in the farmers, in the public, in the seed industry, and many companies that what is this importance of farmer rights. But to my dear students, I just want to say that there are a lot of issues. Just go through all those issues. Take the copy of this presentation. लाइक जैसे कि आप लोग रामायण पढ़ते हैं, महाभारत, ये आप गीता पढ़ते हैं, जितनी बार पढ़ते हैं उतनी बार आपको अलग अलग मीनिंग्स दिखाई देते हैं. आप उनकी स्लाइड्स को आप 10 बार, 20 बार, 25 बार पढ़ेंगे तो आपको आप नए नए मीनिंग्स आपको दिखाई देंगे उसमें. एक सर इशू जो अभी 3 GB तो मेरे को मालूम है कि जो इशू अभी रिजॉल्व नहीं हुआ है वो DSI वाला जो इशू है, डिजिटल सीक्वेंस इंफॉर्मेशन. फॉर माई स्टूडेंट कोलीग्स आई जस्ट वांट टू से, डॉक्टर साहब ने अभी टच किया द एक्सेस एंड बेनिफिट शेयरिंग इशू, लेकिन डिजिटल सीक्वेंस इंफॉर्मेशन में ये है कि the physically material is not being transferred, only information which we are keeping in the public domain that is being transferred. So what are those access issues? इसको सर हमने 2019 में जब डिस्कस किया, वहां भी there was a, because in ITP you know there is a veto power. When we took an agenda कि this list should be enhanced from 64 crops in Annex 1. So in ITP there is no consensus based thing. So even if one country says, no, I don't agree, then the whole agenda is dropped. So 2-3 times they didn't agree to expand this list. And that was very unfortunate. And again, every time when the Indian delegation is going, it is on the agenda items that we will put up this agenda, that the list should be enhanced from 64 to include much more crops which are of the Indian interest. But somehow it could not be done. For DSI, we have the government has made a committee. A lot of interactions happened with the seed industry, with the National Biodiversity Authority, all relevant stakeholders. But again, I think I don't know the latest happenings, but in this month itself, there is a GB meeting happening at Rome. So what decisions they have taken, but I'm very sure that no final decision has been taken, because the developed countries, they are not in the favor of giving any benefit, or they want to have their own terms and conditions for this benefit sharing on this digital information sequences. If they exchange some information, they don't want to share the benefits on that. Sir, क्योंकि time बहुत हो गया and people are waiting for this, so I'll not take much time to summarize a talk which is very elaborate. So I would just like to thank you profusely, sir. And it's really a pleasure for me to chair a session of जो महागुरु हैं, जिनको कहते हैं गुरुओं के गुरु, महागुरु. और आज इतने सुंदर दिन पर, गुरु पर्व के दिन पर इस तरह का एक मौका मिला हमें, तो इससे बड़ी बात कुछ नहीं हो सकती है. There cannot be any better occasion for this. So I really salute to your vision, and still you are continuing that vision, you are continuing that support, not only in the field of, as I told, in the PGR, but recently he had a very excellent meeting for providing a vision for the agriculture education. He's providing a lot of support, vision for, you talk for any subject, for achieving sustainable development goals. He had a very big meeting, brainstorming session. You talk for any other field, you will find that task which he's heading is always having some brainstorming sessions on those topics. And that one example we have seen today, how deeply he goes into every subject, how concerned he is about all those things. So again, sir, I would like everybody to. So, sir, again, we want to give a big hand for this great vision. Thank you. And I want to thank my co-chair, Dr. Tyagi, and both the conveners. Thank you.
Good evening, everybody. Much has been said about the last lecture, which of course is going to have a lasting impression on all of us. But we would just take a few minutes to felicitate the speaker and the dignitaries on the dais. May I request Dr. B.S. Dhillon to please step up and felicitate our dignitaries. Dr. J.K. Sharma, Vice Chancellor, Badi University, Badi Solan, for convening the session very efficiently. And Dr. And also Dr. Y.S. Negi, who, for the sake of saving time, has not given his formal vote of thanks. But we thank the speaker immensely, as has been already mentioned. I request Dr. P.K. Khosla, is he? Yes, Professor P.K. Khosla to please come up on stage and facilitate the chairs of this session. Dr. R.K. Tyagi, Vice President of ISPGR, and Dr. R.C. Agarwal, Deputy Director General, Agriculture Education, ICAR. Thank you, chairs. Finally, I request Dr. P.L. Gautam to please step up on stage and felicitate the speaker of the evening and the speaker of the seminar, Padma Bhushan Dr. R.S. Paroda. Let's give a big round of applause for Thank you, Dr. Khosla. And Dr. P.L. Gautam to step up, please, and heartily felicitate Dr. R.S. Paroda. Ladies and gentlemen, a big round of applause. As is often said, behind every successful woman, man is a woman who believes in him. So we are very, very grateful and privileged to have amongst us Dr. Mrs. Shashi Paroda, who deserves equal applaud for her immense support in the excellent journey of Dr. R.S. Paroda. Ma'am, please step forward, and I request Dr. Manjusha Verma to step up, Joint Secretary of ISPGR, to facilitate Dr. Mrs. Shashi Paroda. She is not only the woman who is behind, sir, but she has also been helping the society in her own way through education and many diverse social activities. Thank you, ladies and gentlemen, and we must have a group photograph of the moment. And with this, we close today's session, technical sessions, and I request all of you to join us. Okay, I will request the rapporteurs to also please step up to take their momentum, and they can take the momentum from Dr. Gautam again. Dr. Lokendra Kumar, Assistant Professor, Department of Biotechnology, and Dr. Anil Kumar from ICR DMR. So my omission, the rapporteurs were left behind. Boys and girls from the Shoolini University, thank you for coming and joining us. Your curfew for tonight, hostel tonight, has been postponed, so don't worry about going late. You can thank your faculty and DSW for that. We will join for the cultural program in the theater downstairs, open theater, followed by dinner in the Shamiana. So let us all meet over there.